Welcome to the world of data analytics, where data holds the key to unlocking success in the corporate realm. In this comprehensive video course, we will take you on a transformative journey, empowering you with the knowledge and skills to harness the immense power of data analytics tools. Whether you are a data professional seeking to make data-driven decisions, or an aspiring analyst eager to dive into the world of data, this course is your gateway to becoming a master of data analytics tools. Together, we will navigate through a vast landscape of cutting-edge tools, exploring their capabilities and functionalities. We will delve into popular platforms like Excel, Numpy, Pandas, Tableau, Power BI, and SQL, unveiling their hidden gems and advanced features. Towards the end of this video, we would also be covering the popular data analytics bootcamps and frequently asked interview questions to keep you on the safer side of your upcoming interviews. But that's not all. We will go beyond the basics, immersing ourselves in data visualization, statistical analysis, predictive modeling, and data storytelling. We will uncover the secrets to extracting actionable insights from complex datasets, transforming raw numbers into strategic advantages. Are you ready to unleash the power of data and revolutionize your business strategies? Join us on this exhilarating journey as we demonstrate.
I will run you through the top 6 data analytics job roles. So before I dive deep into the various job roles, let's quickly understand how important a career in data analytics is and what the future holds for professionals in this domain. Let's take a look at the growth of data. So back in the early 2000s, there was relatively less data generated. But with the rapid rise in technologies and with the increase in the number of various social media platforms and multinational companies across the globe, the generation of data has increased by leaps and bounds. Did you know that according to the IDC, the total volume of data is expected to reach 175 zettabytes in 2025? Now that's a lot of data. Let's take a look at how organizations leverage all of this data. As you know, there are zillions of companies across the world. These companies generate loads of data on a daily basis. When I say data here, it simply refers to business information, customer data, customer feedback, product innovations, sales reports, and profit loss reports, to name a few. Companies utilize all of this data in a wise way. They use all of this information to make crucial decisions that can either hamper or boost their businesses. You might have heard of the term data is the new oil. Well, it definitely is, but only if organizations analyze all the available data very well, then this oil is definitely valuable. And for that, we have data analytics. Organizations take the help of data analytics to convert the available raw data into meaningful insights. So what is data analytics? Technically, you can say it is a process wherein data is collected from various sources, then cleaned, which involves removing irrelevant information, and then finally transformed into some meaningful information that can be interpreted by humans. Various technologies, tools, and frameworks are used in the analysis process. As you might have heard of the term data never sleeps. Well, it surely doesn't. Every millisecond, some or the other data is generated, and this is a constant process. This process is only going to increase in the near future with the advent of newer technologies. The data analytics domain holds paramount importance in every sector. Companies want to leverage on all the generated big data and boost their businesses. They need professionals who can play with data and convert them into crucial insights. Organizations are constantly on the lookout for such candidates, and this opportunity will only increase as data is only going to grow every second. So if you want to start your career in this field, or if you want to switch your job role into a role in the data analytics domain, then we have a set of job profiles that you can look at. We will look into 6 job roles in the data analytics field and learn what each job role is all about, the responsibilities of a professional working in that particular role, the skills required to get that particular job, the average annual salary of a professional working in that role, and finally the companies hiring for that role. So let's start off. First, we have the job role of a data analyst. A data analyst is a person who collects, processes, and performs statistical analysis of large data sets. Every business generates and collects data, be it marketing research, sales figures, logistics, or transportation costs. A data analyst will take this data and figure out a variety of measures, such as how to price new materials, how to reduce transportation costs, or how to deal with issues that cost the company money. They deal with data handling, data modeling, and reporting. Now, talking about their responsibilities, data analysts recognize and understand the organization's goal. They collaborate with different team members such as programmers, business analysts, engineers, and data scientists to identify opportunities for solving business problems. Data analysts write complex SQL queries, scripts, and store procedures to gather and extract information from multiple databases. They filter and clean data using different modern tools and techniques and make it ready for analysis. They also perform data mining from primary and secondary data sources. Data analysts identify, analyze, and interpret trends in complex data sets. This is done using statistical tools such as R and SAS. Another key responsibility of a data analyst is to create summary reports and build various data visualizations for decision making and presenting it to the stakeholders. Next, let us discuss the important skills that you need to know to become a data analyst. Firstly, you should have a bachelor's degree in computer science or information technology. A master's degree in computer applications or statistics is also preferable. You must have a good understanding of programming languages like R, Python, JavaScript, and also understand SQL. In addition to that, it is beneficial if you have hands-on experience with statistical and data analytics tools such as SAS Miner, Microsoft Excel, and SSAS. Basic understanding of machine learning and its algorithms would be an advantage. Acquaint yourself with descriptive, predictive, prescriptive, and inferential statistics. Most importantly, you need to have a good working knowledge of various data visualization software along with presentation skills. This will help you pitch in your ideas and viewpoints to the clients and stakeholders better. Now, talking about their salaries, a data analyst earns nearly 5,23,000 rupees per annum in India, while in the United States they earn around $62,453 per annum. Let's now look at a few of the companies hiring data analysts. So as you can see, we have the American e-commerce giant Amazon, then we have Microsoft, the American online payment company PayPal, then we have Walmart, Bloomberg, and Capital One. So that was all about data analyst. The next job role is of a business analyst. Business analysts help guide businesses in improving products, services, and software through data-driven solutions. They are responsible for bridging the gap between IT and business using data analytics to evaluate processes, determine requirements, and deliver data-driven recommendations and reports to executives and stakeholders. Business analysts are responsible for creating new models that support business decisions and come up with initiatives and strategies to optimize costs. Now let us look at the various responsibilities of a business analyst. Business analysts have a good understanding of the requirements for business. Their vital role is to work in accordance with relevant project stakeholders to understand their requirements and translate them into details which the developers can understand. They frequently interact with developers and come up with a plan to design the layout of a software application. They also run meetings with stakeholders and other authorities. They engage with business leaders and users to understand how data-driven changes to products, services, software, and hardware can improve efficiencies and add value. They ensure that the project is running smoothly as per the requirements and the design planned through user acceptance and validation testing. They make sure all the features are being incorporated into the application. BAs rely on different software to write documentation and design visualization to explain all the findings. It is extremely critical for any BA to effectively document the findings where each requirement of the client is mentioned in detail. Now let us look at the skills required for a BA. A bachelor's degree in the field of science, engineering, or statistics or any related domain will suffice. Knowledge of programming languages such as Python and Java is beneficial. You should be really good at writing complex SQL queries, and you should also have knowledge of various business process models. Along with knowledge of programming languages, ideas about statistical analysis and predictive modeling is necessary. Decision-making, strong analytical and problem-solving skills are necessary to solve software and business issues. You also need to have excellent presentation and communication skills, both oral and written. Moving on to their salary, a business analyst is expected to earn around 7 lakh rupees per annum in India. In the US, they earn nearly $68,346 per annum. IQVIA, Dell, Philips, Honeywell, the famous American messaging platform WhatsApp, the UK-based company Ernst & Young are few of the companies hiring for business analysts. Up next, we have the job role of a database administrator. A database administrator is a specialized computer systems administrator who maintains a successful database environment by directing or performing all related activities to keep the organization's data secure. They are responsible for storing, organizing, and retrieving data from several databases and data warehouses. Their top responsibility is to maintain data integrity. This means that database administrator will ensure that the data is secure from unauthorized access. Moving on to their responsibilities. A database administrator develops, designs, and maintains a database to ensure that the data in it is properly stored, organized, and managed well. They maintain data integrity by avoiding unauthorized access, and they keep databases up to date. They run tests and modify the existing databases to ensure that they operate reliably. They also inform end users of changes in databases and train them to utilize systems. They need to cooperate with programmers, data analysts, and the IT staffs to ensure smooth running and maintenance of databases. Database administrators are responsible for taking system backups in case of power outages and other disasters. So they should have an efficient disaster recovery plan. Now let's have a look at their skills. To become a database administrator, you should have a bachelor's degree in computer science or information technology. Knowledge of programming languages such as Python, Java, and Scala is important. You need to carry at least 3 to 5 years of experience in data management. You need to have an understanding of different databases such as Oracle DB, MongoDB, MySQL Server, and PostgreSQL. Also, they should have an idea about database design and writing SQL queries. Finally, you need to have a good understanding of operating systems such as Windows, Mac OS, and Linux, along with storage technologies. Talking about their salary, a database administrator in India can earn up to 4,97,000 rupees per annum. In the US, they earn around $78,000 per annum. Let's have a look at the companies hiring for database administrators. So as you see, here we have BookMyShow, Oracle, the American MNC Intel, Amazon, Robert Half, and the New York Times, to name a few. Fourth in the list of job roles, we have data engineer. A data engineer is someone who's involved in preparing data for analytical and operational uses. A data engineer transforms data into useful format for analysis. They build and test scalable big data ecosystems for businesses. A data engineer is an intermediary between a data analyst and a data scientist. Now let's jump into their responsibilities. Data engineers develop, test, and maintain architectures. They are responsible for managing, optimizing, and monitoring data retrieval, storage, and distribution throughout the organization. They discover opportunities for data acquisition, find trends in datasets, and develop algorithms to help make raw data more useful to the enterprise. Data engineers build large data warehouses using ETL for storing and retrieving data. They also recommend ways to improve data quality and efficiency, along with building algorithms to help give easier access to raw data. Data engineers often work with big data and submit their reports to data scientists for analysis purpose. They need to recommend and sometimes implement ways to improve data reliability, efficiency, and quality. Moving on to the skills of a data engineer. A data engineer should hold a bachelor's degree in computer science or information technology. They should have good hands-on experience with Python, R, and Java. Also, data engineers should be well versed with big data technologies such as Hadoop, Apache Spark, Scala, Cassandra, and MongoDB. Data warehousing and ETL experience are essential to this position along with in-depth knowledge of SQL and other database solutions. Basic knowledge of statistical analysis will be an advantage along with idea about operating systems. Here is what a data engineer can earn. So in India, a data engineer can earn up to 8,85,000 rupees per annum, while they can earn around $103,000 a year in the USA. We have Capgemini, Shutterstock, the American provider of stock photography, Spotify, Accenture, Genpact, and Facebook hiring data engineers. The next exciting job role is of a data scientist. A data scientist is a professional who uses statistical methods, data analysis techniques, machine learning, and related concepts in order to understand and analyze data to draw business conclusions. They make sense to messy and unstructured data and bring value out of it. They employ techniques and theories drawn from many fields within the context of mathematics, statistics, computer science, and information science. A data scientist understands the challenges in business and comes up with the best solutions using modern tools and techniques to analyze, visualize, and build prediction models to make business decisions. Let us now look at their responsibilities in the industries. Data scientists clean, process, and manipulate data using several data analytics tools. They perform ad hoc data mining, collect large sets of structured and unstructured data from disparate sources. They design and evaluate advanced statistical models to work on big data. They also create automated anomaly detection systems and keep constant track of their performance. Data scientists interpret the analysis of big data to discover solutions and opportunities. A data scientist takes input from data analysts and engineers to formulate the results. They use visualization packages and tools to create reports and dashboards for relevant stakeholders. They also adopt new business models and approaches. Apart from this, they regularly build predictive models and machine learning algorithms. Now moving on to the skills of a data scientist. A bachelor's degree in computer science or information technology will be fine. But a master's degree in the field of data science will hold a major advantage. You also need to have a good experience in the analytics domain. You should be proficient in programming languages such as Python, Java, and C++. Knowledge of Perl will also be an advantage. Familiarity with Apache Hive, Pig, and Apache Spark is necessary along with the knowledge of Hadoop. In addition to knowing programming languages, you also need to know SQL, machine learning, and deep learning. Data visualization and BI skills are necessary for creating reports and dashboards. You should also be able to communicate and present information and ideas properly. Now talking about their salary, a data scientist in India can expect an annual salary of 10,47,000 rupees per year. Meanwhile, in the US, they can earn up to $113,000 per annum. That's a lot of money. From the many companies hiring for data scientists, here we have a few companies named. They are yet again Amazon, Citibank, Apple, Google, the Japanese electronic commerce and online retailing company Rakuten, and Facebook. And finally, we have machine learning engineer. Machine learning engineers are professionals who develop intelligent machines that can learn from vast amounts of data and apply knowledge without human intervention. They use different algorithms and statistical modeling to make sense of data. They design and develop machine learning and deep learning algorithms. Their main goal is to create self-running software. Let's have a look at the responsibilities of a machine learning engineer. Machine learning engineers research, design, and develop machine learning systems. They use exceptional mathematical skills in order to perform faster computations and work with algorithms to create sophisticated models. They perform A/B testing and use data modeling to fine-tune the results. They use data modeling and evaluation strategy to find hidden patterns and predict unseen instances. Machine learning engineers work closely with data engineers to build data pipelines and interact with stakeholders to get a clarity on the requirements. Most importantly, they analyze complex data sets to verify data quality, perform model tests and experiments, choose to implement the right machine learning algorithm, and select the right training data sets. Moving on to their skills. A machine learning engineer should have a degree in computer science and information technology. They should have an advanced degree in computer science or maths. In addition to this, they should also have experience in the same domain. They should be proficient in programming languages such as Python, R, C++, and Java. Knowledge of statistics, probability, and linear algebra is necessary as all the machine learning algorithms have been derived from mathematics. Also, having an idea of signal processing would be beneficial. Machine learning engineers need to have a good understanding of data manipulation and machine learning libraries such as Numpy, Pandas, scikit-learn, etc. They should have good oral and written communication skills. Let us now have a look at their salary structure. A machine learning engineer earns 8 lakh rupees per annum in India, while in the US they can earn around $114,000 a year. Now that's a whopping amount, isn't it? Let's have a look at the companies hiring machine learning engineers. So as you see, we have Amazon, Microsoft, Oracle, Salesforce, Rapido, and Accenture to name a few. That was all about the job role of a machine learning engineer.
A study from New Vantage Partners suggests 97.2% of companies are now investing in data and its analysis. Nowadays, every company needs a data expert. Do you also want to become a part of this market? If yes, how to become a part of it? What are the essential skills one should have? This video will answer all these questions. But before watching this video, please subscribe to Simplilearn's YouTube channel and press the bell icon to never miss any updates. First of all, we are going to discuss who is a data analyst, working of a data analyst, skills required to become a data analyst, tools required, and companies hiring. And finally, we are going to discuss about salary of a data analyst. Let me tell you how Simplilearn can help you in your journey to become a data analyst. Check out the course on data analytics in collaboration with IBM with real-time project and business case studies. You will learn tools like SciPy, Pandas, and programming languages like Python or R too. Enroll now. Link is in the description box below. Question for you. Which one of the following is not a Python library for visualization? Matplotlib, SciPy, Pandas, Jupyter Notebook. Please leave the answer in the comment section below. Moving on, who is a data analyst? A data analyst collects, analyzes, and interprets data. A data analyst will convert raw data into useful information. Data analysts are in high demand because every industry uses data analysis. Work of a data analyst. As a data analyst, you will work closely with the raw data and generate valuable insights to help companies decide their future goal. If you like thinking out of the box, you are the perfect fit for this domain. Data analysts help maximize output when it comes to generating revenue, working closely with both business and data. Nevertheless, this field boasts handsome salaries for all levels of expertise. Can you become a data analyst without prior experience? Yes, anyone can become a data analyst if they enjoy solving real-world problems, have a strong background in statistics, and have a creative mind. If you feel you don't have it, you can definitely develop it. So let us know the skills in detail. What are the basic skill sets required for a data analyst? Data analyst must know basic mathematics and statistics, programming skills, machine learning, and also data visualization tools. So let us know what are the basics that you need to learn as a data analyst. Mathematics. It is always better to know basic mathematics like linear algebra and probability fundamentals. Linear algebra is used in data pre-processing and transformation, which is the critical process of every data analyst. Statistics, a branch of mathematics that deals with collection, analysis, presentation, and implementation. Probability We know that probability is the study of how likely something will happen, which is essential for concluding. Both probability and statistics are the backbones of data analysis. It is feasible to become a data analyst with only a basic understanding of these three areas of mathematics. But in order to remain relevant and grow as a data analyst, one's mathematical knowledge should not be restricted. Compulsorily use some of the tools as a data analyst. What are that? First is Microsoft Excel. It is the most well-known spreadsheet software in the world. It also has computation and graphing features that are excellent for data analysts. No matter your area of expertise or additional software you might want, Excel is a standard in the industry. Its useful built-in features include form design tools and pivot table. It also generates a wide range of additional features that help simplify data manipulation. As a programming language, every data analyst should know Python. It is easy to learn and has a simple syntax. Python is quite adaptable and includes a vast variety of resource libraries that are appropriate for a wide range of diverse data analytics activities. These libraries help in numerical and data computation. The Pandas and Numpy libraries, for instance, are excellent for supporting standard data processing and streamlining highly computational operations. You can also choose between Python or R. R is a well-known open source programming language much like Python. Data visualization tool. As we previously mentioned, data visualization tool is also necessary to become a data analyst. Power BI is a user-friendly interface, makes building interactive visual reports and dashboards simple. Its most vital selling point is its superb data integration. It works flawlessly with cloud sources like Google and Facebook Analytics, as well as text files, SQL servers, and Excel. Tableau is one of the best commercial data analysis tool available. It handles huge amounts of data better than many other BI tools and is effortless. It has a visual drag and drop interface. However, because it has no scripting layer, there is a limit to what Tableau can do. For example, it could be better for pre-processing data or building more complex calculations. You might have heard about MySQL a lot of time. It is a standard language for interacting with databases, and it is very helpful when working with structured data. SQL creates user-friendly dashboards that may present in various data ways since it is so simple to send complex commands to databases and change data in seconds. It has commands like add, edit, delete data. In addition, SQL is an excellent tool for creating data warehouses because of its simplicity, clarity, and interactivity. Overall, I would suggest that to become a data analyst, you should work on programming languages like Python or R plus MySQL to work on databases, adding to that Excel plus visualization tools like Tableau or Power BI. You now know what are the skills are and how it is used. What are you up to in an organization as a data analyst? To create and evaluate the report using automated tools like Tableau or Power BI. To troubleshoot the reporting database environment and reports. Data analyst, you will use statistical method to analyze data sets and spot any valuable trends that may develop over time. Evaluate companies' functional and non-functional requirements. Data analyst assess data warehousing in inspecting and reporting needs. These are all the responsibility of a data analyst in an organization. Coming to companies hiring a data analyst. IBM, Accenture, Capgemini, TCS, Facebook, Amazon, Flipkart, Meta. These are the top companies hiring a data analyst. But data suggests that every small and medium-sized company needs a data analyst. Therefore, demand of a data analyst is in every company. So, there is no need to worry. Job and salary of a data analyst. This is the final part. The salary of a data analyst is high all over the world. When it comes to the USA, the average salary for a data analyst as a beginner is going as high as $70,000 plus per annum. For experienced professional, it is going as high as $120,000 per annum. In India, for a fresher, it is going as high as 8 lakh per annum, and for experienced professionals, it is 20 lakh plus per annum.
Welcome to this tutorial on Microsoft Excel. So we will learn about functions and formulas. We will learn about conditional formatting, data validation, pivot chart, and pivot table. Now let's look at a scenario here. So one day in a startup, one professional speaks that their business is growing and they would need an efficient way to work with the data. They would have to find a way to work faster with storing and analyzing data. Now, to that, another colleague responds, well, we can make use of Microsoft Excel to do this job. The question is, will Excel be able to cater to their business needs? Now, the colleague responds, well, we can make use of Excel in several ways, and it also is a cost efficient option. Now, in that case, the colleague who posed the question says, let's go ahead with Excel and let's train our employees in Excel. And the suggestion is welcomed, which would make the job easier for them. And they would basically decide on using Excel. So they decide on taking a training right away and basically starting to learn Excel. Now, before we move to Excel, one of the question is, why should we use Excel? So let's look at some of the points here. So Excel proves to be a great platform to perform various mathematical calculation on large data sets, which is one of the biggest requirements of various organizations these days. Various features in Excel like searching, sorting, filtering makes it easier for you to play with the data. And Excel also allows you to beautify your data and present it in the form of charts, tables, and data bars. Now, when it comes to reporting, accounting, and analysis can be performed with the help of Excel. It can help you with your task lists, your calendars, and goal planning worksheets. Excel also provides good security for your data. Excel files have the feature of password protection. This way, your information can be safe. Now, when we talk about what is Excel and how it can be used, so Excel, or you might have heard as spreadsheet, can be basically used for a lot of different tasks than just storing the information in so-called tabular format. Now, Microsoft Excel is an application that is used for recording, analyzing, and visualizing data. It is in the form of a spreadsheet. Let's have a look at few of the functions and formulas used in Excel. And before we do that, we can also quickly take a small tour to understand how to work with Excel. Now, to do that, what we can do is we can type in our search, say for example Excel, and just select your Excel app which is installed. And here you see you have a lot of options which says take a tour, drop down list, get started with formulas, make your pivot table, going forward with pie charts, and much more. So we can click on this one which says take a tour, and that basically pops up a window which says welcome to Excel. And if you have always wanted to be better at Excel, you have this which can help you. So let's click on create, and that takes us to the store window. Now that says instructions for screen readers, which basically talks about 10 different steps in which we can learn Excel and using the spreadsheet app. So there are more than 11 sheets which we see here at the bottom end, and each one gives us a simple example which we can work on. So for example, if I click on add, now that takes me to this page which says how do we add numbers. Now you might be provided data which we can upload by loading a file from our machine, or getting data from a web source, or even connecting to a database. So there are various options which we will see in some time. So here we have an option which is called data. You can click on this one, and this basically has options where you can use existing connections. If you have created some, you can always click on from other sources, and you can get your data from SQL Server, from analysis services, from OData data feed. You can get in from XML, from data connection wizard, or also from Microsoft Query. You can be running in different queries here, which shows up in the option which says new query. There are connections which you can use, and that basically will display all the connections for this particular workbook, which we do not have as of now, but we can create them. But let's look at simple examples. Now you can follow these instructions here, which says basically adding up the numbers, and that could be easily done by just placing your cursor here. And what you could do is either you can type in the formula, that is from which row to which row you would want to add the data. So for example, I could just do a sum here, and that shows up all the different functions which are available. Then we can open up a parenthesis, and we can say I would be interested in totaling the amount from column D, and I would select, for example, D4. So I could be doing this, and then I could say D4 onwards till D7. So that's the data which I'm interested in. You can close your parenthesis and hit enter, and that gives you the total. There is also a shortcut for this, which you can always do, is we can first delete this, and you can just place your cursor here and just use your Alt and equals. That automatically selects the numericals, which we can anytime expand or basically collapse. So I will basically select this, which says this function needs two numbers, which is number 1 and number 2, and then you can hit on enter, and that gives you the total. So similarly, we can be getting in the data here by selecting all the fields. So here it also says that you can use a shortcut. Now what we can also do is we can add numbers over 50 by selecting the yellow cell here and then giving a condition such as, so I can basically use something like sum if, and then open a parenthesis. I can select I would be interested in this row, and then I can even drag and drop till here. So that tells me D11 to D15. You can then put in a comma here, and you can give your condition. Say for example, we would say I would be interested in numbers only above 50, and we can select this, close your quotes, and then just close your parenthesis, and that's your formula. So you can do this, and that basically gives me the total is 100. Now similarly, we could do that for the amount here. I could select this. Now there is also an option, I can click on home, and I can go for something like auto sum. So that's one more way of doing it, which anyways says sum is alt plus equals. So it automatically adds up your values, and I can try doing a auto sum that automatically selects my rows, and then I can get my total. Now as per this activity here, it says try adding another sum if formula here, but add amounts that are less than 100, and the result should be 160. So what we can do is we can basically select all the numbers which are lesser than 100. So the way we did earlier here, there can be always a shortcut. So you can always, for example, if you would want to avoid typing in the formula, you can always copy it from here and then just hit on enter. So you are back into this cell, and then I can basically go here and paste the number, and then as per the requirement, we are required to select anything which is lesser than 100. So what I could do is I could select here, I could say let's say G, and then I can change this value to G15, and that's one more way. Now we see our selected rows have been changed, so I can hit on enter, and I can check what is the result. So we would be interested in looking for numbers which are lesser than 100. So I will have to also change this one to a lesser sign, and that basically gives me the total, which is 160. So that's how you can simply add numbers. You can use auto sum, you can type in the formula, you can select the fields, or you can just place your cursor where you would be looking for a sum, and then you can just do a alt equals, and that basically populates the sum. Now let's look at some easy options of filling your cells or automatically populating the values in your cells within your Excel sheet. Now here we have an option which says 100. Now we can click on this, and that basically says it is making a sum of column C4 to D4. So if I click on this one, I can check that this is row number 4, which shows up here, and I also know this is column C. I also have D, so this equals is basically giving me a sum of C4 to D4. Now what we can do is we can always place our cursor here at the right corner, and then we can just drag and drop, and this basically gives me a total of all the numbers for all different rows. So this is one shortcut which we can do to get the total. Excel will automatically give the totals, which we call as filling down. Now what we can do is, in the same way, if we would want to get the totals here, we can first check what is this 200, and this tells me it is C11 to C14 total. So it is totaling the rows from C11, so column C and 11th row, till 14th row, and that's the sum. Now what I can also do is I can similarly, like above, we can do a filling right, which basically means bringing your cursor here and then just dragging and dropping it all the way where you would need the totals, and this basically gives me the total. There is one more quick way to check if this is right. So the easiest option would be to select this cell. Now what I can also do is I can just select all of these fields by just highlighting and selecting all the fields. Once it is selected, press on Control R, and that gives you the total. Now if we would be doing this top down, then I could select all these rows for this particular column, and then I could do a Control D. So that's your filling down, and this one was filling right. So this is an easier option of doing a fill when you would want to have the formula applied to every row as it occurs in the first row or the last row. We could test this by, for example, selecting these fields. I could delete them, and I have here which says 130. I could just place my cursor here and I could drag it all the way up, and that should also do the same magic which we were seeing from top down. So this is a simple way wherein you can fill up your cells, and you can also automatically propagate or move your computation to all the cells. Let's look at the split option, which basically helps us in splitting the data when we have some kind of pattern or when we have some kind of delimiters in our data in, say, one particular column, and we would want to derive the values out of it. So we can always use the splitting option. Now the easiest option would be, so for example, we have our email column which has the email IDs, and which we can clearly see has a first name dot last name. Now I see that there is a last name Smith filled up here, first name is empty. So what I can also do is I can just type in, say, Nancy here. Now that's the first name. I can again start typing the second name, and as soon as you do that, you would see a faded list of numbers, and that's your clue to hit enter. And once you do that, you would see all the first names have been filled in here. If you would want to maintain the case sensitiveness, you can just go ahead and delete these, and let's type in as it occurs. So let's say Nancy as the first name. Go down to the next cell and just type in Andy, and there is your grade list. So just hit on enter, and that basically fills up your first name. What we can also do is we can just select this particular field, and either we can type in Control E, which basically fills up all the options. Now I can just do a undo by typing in or clicking Control Z, and that's basically gone. What I can also do is I can select a particular field, and then I can go into home option, and under home you have an option here which says fill. So you can select this, and then you can do a flash fill, which is what we are doing here. So click on flash fill, and that automatically fills up the values. So in this way you can work within your spreadsheet, and you can be filling up the values where a delimiter by default is understood, and we can split the data. Now, however, sometimes you might have some data which has a different kind of delimiter, and there is again a smarter way of splitting your data. So you can always scroll down here, and that says splitting a column based on delimiters. So we have some values in the data column, and these values in each row are separated by comma. So select this. Your data is already selected. Text to columns, delimited, comma is selected, and now click on next. So it basically says what is the destination. Let's select this one, and I can choose what would you want to have. So that shows me this would be my data preview. Now I can basically select this one. I can say finish and say OK. And now if you see, our data has been placed in the columns appropriately. So this is how you can split your data based on a delimiter and then organize your data in a better way. Now there are some advanced options which we can learn later, but this basically tells about using a formula. So this is something, if we have some name in one cell, and if you would want to split it into first name, your helper column, your middle name, last name, so that can also be done using formulas. And this basically tells how would you extract characters from your left cell and how would you place them in your right cell. So you can try this activity, which is a little more of advanced option. The benefit is that you can always use this, wherein if you do some kind of transformation using your formulas, if your original data gets updated, then the split data will also get updated. And that's the benefit of using formulas, where you can place values from one cell into multiple cells based on execution of your details in the formulas. How about using the transpose option? Now, you might have heard of situations where you would want to switch or turn your rows into columns and your columns into rows, and that's where transposing comes into picture. It might be useful when you have your data in your X and Y axis, or as I would say, in rows and columns, and you would want to switch your rows to become the columns and columns to become your rows. So what we can do is, the simplest way is you can select all your values. So here we basically have 6 columns and I would say 2 rows. Now I can select all of these, and then I can select an empty field. For example, the one which is highlighted here. Well, you can always do a Control Alt V. That's a shortcut. What you can also do is, once you have selected all your fields, you can just copy them. So just do a Control C and then click on an empty cell, and then what you can do is you can do a special paste or paste special. So under your home you have the paste option, and here you can go for paste special. And once you do that, you need to select the transpose option over here and click on OK. And now you will see that the columns and the rows have been transposed. So your row name was item, and that has become the column heading. You had row name as amount, and that has become the column heading, and all your values have been transposed in this particular format. Now there is another way of doing that, and again that's using your formulas. So what you can do is you can transpose with a formula also, and that basically works when you have similar kind of data. So this has 6 columns and basically 2 rows. So you can basically do this. So you can select this, and earlier we were doing a copy, but now what we would want to do is we would want to just look at the row numbers, which tells me it is C33, C34, and it starts with C and ends in with your H column. So what we can do is we know that we have 6 columns and 2 rows. So transposing that would actually give me 2 columns and 6 rows. So what we can do is we can select 2 columns and 6 rows in our Excel sheet. I can then basically start typing in the message, or I can just go to the address bar, and here I can say transpose. Let's go for C33, H34. It basically selects my data, and now I can just do a Control Shift and enter, and now if you see, all the values have been populated. Now you can just place your cursor in one of the cells, but if you see the address bar, the formula remains the same. This is because this is an array formula. So we can read more about an array formula here. It's basically something which performs calculations on more than one cell in an array. And in the example here, the array is the original data, that is C33 to H34. So your transpose is just changing the horizontal orientation to the vertical orientation. So this is a very simple way in which you can basically use the Excel's capability to transpose your data and convert your rows into columns and columns into rows. Apart from working on additions, subtractions, filling up your data, sorting the data, or basically splitting your data, transposing your data, one of the other requirements is sorting and filtering your data. Now that can be very handy when you're working on huge data and you would want to sort it in a particular order, say ascending or descending, or might be based on a particular field, or if that field was, or if the cell was highlighted with a particular color, sorting the data. So let's look at how Excel can be used for sorting and filtering. Examples are pretty simple here. So let's check that. So if we go into sort and filter and say this is the data I have, say for example, I would want to sort the values in the department column alphabetically. So what I can do is I can select department column, and I'm already in the home tab. I can straight away go here which says sort and filter. I can then say sort A to Z, and that's basically alphabetically sorting your department column. And once I do this, you would see the data has been sorted, but it's not just this data. We can just do a Control Z and check what are the values we have. So here we have meat, which is beef, and 90,000, 110,000, the values. Then you have bakery, which should ideally be the first row if we sort it in an alphabetical order, which goes with bakery as desserts. You have the values, so we can check this again. So select department and then just do a sort and filter, and let's say sort A to Z. And if you see, the data has changed, but it's not just changing your first column, but then it has taken care of all the data. However, the data has been sorted based on the department column. So you have bakery, which aligns with desserts, which has the values, and now we have all the data which has been filtered. Now what we can also do is we can sort December's amounts from largest to smallest. So what we can do is we can basically click any cell in the December column, let's say 20,000, and then what I can do is I can go into sort filter, and then I can say sort largest to smallest. So if you see, bakery breads is the row which has the smallest data, or might be you have deli sandwiches, so that one looks also smaller. So let's do a larger to smallest, and if I do this, you would see the values have been shifted now. So it is no more based on the department column, because now the data is being sorted based on the values in the December column. And you see bakery, which was alphabetically the first one, has become second last. So either you can sort the data based on a department column, which goes based on the values. These are all string values or words. So it sorts alphabetically. If you have numbers, might be you can give some values and you can sort the data. You could anytime do a custom sort, and you could basically select if you would want to select the data. So I could do a custom sort, and then I could choose which is the column which we would want to use for sorting, what is the sorting needs to be done, is it cell values, is it cell color, font color, conditional formatting, and then you can also choose the order. So that's one more way to do that. Now, if you scroll down, that also shows how you can sort by date or a color. So for example, if you would want to sort based on the expense date, so there are different options. So what I can do is I can select this date field. I can just do a right click. I can go into sort, and then I can choose. I would want to sort oldest to newest. So since I selected the date field, it basically has sorted all the data, and it has taken the expense date into consideration. Now there are these filters which you see on the row headings. We could have also used those. So I could have selected this, and that basically says or mentions which are the dates I would be interested in looking at. I also have sort by color here. I can do a sort oldest to newest or newest to oldest. So I could also use these filters which have been applied here. Now we have the data which is in color. So if I would want to basically select the color columns or color cells, I could select this. I can basically do a right click here, and when I go into sort, I could choose put selected color or cell color on the top, and that basically will make sure that my data is sorted, and it has also sorted that in a descending order. So in this way you can sort or basically filter your data. What we can also do is we can add filters. So sometimes we can go for formulas which we would want to use. What we can also do is we can basically select the filter which has been applied here. Now how does the filter come in there? So if I would select a particular row, I could select a particular row, and then I could decide if I would want to just add a filter to this one. And that's how the filter has come in. So we have the filter. What we can do is we can basically click on this drop down, and then you have something like number filters. So we can always go here. We can basically choose one of these. So we can basically choose above average. So I could select this, and then basically it shows me the values. We could also delete the filter by clicking on this one, and we could say, well, I'm not interested in this filter anymore. So I could clear the filter, and that shows me all the values. Or I could say that let's click on some other field, for example food. I can go in here, I can go into number filters, and then I could say, well, I'm interested in values which are below average, above average, might be greater than, and then I can choose what is the value. So for example, if we say I'm interested in food which is greater than $25, I could give a value here. I could say okay, and now I have applied the filter. Similarly, you can select this, and then you can just clear your filter, and your data is back. So remember, no data is lost. It is just hidden, or basically based on the filter not shown. So that's good enough for us. And in this way, you can sort and filter the data. So for more details, obviously in all these sheets, you have the links which point to more information on the web, and you can always refer to these. So this is simple way in which you can sort and filter any amount of data which has been stored within your Excel within a particular sheet. Now that we have learned about add, fill, split, transpose, sorting, and filtering, it will also be good to learn how to work with tables or basically converting your data into a tabular format and then doing some easy computations. So click on this tables option here. Now here we see there is some data which is in 5 columns and n number of rows. So I can basically select this data, and then what I can do is I can insert, choose the table option, and then it says my table has headers, and we'll be okay with that. I'll say okay, and now if you see, this is the table created. It basically has different filters which we have learned earlier how to use, and this is basically my table, which is a collection of cells which has some special features. So we can easily add rows to this table, we can add columns to this table, and we can even do some calculations. So for example, here I can click on this one. I can basically enter some field, and then I can hit on enter, and we see that this row has been inserted, wherein we can easily fill in values. For example, I would say chocolates. I could give some value here, size 25,000, might be 35,000, and then basically I can give in some values here. Now what you can also do is you can continue adding rows in this way, and say for example you would want more columns, so you can select this option here in the top bottom right corner. You can just drag it towards the right, and that basically has automatically created columns for my next months wherein I can feed in the data. So this is a simpler way wherein you can keep adding more rows and columns to your data if that has been converted in a tabular format. Now let me just do a Control Z, that basically deletes the columns. Again Control Z deletes the last row which we added, and I can stop here, or I can even remove my values by doing multiple Control Z and removing my rows. So this is how I converted my data into a table, and then I can easily work on this. What I can also do is I can do some calculations. So what we can do, we have a table here, we have a total field, and what we can do is we can just select one cell here. Now as we have learned earlier, we can do a alt and then equals, and that basically says what is this doing. So it says it is calculating the sum of the last 3 months, and if that's what you would want to do, just hit on enter, and it has automatically calculated the totals for all your rows for these 3 columns. So the sum formula is getting filled up. Now I can select any particular cell and I can look in my address bar. So it has already given me the formula where it has started calculating the sum from the October column till the December column, and has given me the calculated values of the columns. What we can also do is we can get total rows in the table. Now that's a simpler option. So what we can do is we can select any cell in this particular table, and then we see that there is a table tools design option showing up here. Now I can select this, and then it says, well, let's get a total row. So let's select this, and it automatically populates the total here. And if you would want the average, then we could select this, and from the drop down I can select what I'm interested in. So for example, I would want the average values and not the total. I could just select this, and that gives me the average of these values. So we can always do simpler computations here by converting our data into table format. Let's learn about one more efficient way of working with the data, and that's using your drop downs. So let's see how drop downs work here. Now say for example you have this data which has the values in the food column and department is empty, and say for example you would want to enter the values in department, however you would want to select the department should either have produce or meat and bakery, and these are the only 3 options which should be available for any user to fill in the values. How do we do that? So we can basically create a table by pressing Control D. So what I can do is under my department here, I can select one of the cells and then I can do a Control T that basically converts this into a table. I can say OK and my table is created. Now what I can do is once this part is done, we can select all the blank fields here where we would want this drop down to be applicable. Now under your data tab, you can go in and select data validation, and this has an option called data validation. Click on this, which basically says allow any value. So here I will select I would want to give a list of values, and then I can type in my values here, which I can say produce, say for example meat, and then say bakery. Now these are the values, so we can click on OK. And once we have done that, we basically have a drop down here next to apples, which will only show us the values which we can feed in under the department column. So I can go into every cell and then I can basically choose what is the department which handles this, and then basically I can select one of these from the drop down. So this is an easier option of creating your drop down and then feeding in the values from the set of values which you have defined here on the right. So this is a simple example of using your drop downs, working with your tables, working with your sort and filter, transpose, split, filling up your data, adding in some data here. And similarly, you can use Excel for more than one use case using its inbuilt features to easily work with your data. Let's see how we can import data or bring in data into our Excel from your local machine or from an external web source. So what we can do is we can open up a blank Excel sheet and say, for example, you have been provided a text file or a CSV file and you would want to import that data into your Excel sheet. That can be easily done. So right now I've opened an Excel sheet. Now I can click on data, and here I have an option which says existing connections from other data sources. So, or you can click on connections if you have already created some. So we can click on from other sources. So this is one option where you can connect to your different data sources and you can get the data from one of these. What we can also do is I can click on connections. Now it says there is none. I can click on add. It says, well, show the connections where connection files on network, connection files on this computer. So I can say, let's get some files from this computer. Now, if that does not show up something, so say browse for more, and that basically shows you different options. So let's basically select a folder where I have some data sets. I'll click in here, and this is basically a folder where I have some data sets. Now let me select this particular file, and I know it is a CSV file. So let's click on open. Now if you would want to verify this, you could have gone and looked into the properties of the file, and it says it is a .csv file, which is what we are interested in. So I'll take this file, I'll say open. Now this basically shows me the text import wizard option, which says is the file delimited. I'll say yes, click on next. So I will select comma as my delimiter. I can say text qualifier is none. Now this is my data. So my data preview is already showing me the data is what is the data in the CSV file. You can click on next, and then you have an option which says data format is general. You can go for date format, you can go for advanced options. So I'll just say finish, and basically now this has been created here. So we basically have this, and now I can click on close. Now once you have done that, you can click on existing connections. It shows me the data which we have here, the connection which we have created, say open, and then it says, do you want to import this data or bring this data into existing worksheet. You can also say add this to a data model if you're doing some data modeling. So click on OK. And now this data is automatically inserted in my Excel file. I can basically save it into this particular sheet. Now what we can also do is we can also start a new sheet, and that does not have a data, and we can get some other data from web. So what I can do is I can go into my GitHub, and let's say I would be interested in this CSV file. So I can select this, and this is my GitHub path, a path on web. So I can click on raw, and that basically gives me the raw path where this particular file is. Now you can select this, copy this particular path, and here you can come back to your Excel sheet. We would be interested in getting the data from web, might be from a text file where we will have to specify the delimiters, or let's go to web. And here I can give in the web path from where I would be interested in getting the file. Let's give the GitHub path, which is publicly available, and then click on import. Now once you click on import, it tells me there are two fields, data and value. These are within double quotes, separated by comma. So first let's click on import. Now once we do this, it will basically get the data from web and put in here. It says existing worksheet, so we had already created a new worksheet. So let's click on OK, and now you have the data coming in, but then this basically shows me in one particular field. So what we can also do is we can just do a Control A, that selects all my columns here, and that's my data. So we can then basically filter this out. So we can say text to columns. It's a delimited file. Click on next. We can select comma and let the text qualifier be quotes. It shows me data preview. Click on next. So you have the general format. It shows the destination, that's the column. Click on finish, and now your data has been split, and you have the data which you have imported from web. So this is the data which is coming in from web. This is the data which came in from my local machine. And similarly, we can even create connection with an existing database. So I can basically click on connections if I would want to do that. So I have an option called connection here, and it says where the selected connections are used. I can basically click on add. I can basically choose if I would want to get the files from network or from computer like we did earlier. I can click on browse for more, which should show me different other options to create connections. Say you would want to create a new SQL server connection. You can connect to a new data source coming in from different place. You could basically choose what kind of connection would you want. So these are all the different options which we can go for. And we can basically connect to a database. For example, if I have some database and say for example access database, I can see if there are some files with that particular database and I can import it. So similarly, we can also click in here which says new query, and that also gives you an option of getting the data from your files, from all these folders, from databases. So you can basically click here and then you can import data from a MySQL database, provided that is set up on your local machine or on a particular server. You can go from cloud, you can get it from online services, you can get it from other sources which says from web, from your Hadoop file system, from Active Directory, from a blank query, and you can even combine queries wherein you can run a Power Query editor. You can get the data from different sources and then you can bring it into your Excel. So in this way, you can get your data from different sources into your Excel, into your spreadsheet, and then you can continue working on those data sets. We have already learned some basic operations which you can do in Excel, and let's implement our knowledge by working on this particular data which is coming in from housing data set. Now here, if we see some fields, we have agent, date listed, area, list price, and this is basically the data which has been sorted in newest to oldest order of date listed. So how do we arrive at this? So what I can do is I can just click on data listed, and then I can either go in here, I can select sort, I can get into custom sort, and then I can choose the column based on which I would want to sort the data. So I would look for the newest data to the oldest data. That means that would be in a descending order of dates, or you could say the oldest date or the earliest month will be towards the lower side of your sheet. So here we can select date listed. Now I can say let it sort based on cell values and the order what we have here. So we have newest to oldest. So let's select this. I can say okay, and now if you see, the date has been sorted. So we have your 10/18/2007 on the top, so that seems to be the latest date. And as we go down, we will see an earlier month or an earlier month than that in this date listed. So we have sorted our data into newest to oldest order, and that's based on your date column. So the result shows up here. Now what we can also do is we can have different questions which we would want to answer. So for example, I would want to sort the data in ascending order of area and descending order of agent name. How do we do that? So let's look into this. So this is here. I already have the result here. And how did I get this? So I'm looking for ascending order of area and descending order of agent name. So we can start with any particular column, that does not matter. So for example, if I look into this Excel sheet, I have my agent name, select this, which we want in a descending order. So we could either do a sort and then go for descending sort Z to A. We could also use the filter option here on the top right, and we could do it, or I could just say sort Z to A, and then it has arranged the data based on the agent column being in descending order. Now I can go into area, and then I can again do a sort, and I wanted my area column to be used for sorting the data in ascending to descending. And that basically not only changes the order of this particular column but for my complete data. So let's do that. And now if you see, we have the data which has been sorted. So we can see how many values we have here and the area values which we see, and this is how you get your result. So I'll just do a Control Z and again, and I'm back to my original data, and this is the sorted result which we are seeing at. Similarly, we can answer other questions. For example, sort the data according to the following order of area. That is, we are saying county, central, and then your county. So we can basically choose in which particular way we would want to do it. So it is county, central, and then again county. So if I look into my sheet 3, so here I basically have my data which is having some South County, then you have your central, and then you have your North County. So we would want to sort the data to solve our problem, which is according to the following order. So first we go for area, then we go for South County, Central, and North County. So what we can do is we can basically have area field selected, and I would want to sort this particular data. So I have South County, Central, and North County. So I can basically go for custom sort, and then I can choose which is the value or column which I'm interested in. Let's go for area. We will go for something like cell values. Well, you can also try to explore conditional formatting icon if this is what you would want to use, or we can basically go for just cell values. And here we can say if I would be interested in first getting my values for South County. So for example, I can say custom list, and then I can basically give in the new list here. So I can say S dot county, and then I would want central, and then I would want North County. So let's select this as it exists. We can basically say add, and that's basically the order which we want. Say OK, and then say OK here. And now what we would want is we would want our data, so we can compare that with the values which we see here. It starts with Kelly. You have in the 12th row something like Lang, and that's what we are doing. So we can basically arrange the data in a particular order by choosing a custom list and then sorting your data. So that's one more simpler task what we have done, where we have sorted the data in the order where under our area column, we first wanted South County, then we wanted central data, and then we wanted North County. So this is how you can do it. Now, let's look into one more problem. So it says find all the houses in the central area, and we would want to basically apply a regular filter. Let's see how do we do that. So we can click on this, and here we have the data. So the problem statement is we would want to find all the houses in central area. Now how do we do that? We can do a sorting, but we would want to use the filter which you see here is implemented. So how do you do it? So you can select this area, and say for example I would want to apply filter. I can just go in here and I can say let's get a filter on my first row, and now I have filters applied. So we are interested in looking into the central area houses. Let's go in here. It says all these fields are selected. That means it shows everything wherein your area has all these values. Let's unselect this, and then I will only be interested in the central. So let's say OK, and then say OK. So now you see the area filter has been applied, and we are looking at the central column. So what we have done is we have applied a simple filter, and we are looking at our data. At any point of time, if you do not want the filter, then what I can do is I can select this, and I can say, well, I'm interested in all the data. So I could do this, or you can clear the filters from area and you get your data back. So that's in one way you can filter out your data. So let's look at an example of sort and filter, where we might have to filter the data based on two columns or multiple columns with different kind of values, where it could be and an or condition. Now say for example this is the data I have, and this is the question which we need to answer, such as find the list of all houses in the central region with pool and South County without pool. Now if it was a simple filter based on one cell, I could have just selected my header row. I could have then applied the filter, and once I have the filter, I can look in area where I have three regions. So I'm only interested in central and South County, so I can get rid of North County, and that's fine. But then we have two different conditions here. So we need the data in central region to have the value for pool being true, and for South County the value has to be without pool. Now how do we do that? So what we can do is we can first create a copy of these headers here. So let me do that. Now the area has to be South County. So basically I can either just select this, and I can choose this value, and then I can select this, and then I can choose central. So that's the criteria which I have, and the pool value has to be, so central region should be with pool. So then this one basically has to be true, and this one has to be basically false. So South County is without pool. So let's select one of the values here, and this is my criteria. Now to get my result, we can always place your cursor here and you can check this is M column and 8th row. Okay, so we would want the result here. So let's go ahead and now click on data, and then in filter you have an option called advanced, and here what I can do is I can say I would want to filter the list in the place, but that's not what I would want to do. So I'll say copy to another location, and here if you see the list range will tell me that this is the data. So A1 to J126, so A to J column selected and all the rows. Criteria range is basically based on what I've given here. So that is M from 1 to V, which is 3. So I'm selecting these columns and then I'm saying all the way whatever criteria I've given, and copy to, I'm saying M8 to V8. So that basically will give me my filtered result. So you could basically just say okay, and now I have my data which has been filtered, and I have my area which is South County, that is without pool, Central with pool, again South County without pool, and then if you look at your central value, that's pool. So this is an advanced filter which we have applied, where simply we have filtered the data based on 2 columns and then we have our result. So in this way you can have your customized filter applied on 2 different columns and get your data, which can be either replacing the existing content, or in the same sheet in different set of columns and rows you can have your result. Let's look at one more example of filtering where you are trying to filter the data based on an AND condition being met in 2 different columns, and then you would want to filter out the data for only specific columns. So the situation is the agents with a house in North County, that should be county area, having 2 and a single type family. So we are talking about 2 bedrooms, and we would basically have a single type family, and here the criteria is that we would want to only populate these columns, which is agent, area, bedroom and type. Now what you can do is, as I explained earlier, that you can get your result in the same sheet in a different location. So here I have created these headers which says agent, area, bedrooms and type. Now this is basically a copy of all the columns what we have here: agent, data listed, area, list price, bedrooms, bath, square feet and so on. So you can basically create a copy of the headers here, and this is where we will give our advanced criteria to filter the data. So the conditions which need to be met is we need to look at North County. So for example, here in area, I can basically go ahead and select one of the values, North County. Now the criteria is having 2 bedrooms only. So let's say bedrooms, and let's say the value should be 2. And then basically I am saying a single type family. So when you would want the single type family, so here under type, I can give the criteria single type. So this is my AND condition. So we are saying North County area having 2 bedrooms and the type is single family. Now this is the criteria, which basically means if I select this one tells me that this is M1 row onwards till V2. So this is what we have, and we would want to filter based on this. So let's go ahead and then go for data, filter, advanced. And here in advanced, it says filter the list in place. Now that's not what we would want to do. So I'll say copy to another location. This basically selects the list range. So which is telling me A1 to J126. So that's the columns and rows selected. Criteria range is based on M1, V2, which we have given here, and copy to, I would say, for example, from M7 to P7. Now this is the area where this is the place where I want the result. Let's say OK. And now I get my data, which is based on the question which has been asked, that you would want the agents with a house in North County area having 2 bedrooms and single type family. So in this way, you can basically do advanced filtering, get your data and get it stored in the sheet anywhere at a different location. Well, I could have also done filtering in place, and that would have replaced the data which we have, but that's not what we want. We would want the filtered result in a different place. So this is how you can do some advanced filtering. We can also use Excel to filter out the data in one particular column, which might be conditional or say using some numerical filters. Now here, say for example, the problem statement is that you would want to display all the houses whose list price is between 45,000 to 600,000. Or say for example, we would want to filter out the data to something else. Say for example, let's say I would want to filter out the data between 300,000 and 400,000. So we can basically update this. Say for example, I'm saying I'm interested in 300,000 to 400,000, and that's the criteria to filter out the data. Now there are two different ways, or there are two easier ways to do it. One is I would want to look at the list price, so I can select this. I can go ahead and do a filter here, and in the list price, now this is where we would want to do the filtering. So it's pretty easy. You can click on this one and then you can go into number filters and you can choose between. Now that's one easier way of doing it. So I could basically select this. I could say I'm looking for value which is greater than or equal to 300,000 and then is less than or equal to 400,000. So if I just do this, I have applied my filter and I have my data which is filtered based on my criteria, right? So that's one easier way of doing it. Or let me do a Control Z. Now let the filter be there, which you can anyways use. But what we can also do is, as we have seen earlier methods, so get a set or get your column headers here, and then you are giving two columns here. Now the only difference between this set of columns, which I have 1 2 3 4, and then you have 7 and 10 columns, and if you see here we have 4 5 6 7 8 9 10 11, right? So whenever you want a AND condition, you will basically add the columns where I can give add condition if it is the same column. If it was a different column, then it would be same number of columns, but AND conditions will lie in the same line and OR condition would lie in a different line. Now here I can give this value, so I am looking for listed price being between 300,000, so I am saying it should be greater than or equal to 300,000, and then I can say less than or equal to 400,000. Now that's my criteria, and then I need my result here, which is in M7. So what I can do is, once I've given my criteria which I'll be using to filter, I can get into data, I can get into advanced, and then I can say copy to another location. So it is selecting my A1 to J126. Criteria range is based on M1 to W2, and then I would want my result from this particular column. So let's say OK, and now you have your data filtered out in a different location in the sheet, which has been filtered based on your AND condition. So you can filter out the data in this way, or you could just apply a filter on a column and give the conditions. Now let's solve one more interesting problem. And here we would want to use Excel, where we would have an and, an or condition. So say for example, this is the data given to you, and the question is that you would want to find all the houses in North County. Again, that's a spelling mistake, but then they are North County area with a list price greater than 300,000 and having 3 or 4 bedrooms. So the bedroom has conditional, so it has or 3 and 4, and then basically you have list price which is greater than 300,000. Now I could have obviously selected the columns and then basically gone for a filter. So I can just do a filtering here, and then I'm looking for list price being greater than 300,000, so which we can always give a number filter, and I can say greater than, and then I can say greater than or equal. So I can say greater than, and then I can give 3,000, 30, 300,000, and that's basically the filter which we would want. And here I would want to select the bedrooms, which should be just either 3 or 4. So if for example here I go in here and I unselect this and then I say 3 and 4, right? So I am getting my data which is greater than 300,000, and it should have the bedroom values which will be either 3 or 4 selected. Now that's one way of doing it. Let's do a Control Z and get it back to as we were, or you can even just say clear filter, so you get your data back as it was. So what we can do is we can here give the criteria. So for example, I have my list price. Now this is what I would want as a condition. So let's say greater than 300,000, and bedrooms should be 3. And then I can say greater than 300,000, and then I can say 4. So this one basically gives me a situation where your list price has to be greater than 300,000 and bedroom should be either 3 or 4. So we have given our filtering criteria. Now to get the result, what we can do is we can go into data, we can go into advanced, and we can say copy to another location. So our list range is selected, which is columns A to J, row number 1 to 126. Your criteria range is given in M1 to V3, where we have specified, and we are saying the result would be in M7 to V7. So if I do this, now I have got the same data which we were seeing earlier, and here the bedroom values are 3 or 4, and basically the list price is greater than 300,000. So this is a simpler way in which you can create your filters. And all this advanced filtering, what we are seeing, it will be saved with your sheet. You can always go back and change this value, or you could do filtering where one person has to look into the filter to see what values have been selected. Now that we have looked into some operations which we can perform in Excel using filter or sorting the data, creating your tables, let's also quickly look at functions and formulas which can be used for doing some easy calculations or computations. Now Excel can be used in different kind of data analysis. So for example, you have different inbuilt functions which can be used, and we can always check for a particular function. So for example, if I wanted to look at a particular function, I could just type in here something, for example is, and then it shows me all the possible functions, and you can always have a look at the detail of the function. For example, you have is even, which will return true if the number is even. If we would say is logical, so I could search for is logical, and that tells me whether a value is logical value, true or false, and returns your value true and false. Now we can obviously say subtotal. So you can search for any of these useful functions, and that tells me what this function can be used for. So returns a subtotal in a list or a database. You have many other such functions such as integer, sum, average. You may be interested in working on truncating some data, getting the absolute value, getting the square root, basically getting a count or getting a max value. You can look for any particular functions within your Excel sheet. Now you also have other functions such as now or time. For example, let's look at now function. So I can search for now, and here it is. So this is returns the current date and time formatted as a date and time. So this is the function which we would want to use, and if I just give the function, it tells me what is the current time. Let's first look at the description of time here. So say for example I would want time. It says converts hours, minutes and seconds given as numbers to an Excel serial number formatted with a time format. So for example, if I would say 2 hours and then 30 minutes and 30 seconds, and if I do this, it has basically converted this into your time format. So you can always use different inbuilt functions for your work. Now we will also look at some advanced functions like SUMIF or some ifs. You have COUNTIF and COUNTIFs, and you can be working on various functionalities of Excel to easily help you in doing some calculations, computations, working with your data, working with your different cell values. So let's look at some example of using functions like sum or SUMIF. So for that, let's go to this sheet, and here we have some data. Now I have already applied a filter which can allow me to filter out the data. So it says find the total units that were sold in the East region. Now we know that in region we have East, and I have multiple regions. I could basically be saying unselect all and select only East and say OK, and that basically gives me the units which were sold. And if I placed my cursor here, and then if I did a auto sum, so it would basically give me the function which is being used, so something like subtotal, and it is basically working on your rows which is E2 to E44. And here we can just do this, so that gives me the total. But this is fine, you could do that, but it would be good if we know how do we use a function like SUMIF to do that. So here I'm seeing this is the subtotal where I'm looking at the values, and basically what I have done is I have filtered out the region, and then basically I'm getting a count. But this does not give me clearly how a sum was calculated from all the values which were listed. What we can also do is let's do a Control Z and let's get it back. So now we have our data, and we would want to get the total units that were sold in the East region. So what I can do is I can start typing in my formula, and for that I'll use an inbuilt function. So for example, I would be interested in going for SUMIF. Now it says SUMIF adds the cells specified by a given condition or criteria. When you talk about SUMIFs, this is when you could give set of conditions or multiple criteria. So let's look at SUMIF. Let's do this. Now obviously this gives me an error because the formula is not right. So we have to basically come in here, and let's start with SUMIF. Now when I say SUMIF, it shows me there is a function with SUMIF which we would want to use. And here, once I open up the bracket, it tells me, okay, what is the range of data which you are interested in. So I'm interested in all the units that were sold in the East region. So we are interested in the region which is here. So I can basically be selecting this, and this tells me you are interested in the data here. So let's not take the header value. So let's say B2, and then we can go all the way to the end. So we can basically select this way. That's the data we have. Select this and hit enter. So now here it has selected B2 to B4, but we need to basically now give the criteria. So the criteria is either a value, or you can point it to a cell which has that particular value. So as per our problem statement, we are looking for the units which are sold in East region. So I can select the value East here, and then my SUMIF needs the range on which you want to calculate a sum. So let's select this, and now we are interested in finding out the sum of units. So that's basically this column, E column. So I can basically type in instead of selecting. So I can say E, and I'm interested in E2 to E44. So that basically selects the area or all the values. And now let's do this. So that basically gives me the sum is 691. Right now, this is the criteria where I have pointed it to a cell, and whatever value that cell has. Well, I could have done something like this. So I could have selected East, giving the value, and then doing it. It still does the same thing, and in this way you have more clarity that you are using SUMIF. You are filtering the data. So you have given the rows, you are given the criteria, and then you have given the range on which you would want to sum up the values. Now similarly, if the question was what was the total revenue generated from binder, now we would want to find out what is the total revenue generated from binders. That means my filtering criteria will be binder, and then I want to find out the total revenue generated. So we have the revenue generated field also here, and we don't have any region to be filtered. We are just looking for binder. So let's again start doing the same thing. So we can go for some if, we can open the bracket. Now it needs the range. So we are interested in revenue generated. Now that's the summation we want, and we would want to get the range of data. So here we can basically select D2 to D44. So that's the data selected. Now I would want to give the filtering criteria. So let's say binder, and then we need to give the range on which the sum needs to be calculated. So that's my revenue column. So that's G. So I can say G2 to G44, and that basically selects the column, and then you get your sum. So it tells me what is the total revenue generated from binder. Now I could be doing this for other things also. So say for example, if you would want to filter out something else, you could basically just drag and drop here, and then I could come here and change this to, say, instead of binder, I would be interested in, say, pencil, if that's the criteria you are interested in. Remember to change this so that you take all the values, and here we will change it to select the relevant rows, and then this is the data I'm getting. So I know that this is the revenue generated from pencil. This is the revenue generated from binder. Now this is a simple use case where we are using some if. What if we would want to use some ifs? So some ifs, let's have a look at how we get to some ifs. So some ifs is where you would want to work on doing some calculation, but then you would want multiple criteria to be met. So let's see how we get this. So here what I can do is, let's work on this problem statement which says what is the total revenue generated from central region where the item is a pencil. So that's something which I would want to check. Now, when we are answering this question, we can also look at the order in which things have been asked in the question. So it says, what is the total revenue generated from central region? So we need the total revenue generated. We know there is a revenue column. We are interested in getting the total revenue generated. We are saying the filtering criteria is central region, and we say in that we would be interested only in the item if it is pencil. How do I do it? So I can use some ifs where you can pass in multiple criteria. So let's start with some ifs. And when I start with some ifs, let's open up the bracket. So it says sum range, it says criteria range, then it gives one criteria, and you can give in any number of criterias. So for example, we are interested in total revenue generated. Now that's my G column. So let's follow in the same order. So let's say G2. So that's my first value. And then I know there are 44 rows here. So I can say G44. And you can obviously check if that has selected all the rows. Now that's my total revenue generated. So I would want the total revenue generated. So I'm saying setting this sum range. Then I need to give the criteria range. So it says from central region. So central region comes into column 2, that's B. So let's say B2 to B44. So that's my criteria range. Then you have to give your criteria, but we need to filter out the region being central. So let's select this. Now either I could point to a value in the cell, or I can just give the exact value here. We can also give a wildcard or matching pattern, so that also works. Now this one is fine. We are now also interested in finding the total revenue generated when the region is central and the item is pencil. How do we do that? So for item, we know the column is D2. So let's select D2 to D44. So that basically selects all the rows in the D column, and we need to give the filtering criteria. So let's do a comma and then just give in our value. So let's say pencil, and then let's close your bracket, and that basically gives you the result. So we need to just follow the order of our question, which says what is the total revenue generated. So we are looking at the revenue column, we are selecting all the rows. Then it says from the central region. So we need to select the region column and give the filtering criteria as central, or point to a cell which contains that value. And then it says we would be interested only in item being pencil. So then you select the column which has all the items and provide your filtering criteria, that is pencil. So that's your easy calculation of using sum if, which we compare with sum if here. So sum if here was just having your criteria. So basically you are selecting your rows, giving your filtering criteria, and then your sum range. In sum ifs, we are giving multiple condition. Now same thing can be done here. It says how many units were sold by sales representative Jones where the cost of each item was greater than 4. So how many units were sold by sales representative? So when we talk about how many units, that's your E column. So let's start with that. So let's say sum ifs. I would be interested in E column. And let's give the range. So it says sum range. So those are the number of units on which we would want to find the sum. Then it says you need to give the criteria range. So we say sales representative, where the name is Jones. So sales representative is in sales rep column C. So let's say C2 to C44. Now then we need to give our filtering criteria. So let's say Jones is the sales representative where we are interested, about whom we are interested in. And then the question says where the cost of each item. So cost of each item is what we are interested in. You have unit cost. So that's what we are interested in. So that would be F, and then say F2 to F44. And then you need to give your cost. So it says where each item is greater than 4. So let's select this and let's do this. So this tells me 301. Now, similarly, let's answer our third question, which says how many units did Jones sell excluding pencil item? So we would want to find out what was the total number of units that were sold, and that units or that should not include the pencil item. How do we start doing this? So let's start with some ifs. Now we know that you start with some ifs, you need to give the sum range. So we are interested in the number of units. So let's basically go in and select our number of units which were sold. So that's your column E. So I can say E2 to E44. That's where I would want to perform the sum. Now I'm saying how many units that were sold, where we are talking about sales rep being Jones. So let's select the columns C and then give the range. After that, we need to give our filtering criteria, which is Jones, and then we are interested in the items, but excluding pencil. So items is in column D. So let's say D to D44, and then we have to give our criteria. So we can say, well, that should exclude pencil. So I can basically say pencil, and let's close this and let's check. So that's my formula, which says that these are the number of units which the sales representative, whose name is Jones, had sold, and that does not include pencil as an item. Let's also look at an example of using COUNTIF or COUNTIFs. Now, both of these can be very useful when you would want to calculate certain values. So for example, if I would want to work on COUNTIF, let's try solving this problem. Now, remember, you can answer these questions using filters, and that can be an easier way, but then sometimes you may want to get the formulas so that you can make your spreadsheet and your calculation more dynamic in nature, and that will basically depend on the values in the columns or rows. So for example, if I have find the total number of times Gil has made a sale. Now if I look at my data here, it tells me that for every sales representative there is some value in the sale, and it says sales has greater than 3. So for example, Jones, you have sales greater than 3, or you have Jardine, which is sales greater than 3, and so on. So what we are interested in is doing a quick count and finding out the total number of times Gil has made a sale. How do we do that? So we can use this COUNTIF function, and if I go into COUNTIF, it says counts the number of cells within a range that meet the given condition. Now what's our condition? Our condition is Gil, and we would want to find out how many times the name, say, Gil appears or Gil has made a sale. Now I could just say COUNTIF and then open up a bracket. I need to give a range. So let's say we are interested in looking at the range. So let's say we will choose sales rep. So I can say C, and then I can say C2 to C44. Now that's my range. Let's not give that in quotes. So you have to give a range. So let's do a count if that selects the data, and then we need to give the condition. So for example, let's here give the name, which is Gil, and then close this. So that basically tells me it is 5 times Gil appears here. We can check this. So I can go in here, I can add a filter, and then might be I would be interested in looking at only Gil, and that basically gives me 5, right? So we can always do that, and we can be using formulas like this. Now what about this question, so which basically says which sales representative made a sale more than 3 times? Now it might be looking little confusing when I say, for example, let me clear out this filter. Now we have sales greater than 3, and we would want to find out which sales representative made a sale more than 3 times. Now I could basically check for every sales representative here if they have made a sale more than 3 times, and what I can do is I can just say equals, I can start with count if, then I need my filtering criteria. So that's your range. So first thing is we will choose, for example, let's choose C2 to C44, and then we need to give an criteria. What is the criteria? We need basically a sales representative. So I can choose the value here in C2, and then I can close this, and then I can say the sale has to be greater than 3, and let's check. So it tells me the boolean value that yes, this guy has made sales more than 3 times. And what we can do is we can just drag and drop, which basically gives me the value for other sales rep. You can always check the value is automatically changing to this value in cell. And for example, let's go in here. So this is obviously 2, so it says me false, right? And you can basically get the values for all your values. So that basically tells me which sales representative has made a sale more than 3 times. Now, like some ifs, we also have count ifs where you can give multiple criterias. So for example, the question is how many orders were placed from the East region after this particular date. So we have a date criteria, we also have the region criteria, and we need to basically get the count of number of orders which were placed. Now I can in this case use count ifs, and this basically says that you can start with a criteria. So it says how many orders were placed from East region after particular date. So date is in my first column. So for example, I could say A, start with 2, and say for example, let's go A44. That should have selected all the rows. And then I need to, once I've given the criteria range, I need to give the criteria. So we are saying the date has to be greater than 10th Feb. So let's give it 2/10/2019, and then you need to say how many orders were placed. So you need to give the criteria, second criteria range. So we are looking at the number of orders which were placed from the East region. So when I would want to look at the region, that's your column B. So I can basically say B2 to B44, and here I would basically give my criteria. So the criteria is East. Let's give that. And once you have done this, you would want to find out the total number of orders. So let's select this, and if I do this, it tells me 13. Now, is that right? So we are looking for your date, your region being east, and then getting the total number of orders. So here I can just do a count if I'm saying A2 to A44, wherein I have given the date criteria that it should be greater than 10th Feb, because I do not want to count 10th Feb. It says after 10th February. And then you're saying the region has to be east. So we would want to find out the total number of orders. So my region is east, and that gives me the result. Now, similarly, you can also find out how many times Gil sold pencils. So here we will have to give the range. So let's start with count ifs. Now here I would want that item is pencils, so we can as well select column D to D44. Then you have to give your criteria, so that's your pencil, and then we are looking for sales rep, which is Gil, so that is my column C. So let's say C2 to C44, and the value should be just Gil. So it tells me it's twice where Gil has sold pencils. So we can obviously check this by going in here, choosing my filter, and then let's search for rep being just Gil. Okay, and now we are interested only in the item being pencil. So I can say, well, let's get to pencil only, and that tells me twice. So you can obviously re-verify using filters, but using functions or using formulas, it is always good to calculate, and that can be making your computation and calculation more dynamic. Let's look at one more interesting feature of Excel, and that's your conditional formatting. Now, as you see on the screen, conditional formatting has different rules which can be applied on your data, and that allows you to basically differentiate or easily identify data values which are based on certain criteria or rules. So when you talk about conditional formatting, you have different options, such as you can highlight cell rules, you can get top and bottom values, you can apply different rules, apply different color scales, and you can easily manage these rules. So conditional formatting is very useful for people who would want to work on huge amount of data and easily perform some data analysis. It's easy to use as it is shown here, and with your conditional formatting, you can format cells based on a preset condition. You can perform conditional formatting to identify cells. You can highlight a few significant cells, and you can easily perform conditional formatting as shown on the left side. Now, how do we work with conditional formatting? Let's have a quick look. So say, for example, we have our Excel sheet, and if you see here, I am highlighting the salesperson who have generated revenue greater than 10,000. So we can be looking at the values where the revenue generated by a particular salesperson is greater than 10,000. It has a particular color. And how do we get here? So for example, let's select this data, and what I could do is I could go into conditional formatting. Now I could basically highlight cell rules, and we could just say greater than. That's an easier way. I could also go ahead and create a new rule. but then I can use one of this option. I can say greater than, and let's give some value. Might be we would be interested in looking at any value greater than 12,000. So let's choose 12,000. And here it says what color would you want to select. So for example, I would say something like yellow filled with dark yellow text, and let's say okay. So right now what I'm doing is I have all the values where the revenue generated was greater than 10,000, but then I have also selected all the sales people who have made or who have generated revenue greater than 12,000. So I can just do a Control Z to see the previous result. Now here I had the values which were greater than 10,000, and the one which we did just now basically highlighted the values which are greater than 12,000. So this is one simple example. Now we can look at some other examples. Say for example, you want to format cells using 3-color scale. So if you look at the values here, I have a 3-color scale mainly in green, yellow, and red. And how do you do this? So for example, I can go in here and I can go to conditional formatting. So I would want to go for color scales, and here you can create different rules. So we can set up a 2-color scale. So we can say format only values that are above and below average. I can format only cells that contain something. I can get the top and bottom value. So these are different ways in which I can have a 3-color based scale. Now what I will do is I will select this, and let me show you the rule which I have. So for example, I can go into manage rules, and if you see here, there are certain rules which have been specified. Now what does that mean? So you would want to specify a 3-grade scale. So for example, if I would want to look at my first rule, it tells me that I'm choosing 3-color scale. I can choose lowest value, percentile, and highest value, and that basically will select the cells based on their values. So what we could have done is I can basically use one of these values. I can delete these rules which I have created. So for example, I have all these rules, but you should always carefully remember that the rules will be applied in the order shown. So for example, if I just delete these rules and then say apply and say okay, my data is back. Now it does not have any highlighting. Now I can go in here, I can say conditional formatting. I could go for color scales, or I could basically go into new rule. So I would want the cells to be using 3-color scale. So let's choose 3-color scale. Now when you say 3-color scale, it says what will be the color of lowest value, and we could choose, might be any one of this. Let's choose red. I can say midpoint is percentile 50, and then the highest value is green. And if that looks good, let's say okay. And now if you see, the lowest values have been highlighted as red. You have mid values, and then you have the positive value. So this is a 3-color scale, and that easily helps me in identifying the data based on the cell values. Now in conditional formatting, what you can also do is you can basically color the cells based on their values. So what we are seeing here is if the revenue generated is greater than average, then that shows in green. And if the revenue generated is lesser than average, that shows in orange. Now how do we do that? So we can basically again manage some rules. So I can basically create a new rule. Now here I can select one of the options which says format only values that are above or below average, and that's the option I would want to select. Now I can select this, and it says format values that are above average. So In our case, we had it in green. So for example, I'll say above average, and then here I can go for a particular color. So you can go for a particular size. So let's go and look into the formatting. So for example, let's choose yellow. Say okay. Now I'm saying wherever the cell values are above average, it would be yellow instead of green. And let's go in here. Let's go and look into manage rules. So this is basically the rule which we are applying. Now we can also add a new rule, and I need to select the values. So for example, I will say here, so we had gone for above, now we'll go for below, we'll go for format, we will choose red, we'll say okay, we'll say now these are basically the rules which we have created, and here it says applies to your data. So right now it has not been applied. So for example, if I select this and then I could basically choose my area, just hit on enter, and similarly you can go in here and then select your area, hit on enter and say apply, say okay. And now if you see, I have really chosen bright colors, but then I have said wherever my revenue generated is above average, it should be in yellow, and below average should be in red. So we wanted above average to be in green and below average to be in orange. So that's what we have here, right? So you can always color code your cell values based on some rules which you are setting up. Now similarly, you can also find the top 10 and bottom 10 values, and that's pretty easy. So you can just select this, and then you can go into conditional formatting. You can go for top and bottom values, top 10 items, bottom 10 items, or you can go in for more rules. So you can say format only top or bottom ranked values. So you have top 10. Now you can choose the color, and for example I'll go for blue and I'll say okay. So now if you see, my top 10 values are blue. Now similarly I can add one more rule. So I can say new rule, and I can say let's go for top or bottom. Let's go for bottom. Let's go for format. Let's say orange. Say okay, say okay, and that's it. So now you have your values which are top or bottom 10 values. So you are using conditional formatting where you are basically highlighting your cell values based on different colors, and here easy conditional formatting based on different rules helps us to do that. Now similarly, you can also have the values which is basically showing you how the values are increasing. So what we can do is we can select our columns. Either you could apply this to all the columns. Now here I have applied this only to Jan and April. Now I could apply this for June. So let's say June. So you can go for gradient fill, you can go for solid fill, you can obviously just select the color, and that takes care of the things. You can say for example select this, and now this is selected, but I would want to might be format this. So I can go in here, I can go into manage rules. Now that will tell me what rule has been applied in the order. So I can just do a edit rule, and that basically says this is a solid fill, which is color, you have no border, this is basically color is black. Now I can go for something like gradient fill, and I can say okay. And now if I say apply and okay, so this basically is like your first column. So you can use conditional formatting for various use cases, and you can highlight the values So anyone who would look at the value would automatically notice which are the higher values, which are lower values. Might be here the revenue is getting generated or was getting generated but did not grow beyond a particular value, and so on. Now similarly, you can also go in for different options. Say for example, here we would want to see if the revenue was dropping, or if the revenue decreased, or say for example if the revenue was going up for this particular salesperson. So here we are looking at Carol. So in Jan the revenue generation by sales was very high, then in Feb it was falling down, in March it was kind of stable, then in April it went way below. So we can obviously work on this, wherein we can grade our cell values. So what we can do is we can go in for highlighting the cell values. Now you can go for color scales, you can go for icon sets, and this is where you can choose your different shapes. So you could choose one of these shapes. So for example, I would be interested in looking at the indicators like directional. I could go using this 3 arrows. I can go in for this color. I can choose directional, and then my values are automatically using directional. Now what we can also do is we can then go into manage rules, and that basically tells me what rules have been applied. So for example, the latest one is the icon set, which I have chosen. It shows the selected columns. I can obviously do a edit rule, and then I can choose. So I'm saying the format style is icon sets. I'm not using a data bar. I'm not using color scale. Now here I have chosen the style of icons, and then here you can basically give some values. So you have icon which is green when the value is greater than or equal to 67%. When I say hyphen or minus, it is less than 67. It's way below 33%, then you give this value. So you can obviously edit and easily highlight your cell values based on this icon set. So I can apply this, and that's how I use conditional formatting. So conditional formatting can be very useful if you would want to use icon set, if you want to use your data bars, if you would want to highlight particular values, if you would want to color code based on some calculation, if you would want to use a 3-color or a 2-color scale, or if you would want to just find out values based on some simple calculation. So conditional formatting is used extensively by data analysts, or people who are working business intelligence teams, or people who would want to use Excel to easily identify the data, easily identify the cells which contain particular value, or finding out less significant or more significant cells to then pull out values and carry out your computations, calculations, or analysis.
If you're an aspiring data analyst looking for online training and certifications from prestigious universities and in collaboration with leading experts, then search no more. Simplilearn's postgraduate program in data analytics from Purdue University in collaboration with IBM should be your right choice. For more details, use the link mentioned in the description box below.
Let's continue learning on using Excel for various things. Now we have learned on conditional formatting and seen how that can be very helpful. Let's learn one more feature of Excel, and that's basically your data validation. Now this can be very useful when you would want to work on validating the data which is being fed in the cells. So you could limit it to basically a number between a particular value. You could also add some messages to it if you would want, or you could even circle invalid data or clear validation circles. So data validation really helps us in validating the data which is being fed in to particular fields. Now, It's a feature in Excel which is mainly used to control what a user can fill in a cell. You can decide what type of values must be entered. You can also restrict user to enter only valid data, and if any invalid data is entered, an error message will be displayed. Now that's where you can use your data validations. So let's see how that can be done. So for data validation, let's see some exercises here. So for example, you have a name column and you would want to restrict that the name should accept only 15 characters. Now, how do you do that? So you can basically select the cells, or you can just select a particular cell and then we can later drag the property to other fields. Now here, once the cell is selected, so for example, let's try this out and let's see if that works. So for example, I will say Peter Johnson, okay, and that is basically 5 and 9 and 12 characters. So let's say junior, and if I do this, it says input length is greater than 15. Do you want to continue? If I say yes, right? So basically it is allowing me to add the value here, but then it has basically violated the rule. Now this is giving a message to the user that the username should be entered less than 15 characters. Now how do we do that? So for this, we can basically select the column and then we can search for data tab and get into data validation. So this is where you can create or select different kind of rules. So for example, I can go into data validation, I can go into settings, and I can say the text length, and that should be less than 15. Now this is the maximum I'm giving, and it says apply these changes to all other cells within the same settings. So I can do this, or I can just drag and drop. So I can basically apply this formula, and now you can in fact randomly check in any particular cell, is the rule applied. So it says text length less than 15. So we can basically control data validation in this particular column, and that will allow only 15 characters. It will pop up a message if the user really wants to go beyond the particular limit. Now you also have similarly date of birth. So the restriction is date of birth should be between 10 Jan 1990 to 30 December 1998. So this is what we want to restrict. How do we do that? So we can select the field, we can click on data validation, and if you see here, I have selected date, and then date is between, and then obviously you can give a range, that is 10 Jan date 1990, 12/30, 1998. So that's the start and the end filter which has been applied. And once this is done, you can also check your input messages, which says when cell is selected, show this input message, enter a valid date. So if you see here on the left, there is a pop-up which is coming up which says enter a valid date. Now I can also say when user enters invalid data, show this error alert. So I can say stop, I can say invalid entered, and this is how I have set a rule. So for example, if I just do something like this, and that says invalid date entered, I can do a retry. It will take me back here, but unless and until I do not give the right format, the date will not be accepted. And again, the same thing applies to all the cells. Similarly, email. So we are saying the email should have @ present in the value provided. Now for this, we can use a formula and we can select, well, I would want to apply this rule to all these rows starting from C2 to C14. So let's get into data validation. Let's look in settings, and here we are choosing custom. Now within custom, I'm choosing what is the formula. So I'm saying is number, and then I'm saying find @ for the rows C2 to C14. So the only thing we are concerned about here is the value should have an email icon. You can input a particular message. You can say what has to be done for error alert. So for example, we can basically go in here and we can say invalid email. That's the title I'm giving. And we can say email should contain @ So if I do this and if I say OK, now you can test it. So you can say A, B, C, D, and that says email should contain @ and basically that will not allow me to add the values. So now you have the field called salary. It says salary should be greater than 50,000. Now we can limit the values by choosing a whole number. So for example, for salary, I can go into data validation. I can go into settings. So here I can say something like decimal, or I can go for whole number. So both of the things are fine. It depends on what kind of values get into this particular field. So if I say whole number and if I say it has to be greater than 50,000, so I'm saying the minimum is 50,000. Or I could have given a decimal and then I can say greater than, less than, equal, or anything, or even between. So I can select greater than and then I can just say OK. Now for rank, the rule is rank should be between 100 and 200. So again, we can use a whole number. So ranks will generally not be decimal. So this would be whole number. Salary can be a whole number or it could be decimals. So we have chosen decimal here, and in rank, if you click on data validation, I have chosen whole number. I've set data between 100 and 200. Input message, nothing. Error alert, nothing, but that depends. I can give this. So this is how you can just do a simple data validation and control the values which land in the cell. Okay, so now let's also understand how we can restrict the values in a particular cell, which might be based on a list of items. Now, for example, here, if you see, I have two columns. So one column basically has the values of city names, and then you have places within that particular city. So if I would want to implement a data validation based on this, so for example, if you see here city, and that basically shows me only the 4 values which can be entered. And if I go to place, then it tells me for Maharashtra, I can only enter Pune, Mumbai, Nasik. Now, how do I do this? So say, for example, you take an empty field and you want to restrict the values of city names. So I could select data validation. I could basically select list, and then it tells me you need to enter the list values, that is the source. So you click here, and then I can just select these fields. Now, if I do this, and if I say OK, it has implemented a data validation. But if you look into this, it will show me the same thing, but then it shows me some empty cells which did not have any value. So this is fine, but it would be better if we do it in a different way. So I can select this, and I've already given my city names here. So I can just do a data validation, and here in the source, let me get rid of this. Now I can just have my cursor here. I can select these values, and then if I say OK, so now if you see, my city names have been restricted to these values. And that's how you can implement your data validation. So I have this data validation here, but I will get rid of this one by just doing a Control Z. Now I'll come here and say, for example, I would want to implement the same data validation. Now the easiest way would be in doing this for all my 4 cities. Now if you see here, I have data validation. I could choose Bangalore, And if you come and check here, there is no data validation, but we have implemented data validation here. Now, how is that done? So I could select this, or for example, I can go in here, I can select data validation, I can select list, and then here in the source, I will say for Bangalore, the values should be these. And then if I basically say OK, now if we see, these are the values which are fed into Bangalore. So we could do this, or like what we have done here. So if you can check the data validation rule, I have used list and then I have said indirect F2. So basically I'm giving in a formula which relates to the value which is in for the city Maharashtra. So we could do this, or in a simpler way we could do this and then just drag and drop here. So we could check for Maharashtra what are the values. Let's choose a different city. So for example, Kolkata, and here I will choose. Now, since we did a drag and drop, it has basically taken the values of Bangalore. So that's not right. So we select this, we go into data validation, and here I can either feed in the values, that is such as Bangalore. I could basically say something like this, Kolkata, and I could say OK. So now if you see, it shows me the places in Kolkata. Now here we have, let's choose a different city. So for example, let's go for Delhi, and here I can go to data validation and I can just say Delhi. So this is an easier way of doing it. Or if you remember the formula, then what you can do is you can just give in indirect and then basically give the value of the cell for which you would want to keep in the values. So this is how you can do list validation. So you can provide a list of values and then you can restrict the values in a cell which should be belonging to a particular list. So this is how you do a simple data validation by restricting the data in the form of a list. Now let's learn about pivot charts and tables, which is one more very useful feature of Excel and which allows you to work with your data or perform data analysis. Now, pivot table is a summary of your data. It is used in cases where there are numerous rows and columns in your data set, and it allows you to group your data in several ways so that you can derive meaningful information from it. Now, the visual representation of a pivot table is termed as a pivot chart. Now, how do we do that? So let's see an example. Now, here is some data. Here you see we have some row labels, which basically gives me some category of items here. It also tells me the sum of sales, and basically it gives me per item what is the total sum of sales which were made. Now, how do I get this here? So for example, if I would want to delete this, and I would be interested in getting the total sales under each category of items. Now we know that we have different data here and it's huge. For example, on the row end, if I just do a control and right arrow, it tells me what's my right last column. And if I just do a control and down arrow, it tells me there are 9,994 rows. Now I can use this, and what I can do is I can basically work on insert and go to pivot table. Now this basically tells you need to choose the range. Now since I have chosen my first row and first column, it basically has selected the data, and that's fine. Now do you want the result in a new worksheet? I'll say existing worksheet, and I can choose a location. Now that basically needs me to select a field. Might be we can just select this field, and that should be good enough. So for example, if I close this or if I say OK, so this is basically an indication that my pivot table will be created. Now, what are the fields we are interested in? So as per the problem, we need to find out what are the total sales for each category. So let's go in here and let's select the field category. Now, as soon as you do that, it shows that the rows which are being selected are for this column category. And now we are interested in getting the sales. So we would want the sales per category. So let's select this. So you see sum of sales is selected. Now close this, and that's it. That's your data. So it shows you row labels. It tells you what are the different categories, and it also gives you sum of sales, which is per category. Now this is one easy example where we have solved the problem, where we have tried to find what were the total sales under each category of items. So for example, let's have another data set. So again, you can just check how many rows we have, and it is basically the same, 9,994. And if I look in columns, it basically shows me profit is the last column. And here we would want to find out which category. So for example, let me get rid of this. Which subcategory of items sold the maximum under each category? So we have some categories here which says furniture, and it shows some subcategories, and then it shows me office supplies, and then some subcategories, and same thing with technology. Now we know how we got this data, but this is different than what we were seeing here. So here we were just getting the categories, but we did not have any breakdown of subcategories within this particular category. And here you see there is a breakdown, and then basically you can also apply a filter which basically says what is the data you want, and if you are interested in finding out a particular value. Now how do we do this? So for example, let me get rid of this. Now we know how we can find out the category of items, but we would want to find out which subcategory of items sold the maximum under each category. So here we are not looking at sales, but we are looking at the quantity. Okay, so what we can do is we can go to the first row and first column, click on insert, click on pivot table. Data is already selected. Let's choose existing worksheet. Let's choose a location in our worksheet where we would want to have this. So might be I can select this particular field and then just close this. So it says this is the existing worksheet. Say OK, and now you need to select your columns. So for example, if I would want the data for categories, so I can select this. Now I know that within category, these are the options which we have, and then there is a subcategory. So let's select that. And if you see here, now we have the data which will be filtered. So based on your category and subcategory, and then we will choose quantity. So it automatically understands that this is something on which summation can be done. So let's select this and close on this. Now if you see here, we have got our items where we can see the subcategories within a particular category. Now I can basically close this, and that just shows me high level categories here. So here I can again select a particular row and column. I can go for either a new pivot table. So we could basically select this. The row is already selected. Existing worksheet is what I want. So now I will select this particular place. Say OK. Now we do the same thing like what we did earlier. So we will select category, subcategory, and quantity. So the data has already come in. Just select this, and now you already have all your data. But this is not what we want. We want to basically apply a filter to this. Now how do we do that? So we can go for slicer. So I can go for insert slicer, and then it tells what are the subcategories which you are interested in. So for example, if I go for something like subcategory and say OK, so this tells me what are the categories you are interested in. So for example, we know that furniture has furnishings with the highest value. So I can select, say, furnishings, and then I was interested in office supplies. So within office supply, I can basically search for here binder. So I can just do a control and select binder. And then I can also know for technology, I can select phones. So I'll say control and select phones. And now if you see, the filter has been applied and we have these subcategories which are selected. So we have our data here. Now we don't need really this. So I can just delete this and I have my data which shows me furniture being the main category, and that has only furnishings, office supply having binders, and technology having phones, and that basically is a filter applied on the result of your pivot. So this is how we are seeing which subcategory of items were sold maximum for each category. So this is how you can easily use pivot tables and you can do some analysis. Let's look at some more examples. Now, let's see if you have to answer this question, which says which were the top 3 states for each region that made the highest average profit. Now, how do we calculate that? So for example, this is the data we have, and as I've instructed earlier, you can select the first row and first column. You can click on insert, go into pivot table, and that basically selects all your data. We will choose the result should be in this existing worksheet. So select this, click here, and then basically let's select this cell and I will say okay. So now my pivot table will be here. So we are interested in finding out top 3 states within each region which have made the highest profit or which have made the highest average profit. So for that, first we will select region. So when we select region, it shows here region, and within region you will then select state. So within every region you have multiple states, so that's what we are selecting. And then we are interested in looking at the profit, so let's select profit, and that automatically shows up here. So we can now say close this. So basically we have all the data, but we are looking at the sum of profit, but that's not what we want. We are looking for top 3 states from each region that made the highest average profit. Now, how do we change that? So here we have sum of profit. So I can do a right click and basically I can say summarize values by average. So now I'm getting the average here, and that basically tells per region I have the average profit. But first is let's sort this data. So let's go into sort more options, and here I have average of profit. Or for example, as I said, you can select region, say okay, and now it is basically having the regions, and then you have your state value. So again we can do a sorting here, and I can say let's go for more sort options. I'll say descending, the state values should be based on average profit. So let's say okay, and now if you see in particular region we have the data which has been sorted, wherein you have the highest average profit on the top. Now what we can also do is we can basically then go for filtering. We can say top 10, but I'm not interested in top 10, so I could reduce this to top 3, and this is the items average of profit, say okay. And now you see per region you have the data which is showing me top 3 states, what are the average, and then you are also looking at the subtotal, so which basically says average profit for your west. Now if you would want to arrange this, your west and south and east and central in a particular alphabetical order, if you would want to sort it, you can always do a sorting, and you can choose sort Z to A, if that's what you would want to do, or you can go for sorting, more sort options, and you want to sort the region, which is as of now based on descending Z to A. Let's make it ascending. Say OK. And now you see the data has been filtered. So it says per region. Now you can always select this and you can say, what is this? So this is basically your average of profit. Now we are looking at each region and the states, the top 3 states as we wanted within a region, and what is the average. Now we have one more question. What is the percentage contribution of each subcategory of products under each category to the total sales? So we know there are different products, there are different categories, and all the categories contribute to the total sales. So we would want to find out what is the percentage contribution of each subcategory of products under each category. So we not only want the category percentage, but we would also want what is the contribution of each subcategory to each category to the total sales. How do we do that? So for that, we need to again just place our cursor here or select the first row and first column, click on your insert, click on your pivot table, and now the data is already selected, existing worksheet. Place your cursor here, and then let's select this cell, say OK. Now your pivot table fields are here, so we are interested in category. So let's select category, and then within a category we will have subcategories, and we are interested in the sales data, wherein it is already going to give us the sum of sales, but we would want this in the form of percentage rather than just the sum. Now we can click here value field settings, and it says if you would want to summarize this, it says show value as, and what are the values you would want. So you can straight away go ahead here and say percentage of grand total. So we could do that because we know we will get a sum of sales and grand total. Now I could basically say percentage of grand total, say OK, and then just close this. So once you have closed this, you see already the data is in percentage. So now we have our data with subcategories, but we also want the data to be sorted, might be in a descending order, which tells which subcategory is contributing more than others. We can select how many subcategories we are interested in. So we can basically select one of the subcategory cells, right click. Now you have option filter and you have sorting. So we can say more sort options. Now here I will say descending, and you want the descending to be sum of sales, which is already showing as percentage. Click on OK, and now you see for each category it shows the percentage contribution towards the sales. It shows the subcategories contribution to a particular category and also to total sales. So technically speaking, if you look at all these values which are subcategories, and if you would total them, that would be your total grand total. So this is how we can solve a simple problem like this. What is the percentage contribution of each subcategory of products under each category to the total sales? The next question is, which customer made the lowest profit in the home office segment in each state? Now here we know that we are looking for home office segment. We are looking for customer which made the lowest profit. We are also looking for the state as the main criteria. So in each state, we would look for home office segment, and within that we would look for customer which has made the lowest profit. That means the lowest value of the profit. So how do we do this? So let's get into selecting our row and column. We will go into insert. I'll say pivot table. I'll say existing worksheet, and let me get my result here. So let's say OK. Now that gives me the pivot table. So the first thing is we are looking at per state, and I would be interested in home office segment, or I could first start with segment. Now here we have segment, and in segment I can basically select home office, so I can just do a uncheck and select home office only, and now I can select state. So that will be my subcategory within segment, and then within state we would want to find out the customer. So let's get the customer name, and we are interested in finding out the lowest profit, so let's select profit, and here we have sum of profit. So the fields are selected, close this, and now you have your data, which basically shows me the names of customers which made the profit, but it's not sorted. So we can sort this, and we have state entries also, so that's fine. So what I can do is here I can basically say sorting, go to more sort options. I can say I want to do a descending, or I want to do an ascending based on sum of profit. So let's do that. Now you see the topmost value is the lowest value per state within home office segment. Now what we also want is we just want one value per state. So how do we do that? So we can just go for filtering, go for top 10 values. I'm interested in bottom value, and in that also I'm looking for only the lowest value. So let's select 1, say OK, and now you see we have data for home office segment per state customer who has made the lowest profit. So we have easily answered this question using our pivot table. Now say for example we have a question which says find the sales made in each quarter of 2016 for all the regions. So the data has to be divided quarterly, and use order year as a slicer. We can do that by selecting what data we would want to slice, and then we would want to create a pivot chart also. So for example, how do we do that? So for example, I will get rid of this, I will get rid of this, my pivot chart, which we can recreate. So find the sales made in each quarter of 2016 for all the regions. So this is what we want. Now how do we do this? So for example, let's select this. We will do a insert pivot table. We will basically say existing worksheet, and then I can select this particular cell. I'll say OK, and now I'm interested in data quarterly. So first let's select our field here. So we should basically have, if all our fields are selected, say for example if I say order date, now you see we have quarters and years which are selected. Now we could be selecting these fields which says quarters, years, and if I would want data to be filtered based on years, I could do that, or I could get rid of years. So I have quarters, I have order date. So that's being already selected. Now what else we need? We need to find out for every region. So let's select the region, and we can also add region as a column here. So that will basically give me all the regions as different columns. And then finally we want the sales. So let's select this, and now let's look what we have. So if you see here, we have our data which is for each quarter. It gives me the total data, but what we would be interested in is not looking at the total data, but we are only interested in quarter of 2016. Now how do we do that? So what we do here is we have row labels. So let's click on this. So we have date filters, and then in date filters we can go for between, and then we will say 2016, and the value has to be 1. And then let's select this and let's change this to 2016, and this is 12th month, and then we can say 31. So we are saying the date has to be 2016, and it basically says not a valid date. So let's select a particular date and see. So the month has to be here. So let's change this and let's make it date and say okay. And now we have our data, which is for 2016. So for example, I could basically select this, and here I could be looking at what are the filters we have. So it says clear filter from order data. So we have applied the filter on order date, and these are your date filters, which is basically date 16. Oh, this is wrong. So this one has to be changed to 2016. So select this, and now we have our data for 2016. So we have found the sales made in each quarter of 2016 for all the regions, the grand total for a particular quarter if we are looking at the value, or for individual months in a particular quarter. And we have sliced the data. Now we could have also introduced a slicer by selecting which field we would want to implement. So for example, if I would select a particular field and then I could click on slicer, I could choose I would want to slice the date based on order date, and then could have done it. Or we have just given the date for 2016. Now we just need to plot a graph for this, and that's very easy. So you just need to select the complete pivot data, and here you have the chart options. So let's go for line chart, and that basically shows me the line chart. So we can select this, we can just drag and drop it here, and then we can basically check if that is showing us the data. So if you see here, this is line chart where it has divided the regions in different colors. So we have all the regions. We could filter out in pivot chart a particular region. We have the quarterly time here. In order data, the filter is applied. It says it is 2016. In quarters, it tells me it is 16. So we have our data, we have created a pivot chart, and basically we have sliced the data for 2016. Let's answer one more question, and that's finding the profit made in each year for all the categories of products in East and West regions only. And then we would want to create a histogram for the same pivot table. So histogram usually gives us the frequencies. So let's look at how do we calculate the profit made in each year for all the categories. So what I can do is I can basically select my row ID here, and now I'll do a pivot table. So the data is already selected. I'll choose existing worksheet. Let's select this particular cell, say okay. Now what are we interested in? Now if you look at the fields, we don't see any years or quarters and so on. So for example, here I can just choose order date, and then basically I can choose, say for example, years or quarters, the data which is coming out from my order date. So here I will just select years. Now then I have my order date. So we are interested in the years, orders, and we are interested in, let's look at our column or the question what we had here. So we have years, find the profit made in each year. So let's select profit. So that basically says sum of profit. But then I'm also interested in for all the categories of products. So what I can do is here I have my field which is category, and that I'll add to the columns. So that shows me what are the different categories. And this looks fine. Now I'm also interested in east and west regions. So that is basically in the region. So either we could add a slicer or we could do a filtering here by adding the filters. So first is I'll click on region, and here it says select all. I'm only interested in east and west. So let's select this, take this, put it here. Let's say OK. And now we have the data which has been filtered based on the region. So here we have region. So you can always look at the filter. It is east and west. And we have our year data per year. We have different categories. You can always look at what are these column labels. So this is my different categories, and this is the profit per category, and then you have your grand total. So we have already our data. Now let's say close this. So we have our data for all these years, different categories, the profits made per year. And if I would want, I could go into an year and I could look into different months. So that also is showing up. And now we would want to basically plot a histogram with this data. So I can just place my cursor here. I can select this, and then I can go into insert, and here I have different options. So we can go for bar chart, we can go for insert hierarchy chart, we can go into waterfall, funnel, stock, surface, or radar chart. So there are different options what you have here, and we will go for a simple histogram which is two-dimensional. Let's select this, and here you see you can obviously select different regions. You have your years which shows up, you have your order date, and then you have your categories which can be chosen for your histogram or for your bar chart. And that basically is how you use your pivot table. You use some calculations, and then you can plot your needed graph to visualize the data and understand it in a better way.
So let's start with what is Numpy. Numpy is the core library for scientific and numerical computing in Python. It provides high-performance, multi-dimensional array object and tools for working with arrays. And I'll go a step further and say there are so many other modules in Python built on Numpy. So the fundamentals of Numpy are so important to latch onto for the Python, so that you can understand the other modules and what they're doing. Numpy's main object is a multi-dimensional array. It is a table of elements, usually numbers, all of the same type, indexed by a tuple of position integers. In Numpy, dimensions are called axes. Take a one-dimensional array, or we have, and remember dimensions are also called axes, so you can say this is the first axis, 0, 1, 2, 3, 4, 5. And you can see down here it has a shape of 6. Why? Because there's 6 different elements in it in the one-dimension array. And they usually denote that as 6 comma with an empty node on there. And then we have a two-dimensional array where you can see 0, 1, 2, 3, 4, 5, 6, 7. And in here we have 2 axes or 2 dimensions, and the shape is 2, 4. So if you were looking at this as a matrix or in other mathematical functions, you can see there's all kinds of importance on shape. We're not going to cover shape today, but we will cover that in part 2. Did you know that Numpy's array class is called NDArray for Numpy Data Array? Now we're going to take a detour here because we're working in Python, and 2 of my favorite tools in Python is the Jupyter Notebook, and then I like to use that sitting on top of Anaconda. And if you flip over to jupyter.org, that's jupyter.org, you can go in here. You can install it off of here if you don't want to use the Anaconda Notebook, but this is the Jupyter setup, the documentation on the Jupyter. Jupyter opens up in your web browser. That's what makes it so nice, is it's portable. The files are saved on your computer. They do run in IPython or IronPython, and you can create all kinds of different environments in there, which I'll show you in just a minute. I myself like to use Anaconda. That's www.anaconda.com. If you install Anaconda, it will install the Jupyter Notebook with the Anaconda separate. And you can install Jupyter Notebook and it'll run completely separate from Anaconda's Jupyter Notebook. And you can see here I've now opened up my Anaconda Navigator. What I like about the Navigator, and this is a fresh install on a new computer, which is always nice. I can launch my Jupyter Notebook from in here. I can bring other tools, so the Anaconda does a lot more. And under environments, I only have the one environment, and I can open up the terminal specific to this environment. This one happens to have Python 3.7 in it, the most current version as of this tutorial. And then you open a terminal if you're going to do your pip installs and stuff like that for different modules. You can also create different environments in here. So maybe you need a Python 3.6, Python 3.5. You can see we're having a nice framework like Anaconda really helps. So you don't have to track that on your own in the Jupyter Notebook and your different Jupyter Notebook setups. We'll go ahead and launch this Jupyter Notebook. And then I've set my browser window for a default of Chrome. So it's going to open up in Chrome. And you can see here, this opens up a folder on my computer. We have a couple different options on here. Remember, I set the environment up as Python 3.7. You would install any additional modules that aren't already installed in your Python on this. And it keeps them separate, so you do have to, for each environment, install the separate modules so they match the environment on there. And in here we have a couple things where you can look up what's running. You have your different clusters. Again, I just installed this on a new machine, so I just have a couple things in here that were run on here recently. And where we go on here is we then have on the upper right, New, and from the pull-down menu you'll see Python 3, and this will open up a new window. And now we're in Jupyter Python, so this is a Python window, and we'll just do a print. And this, of course, let's go hello world. And we'll run that, and it prints out hello world in the command line. There's a couple special things you have to know what we're not going to do today, which is on graphics. If you've never seen this, one of the things you can do is you can also do A equals hello world. And if you just put the A in there, now if you do a bunch of these where you have A equals hello world, B equals goodbye world, and you put A, B, A, then return B, it'll only run the last one. But you can see here, if you put the variable down here, it will show you what's in that variable. And that has to do with the Jupyter Notebook inline coding. So that's not basic Python, that's just Jupyter Notebook shorthand, which you'll see in a little bit. So back to our Numpy array versus Python list. Python list being the basic list in your Python. Why should we use Numpy array when we have Python list? Well, first, it's fast. The Numpy array has been optimized over years and years by multiple programmers, and it's usually very quick compared to the basic Python list setup. It's convenient, so it has a lot of functionality in there that's not in the basic Python list. And it also uses less memory, so it's optimized both for speed and memory use. And let's go ahead and jump into our Jupyter Notebook. Since we're coding, best way to learn coding is to code. Just like the best way to learn how to write is write, and the best way to learn how to cook is cook. So let's do some coding here today. And just like any modules, we have to import Numpy. We almost always import it as NP. That is such a standard. So you'll see that very commonly. We can just run that. And now we have access to our Numpy module inside our Python. And then the most common thing, of course, is to go ahead and create a Numpy array. And in here, we can send it a regular list. And so we'll go ahead and send this a regular array. Let's go 1, 2, 3 to make it simple. And then I'm just going to type in A, and we'll run this. And so you can see down here, the output is an array of 1, 2, 3. And we could also do print, just a reminder that this is an inline command, so that wouldn't work if you're using a different editor. You can see that it's an array 1, 2, 3. But we'll go ahead and leave it as A. Kind of a nice feature so you can see what you're doing really quick in the Jupyter Notebook. And just like all your other standard arrays, I can go A of 0, which is going to be a value of 1. Of course, we do A of 1. You go all the way through this. A of 1 has a value of 2 in it. So whether you're using the Numpy array or the basic Python list, that's going to be the same. That should all look pretty familiar and be pretty straightforward. Remember, the first value is always 0 and when we set on there. So let's take a look why we're using Numpy, because we went over the slide a little bit, but let's just take a look and see what that actually looks like. And what we want to look at is the fact that it's fast, convenient, and uses less memory. So let's take a glance at that in code and see what that actually looks like when we're writing it in Python and what the differences are. And to do this, I'm going to go ahead and import a couple other modules. We're going to import the time module so we can time it. And we're going to import the system module so that we can take a look at how much memory it uses. And we'll go ahead and just run those so those are imported. And so we'll do B equals range of 1. Yeah, 1000 is fine. And so that's going to create a list of 1,000, 0 to 999. Remember, it starts at 0 and it stops right at the 1,000 without actually going to the 1,000. And let's go ahead and print. And we want system.getSize of. And we'll pick any integer because we have, 0 to 1,000. We'll just throw one in there, 5. It doesn't matter because it's going to, whatever integer we put in there is going to generate the same value because we're looking at the size of how much memory it stores an integer in. And then we want to have the length of the b. That's how many integers are in there. And if we go ahead and execute this and run this at a line, we'll see, oops, I did that wrong, comma. If we multiply them together, we'll see it generates 28,000. So that's the size we're looking at, is 28,000. I believe that's bytes. That sounds about right. So let's go ahead and create this in Numpy. And we'll go C equals NP. And this is a range. So that's the Numpy command to do the same thing that we were just doing in a list. And we'll also use the same value on there, the 1,000. And then once we've created the value of C for np.arange, let's go ahead and print. And we can do that by doing c.size times c.item size. And that's very similar to what we did before. We did get the size of, so the C size is the size of the array, and each item size, just reversed. So it's the size of an integer 5, item size is going to be the integers, and C size. And let's just take a look and see what that generates. And wow, okay, we got 4,000 versus 28,000. That's a significant difference in memory, how much memory we're using with the array. And then let's go ahead and take a look at speed. Let's do size. We tried this with lower values, and it would happen so fast that the NP array kept coming up with 0 because it just rounded it off. So size, and let's create an L1 equals range of size, and we'll do an L2. We'll just set up to the same thing. It's also range of size on there. There we go. And then we can do on A1 equals np dot arange size. And then let's do on A2 equals np dot arange. We'll keep it the same size. And what we're going to do is we're going to take these two different arrays and we're going to perform some basic functions on them. But let's go ahead, actually let's just load these up now. We'll go ahead and run this so those are all set in memory. Except for the typo here. Quickly fix that. There we go. So these are now all loaded in here. And let's do a start equals time.time. So it's just going to look at my clock time and see what time it is. And then we'll do result equals, and let's do, let's say we got an array, and we're going to say, let's do some addition here. X plus Y for X comma Y, and we'll zip it up here. Two different arrays. So here's our two different arrays. We're going to multiply each of the individual things on here. L1, L2. There we go. So that should add up each value. So L1 plus L2, each value in each array. And then we want to go ahead and print. And let's say Python list took. And then we'll do time dot time. We'll just subtract the start out of there. So time, whoops, I messed up on some of the quotation marks on there. Okay, there we go. Time minus the start. And we'll convert that to seconds. So we'll go, because that's in milliseconds, so times 1,000. And let's hit the run on there. This is kind of fun because you also get a view while we're doing this of some ways to manipulate the script. And as you can see also my bad typing. There we go. Okay, so we'll go ahead and run this. And we can see here that the Python list took 34. Actually, I have to go back and look at the conversion on there. But you can see it takes roughly 0.34 of a second. And we can go ahead and print the result in here too. Let's do that. We'll run that just so you can see what kind of data we're looking at. And we have the 0, 2, 4, 6, 8. So it's just adding them together. It looks pretty straightforward on there. And if we scroll down to the bottom of the answer, again, we see Python list took 46. A little different time on there depending on what core, because this is on an 8-core computer, so it just depends on what core it's running on, what else is pulling on the computer at the time. And let's go back up here and do our start time. Paste that into here. And this time we're going to do a result equals, and this is really cool. Notice how elegant this is. It's so straightforward. This is a lot of reason people started using Numpy is because I can add the two arrays together by simply going A1 plus A2. It makes a lot of sense, both looking at it, and it's just very convenient. Remember that slide we're looking at? Fast, convenient, and less memory. So look how convenient that is. Real easy to read, real easy to see. And I don't know if we don't need to print the result again, so let's just go ahead and print the time on here. And we'll borrow this from the top part because I really am a lazy typer. And this isn't the Python list, this is the Numpy list, or Numpy array. And let's go ahead and see how that comes out. And we get 2.99. So let's take a look at these two numbers, 46 versus 2.99. So we'll just round this up to 3. That's a huge difference. That's like more than 10 times faster. That's like 15 times roughly at a quick glance. I'd have to go do the math to look at it. And it's going to vary a little bit depending on what's running in the background on the computer, obviously. So we've looked at this, and if we go back here, we found out it's much faster. Yes, there's going to be different speeds depending on what you're doing with the array. Very convenient, easy to read, and it uses less memory. So that's the core of the Numpy. That's why a lot of people base so many other modules on Numpy and why it's so widely used. So we did glance at a couple operations while we were looking at speed and size. Let's dive into a little bit more into the basic operations. And these are always nice to see. I mean, certainly you want to go get a cheat sheet if you're using it for the first time. Look things up. Google is your friend. We did this for the most basic numpy.array or np.array. And we'll go ahead and create an array. Let's do pairs, 1, 2. And then let's do 3, 4. And if we're going to do that, let's do 5, 6. There we go. And if we go ahead and take this and run this, I can go ahead and do our A down here so it's in line and it'll print that out. You can see it makes a nice array for us. So we have A, and if you look at that, we have 3 different objects, each with 2 values in them. And hopefully you're starting to think, well, how many dimensions or indexes is that? And you'll see 3 by 2. So let's go ahead and take a look, and let's go, how about A.nDimensions? Speaking of which, we'll run that, and we have 2 dimensions for each object. And then we can do the item size, so A dot. We saw this earlier, where we looked up how many items. It was up here, where we wanted to multiply item size times the actual size of the object. So the memory is being used versus the item size. And we should see 4 there. Memory is compressed down. That's always a good thing. And then the shape. The shape is so important when you're working with data science and you're moving it from one format to another. So we have our shape. We just talked about that. We have 3 by 2. 3 rows by 2 objects in each one. Generally, I don't look too much at the size, but the dimensions I'm always looking up. And this is nice, you can automate it. So you might be converting something, you might need to know how many dimensions are going into the next machine learning package so that you can automatically just have it send that information over. So we looked at A shape. Let's go ahead and create a slightly different array, np.array. Let's go ahead and just do as our original setup here. And one of the features we can do, which is really important, is we can do dtype equals. In this case, let's do np float 64. And so what we've done is we're converting all of these into a float, and we type in A. And now instead of having 1, 2, 3, 4, 5, 6, you see they're all float values. 1.0, there's no actual 0 in there, just there's a 1 dot, or the 1 period, 2, 3 period, 4 period, 5 period, 6 period. And this, again, data science, I don't know how many times I've had to convert something from an integer to a float so that's going to work correctly in the model I'm using. So very common features to be aware of and to be able to get around and use. And we'll also do, let's just curiosity, item size. We'll go ahead and run that. And we see that it doubled in size. So it's not a huge increase. Well, doubling is always a big increase in computers. But it's not a huge increase compared to what it would be if you're running this in the Python list format. And then we did the shape earlier without having it set to the float 64. Let's go ahead and do a shape with it set to 64. And it should be the same 3, 2. So it all matches. So we've gone through, and remember, if this is all brand new to you, according to the Cambridge study at the Cambridge University, if you're learning a brand new word in a foreign language, the average person has to repeat it 163 times before it's memorized. So a lot of this, you build off of it, so hopefully you don't have to repeat it 163 times. But we did manage to repeat it at least twice here, if not a little bit more. And let's go ahead and take this. We're going to go look at one more setup on here. And let me just take this last statement here on the converting our properties of our data. And instead of float 64, let's do complex. Let's just see what that looks like. And let's go ahead and print that out and run it. And so we now have a complex data set up, and you'll see it's denoted by the 1 dot plus 0 dot j. And if we flip over here and do a basic search for Numpy data types, better to go to the original web page, but pull up a bunch of these. You can see there's a whole list of different Numpy data types. Shorthand, complex, we have complex, complex 64, complex 128. Complex number represented by two 64-bit floats, real and imaginary components. One option on there, float 16, float 32. Float, shorthand for float 64, most commonly used. And of course all the different ones that you can possibly put into your Numpy array. So we covered a basic addition up there when we were comparing how fast it runs. But some very basic components, how to set up a Numpy array, how many dimensions it has, item size, data type, again we went to item size, and there's also the shape. Probably one of the more used. I use a shape all the time, very commonly used. And then down here you can see where we actually created a Numpy complex data type. So let's look at some other features in Numpy. One of them is you could do Numpy dot zeros, and we're going to do 3, 4. There we go. And we'll go ahead and run this, and you can see if I do np.zeros, I create a Numpy array of zeros. This is really important. I was building my own neural network, and I needed to create an array where I initialized the weights, and I wanted them all to be the same weight. In this case, I wanted them to start off as 0 for the particular project I was working on. And there's other options, like you can do Numpy 1s, and we'll do the same thing, 3, 4, we'll run that. And you can see I've created an array of Numpy 1s. In this case, it comes out as a float array. And then this is an interesting to note, because we have, let's go back to our Python and do L range 5, and we'll print the L, so that's our list. And if I run that, it doesn't create the range until after the fact, until you actually execute it. That's an upgrade in Python. Python 2.7 actually created the array, 0, 1, 2, 3, 4. This one actually creates the script, and then once it's used, it then actually generates the array. And if we do that in Numpy A range, remember that from before, and if we do Numpy A range 5, and let's do L equals, or we can just leave it as Numpy, that's fine. There we go, just run that. You can see there we actually get an array, 0, 1, 2, 3, 4 for the value of the Numpy A range 5. It generates the actual array. And for part 1, we're going to do just one more section on basic setup, and we're going to concatenation, do a concatenation example. There we go. We're going to do strings. Let's take a look at strings and what's going on with there. And let's do, let's see, print. Let's do an NP character, something new here. And we're going to add, and then here's our brackets for what we're going to add. And let's say, let's do hello, comma, hi. And in the brackets on there, let's create another one. and this one's going to be ABC, and we'll do XYZ. So we're just creating some, randomly making some up on here. And then we'll go ahead and just print this. If we run that, you can come down here, and of course make sure all your brackets are open and closed correctly. And then you can see in here when we concatenate the example in Numpy, it takes the two different arrays that we set up in there and it combines the hello with the ABC and the hi with XYZ. And if we can also do something like print, let's do np character dot multiply. So there's a lot of different functions in here. Again, you can look these up. It's probably good to look them all up and see what they are, but it's good to also just see them in action. And let's do hello space, comma, 3, and we'll run this one and run that without the error. And you'll see it does hello, hello, hello. So we multiplied it by 3. And we can also, and let's just take this whole thing here instead of retyping it. And we can do character center. So instead of multiply, let's do center. And over here, keep our hello going. Take the space out of there. And let's do center at 20. And fill character equals, we'll fill it with dashes. So if we run this, you can see it prints out the hello with dashes on each side. And we keep going with that. We can also, in addition to doing the fill function, we can play with capitalize, we can title, we can do lowercase, we can do uppercase, we can split, split line, strip, join. These are all the most common ones. And let's go ahead and just look at those and see what those look like, each one of them. Here we're going to do the hello world, all-time favorite of mine. I always like to say hello universe. And you can see here we did a capital H with the world, but so we want to capitalize. So capitalize is the first one in the array. So we get hello world on there. And we can also take this, and instead of capitalizing, another feature in here is title. And let's just change this to how are we doing? How are you doing? Instead of we, we'll do you. And let's run that. And you can see here, because we created it as a title, it capitalizes the first letter in each word. And in this one, we're going to do character lower. Two different examples here. We have an array. We have hello world all capitalized, and we have just hello. And you can see that one is an array and one is just a string. If we run that, you get an array with hello world lowercase and hello lowercase. And if we're going to do it that way, we can also do it the opposite way. There's also upper. And let's paste those in there. And you can see here we have character.upper, opposite there, python.data, and we'll do Python is easy. Hopefully you're starting to get the picture that most of the Python and the scripting is very simple. It's when you put the bigger picture together and starts building these puzzles and somebody asks you, hey, I need the first letter capitalized, unless it's the title, and then you start realizing that this can get really complicated. So Numpy just makes it simple, and we like that. And so in this case we did Python data, it's all uppercase, Python is easy, like shouting in your messenger, Python is easy. And then if you're ever processing text and tokenizing it, a lot of times the first thing you do is we just split the text, and we're just going to run this np.character.split, are you coming to the party? If we do that, it returns an array of each of the individual words. Are you coming to the party, splitting it by the spaces. And then if you're going to split it by spaces, we also need to know how to split it by lines. And just like we have the basic split command, we also have split lines. Hello, and you'll see here the scoop in for our new line. And when we run that, if you're following the split part with the words, you should see hello, how are you doing? The two different lines are now split apart. And let's just review 3 more before we wrap this up. Commonly used string variable manipulations. We have strip, and in this case we have Nina, admin, Anita, and we're going to strip A off of there. And let's see what that looks like. And then you end up with nin, demin, nate. It basically takes up all leading and trailing letters. In this case we're looking for A. More common would be a space in there, but it might also be punctuation or anything like that that you need to remove from your letters and words. And if we're going to strip and clean data, we also need to be able to reformat it or join it together. So you see here we have a character join. We'll go ahead and run this. And it has on the first one, it splits each of the letters up by the colon and the second one by the dash. And you can see how this is really useful if you're processing, in this case, a date. We have day, month, year, year, month, date. Very common things to have to always switch around and manipulate depending on what they're going into and what you're working with. And finally, let's look at one last character string. We're going to do replace. If you're doing misinformation, this is good, pulling news articles and replacing is and what. In this case, we're just doing he is a good dancer. We're going to replace is with was. And you can see here, he was a good dancer. Hopefully that's not because he had a bad fall. He just was from like, 1920s and has gotten old. So there we go. We've covered a lot of the basics in Numpy as far as creating an array. Very important stuff here when you're feeding it in. How do we know the shape of it, the size of it? What happens when we convert it from a regular integer into a float value as far as how much space it takes? We saw that doubled it. Item size, you have your in dimensions, and probably the most used is shape. And we'll cover more on shape in part 2. So make sure you join us on part 2 because there's a lot of important things on shape in there and setting them up. We also saw that you can create a zeros-based array. You can create one with ones. If we do a range, you can see how it is a lot easier to use to create its own range, or a range as it is in Numpy. You saw how easy it was to add 2 arrays. We saw that earlier, just plus sign. Then we got into doing strings and working with strings and how to concatenate. So if you have 2 different arrays of strings, you can bring them together. We also saw how you can fill, so you can add a nice headline, dash, dash, dash. We saw about capitalize the first letter. We saw about turning it into a title, so all the first letters are capitalized. Doing lowercase on all the letters, upper for all the letters, just lower and upper, nice abbreviation. We also covered how to split the character set, how to strip it. So if you want to strip all the A's out from leading A's and ending A's or spaces, you can do that very easily. Also how to join the data sets. So here's a character join option for your strings. And finally we did the character replace. Now let's go ahead and dive in there since we're going right into part 2, which is getting some coding going under our belt. And here in our Jupyter notebook, we can go under New and create a new folder, Python 3. I think I forgot to do this last time, but we could just do the Control++, which in any browser enlarges a page, makes it a lot easier to see. Always a nice feature. Another beautiful benefit of using Jupyter Notebook. And let me go ahead and show you a neat thing we can do in Jupyter. This is nice if you're working with people and you're doing this as a demo on a large screen. I'm going to do the hashtag or pound symbol array manipulation, kind of a title of what we're working on. And then I'm going to call this cell type markdown as opposed to code. And you'll see it highlights it here, and then if I run it, it just turns it into array manipulation. And then we're specifically going to be working on array manipulation, changing shape to start with. And we'll go ahead and mark this cell also a markdown, so it has a nice little look there. And then it comes up, and you can see it, just like I said, it just highlights it and makes it in bold print, just making it easier to read. Not a Python thing, but a Jupyter thing that's good to know about, especially if you're working with the shareholders, since they're investing money in you. Of course, the first thing we want to do is import. We're going to import Numpy as in P, and that should be standard by now. By now, you start a Python program, you're doing some data science. Numpy is just something you bring in there. And let's go ahead and create our array, and we're going to do that as the np.arange. Remember, that's 0, well, we're going to do 0 to 9, and then we'll go print, put a little title on the original array. We'll just print that array A. Remember from the first lesson, so we have our array which is 0, 1, 2, 3, 4, 5, 6, 7, 8. And let's add a print space in between. Let's create a second array, B, but we want this to reshape array A. And what does that mean? And the command is simply reshape, and then we have 9 items in here, and this is so important right now. So be very aware, if I did some weird numbers in here, it's not going to work. And we want multiples of 9. We know that 3 times 3 is 9. So we're going to reshape our A array by 3 by 3. And then we're going to print, well, let's give it a title. Oops, I added too many brackets in there. Modified array, and then let's go ahead and print our B. And let's see what that looks like. And as we come down here, you can see we've taken this and it's gone from 0, 1, 2, 3, 4, 5, 6, 7, 8 to an array of arrays. And we have 0, 1, 2, 3, 4, 5, 6, 7, 8. And so we split this into 3 by 3. And you can guess that if I tried to reshape this, let's just do a 5 by 3, which is 15, that's going to give me an error. So it's not going to work. You're not going to be able to reshape something unless the shape, all the data in there matches correctly. So we can take this flat 9, and they call it a flat because it's just a single array. And we can reshape it into a 3 by 3 array. And first you might think matrices, which this is used for that, definitely. I use it a lot in graphing because it'll come in that I have an array that's xy, comma xy1, y1, comma x2, y2. And so the shape of it might be 2 by the length of the number of points. And I need to separate that into x flat array and a y flat array. And you can see this can be very easy to reshape the array doing that. And we can of course go back. We can do b, do a print, and we'll do b dot flatten. Remember I said it's called a flatten array? And if we run that, you'll see it just goes back to the original one. It takes this 0, 1, 2, 3, 4, 5, 6, 7, 8 and flattens it back to a single array. And then one other feature to be aware of is if we flatten it, one of the commands we can put in there is order. Let me just go ahead and do that. Order equals F. Strangely enough, F stands for Fortran. The whole Fortran days. I remember actually studying Fortran programming language. In this case, you'll see that it uses the first, like 036 is the order. So instead of flattening it like we had before, 0, 1, 2, 3, 4, 5, 6, 7, 8, it now does 0, 3, 6, 1, 4, 7, 2, 5, 8. And if you go to the Numpy array page, you can see here that they have the flatten. I just open up the Numpy ND array flatten setup to look it up. And they have 3 different options. They have C, F, and A. And it's whether to flatten in C, which was based on how the C code works for flattening, or originally worked, which is row major. Fortran, which is column major, or preserve the column Fortran ordering from A. So whatever it was in, the default is the C version. So the default that you saw, you could put order equals C and it'd have the same effect as we saw there before. You could even do order equals A. That would also have the same effect because that's the default. So really the only other thing you really should change on here is to change it to C if you need it. And you can see right here, or F, I mean not C. The only thing you really want to change it to is to your F for the Fortran order, which then does it by column versus by row. And let's look at, here we go, reshape. So let's create a range of 12, and let's reshape it. And we'll do 4, 3 for this one. And remember this is Numpy. I forgot the NP there. np.arrange. And we can type in just A for print, or you can do full print A. And of course in Jupyter Notebook you even have a little extra print at the beginning. If we run this, we'll see we create a nice array of 0, 1, 2. It's reshaped it. So we have 4 rows and 3 columns, or you could call that 3 columns and 4 rows. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But this one is so important. We'll do np transpose A. Let's go ahead and run that. And it helps if I get all the S's in there and don't leave an S out. And you'll see here we've taken our array. If you remember correctly, we had 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And we've swapped it. So we've gone from a 3 by 4 or a 4 by 3 to a 3 by 4. And this really helps if you're looking at like a huge number of rows and the data all comes in. Like let's say this is your features in row 1, your features in row 2, and this is X, Y, Z. Well, when you go to plot it, you send it all of X in one array, all of Y in one array, and all of Z in another array. And so it's really important that we can transpose this rather quickly. This is kind of a fun thing. I can highlight it and do brackets around it, and if you remember correctly, because we're in Jupyter, it doesn't matter where we do the print or not. It'll automatically print it for us. And you see if I hit the run button, it comes up at the same exact thing. And let's play with the reshape. And you know what, let's zoom this up a little bit here. Make that even bigger so you can really see what's going on. And let's play with the reshape just a little bit more. We'll do b equals np.arange. Let's do 8. And reshape. We'll do 2, 4. Let's go ahead and print B and then run that. And you'll see we have now the 2 rows. This is a bit more like, so we have 4 maybe 2 rows of 4 things, or this might be all of our X components and our Y components. So we can switch it back and forth real easy. Important to note here, whether we do 2, 4, or in the case of 4, 3, this has 12 elements. And so however you split it up, it's got to equal 12. So 4 times 3 equals 12. That's pretty straightforward. Same thing down here. 2 times 4 equals 8. If I change this, and let's say I do 2, 3, let's just run that in, and you'll find we get an error because you can't split 8 up into 2 rows by 3. You have to pick something that it can split up and arrange it in. So let's go ahead and run that. And just for fun, let's go reshape our B again, if I can type. Reshape our B again. And what else goes into 8? Well, we could do 2 by 2 by 2. So we can take this out to 3 different dimensions. And then, of course, if we, because this is going to come out as a variable, we can just go ahead and run it. And it'll print it. We could also do a print statement on there, just like we did before. And you'll see we have 2 different groups of 2 variables of 2 different dimensions. So 2 by 2 by 2. And let's go ahead and assign this to a variable. C equals B reshape. And let's do something a little different. Let's roll the axes. Roll axes. And we'll take our C and do 2, 1. And if we go ahead and run this, it's going to print that out. Whoops. Hit a wrong button there. Let's do that one again. And you roll the axis and you can see that we now have, instead of 0, 1, 2, 3, 4, 5, 6, 7, we now have the 0, 2, 1, 3, 4, 6, 5, 7. So what's going on here? We're taking and we're rolling the numbers around, and let's just simplify this. We'll just do it with C, 1 and run that. And so if we roll a single axis, you got 0, 1, and then it rolled the 4, 5 up, and then we have 2, 3, 6, 7. And if we do 2, let me see what happens there. And this is one of those things you really have to play with and start feeling what it's doing. We've now taken 0, 2, 4, 6, 1, 3, 5, 7. So you can see we've now rolled by 2 digits instead of rolling the 1 setup. We now rolled 2 digits up there. And so if we go back and we do the 1, so we've rolled it up, 0, 1, 4, 5. And then we're going to take the 2 in there. And we've rolled the 0, 1, 2, 3, 4, 5, and 6, 7. So we start rolling these things around on here. There's a lot of different things you can do on this. But it's another way to manipulate the numbers on your Numpy. And finally, let's go ahead and swap axes. We'll do C. And let's just go ahead and run that. It's going to give me an error on there. That's because it requires multiple arguments. Left out the arguments. So now we can swap them. We get the 0, 2, 1, 3, 4, 6, 5, 7. So you can see everything's been swapped around. So next thing we want to go over is we want to go over Numpy arithmetic operations. How can we take these and use these? Let me just go ahead and put this cell as a markdown. There we go. We'll run that so it has a nice thing. All right, nice title on there. That's always helpful. And let's start by creating 2 arrays. We'll do A is an NP range, A range 9. And let's reshape this 3 by 3. So by now you should be seeing this reshape stuff, and this should all look pretty familiar. We have our 0, 1, 2, 3, 4, 5, 6, 7, 8 on there. And let's create a second one, B. And this time, instead of doing A range, let's do NP array. We'll just create a straight up array. And we'll do an array of 3 objects. So it's going to be 3 by 1. And if we go ahead and print B out, we run that. This is actually pretty common to have something like this, where you have a 3 by whatever it is and a 3 by 3 array. When you're doing your math, you kind of have that kind of setup on there. And what we can do is we can go np.add AB. Don't forget, we can always put a print statement on there. So if we add it, you'll see that it just comes in there and it goes, okay, we're adding 10 to everything. And we could actually do something more, make it more interesting. 10, 11, 12. So let's change B's, now 10, 11, 12, and let's run that. And you can see that we have 10, and then you had 1, plus 11 is 12, 2 plus 12 is 14, 13, so 10 plus 3 is 13, 11 plus 4 is 15, and 12 plus 5 is 17, and so on. We'll put this back since that's how the original setup was. Let's do 10 by 10 by 10 and run that and get the original answer. And if you're going to add them together, we need to go ahead and subtract AB. And we run that. We get minus 10, minus 9, minus 8, just like you would expect. So we have our subtraction. 0 minus 10 is minus 10, and so on. And if you're going to add and subtract, you can guess what the next one is. We're going to multiply. And we'll multiply AB. And this should be pretty straightforward. You should expect this. If we multiply 10 times 0, we got 0. 10 times 10 is 10, and so on. And finally, if you're going to multiply, what's the last one we got is divide. What happens when we do divide A by B? And we run this, and we're going to get 0. And this is 0 divided by 10 is 0, 1 divided by 10 is 0.1, 2 divided by 10 is 0.2, and so on and so on. So the math is pretty straightforward. It just makes it very easy to do the whole setup. And again, if we went this, and let's say, let's change this up here. Instead of 10, we do 100. And make this 1,000. There we go. And if we run that, and then we do the add, you can see we got 10 plus 100 plus 1,000. Same thing with the subtract. Same thing with the multiply. And then you can also see the same thing here with the divide. So a lot of control there with your array and your math. Again, let's set this back to 10. Oops, it's right up here, wrong section. There we go, 10. And we'll just go ahead and run these and get back to where we were. And this brings us to our next section, which is slicing. And let's put in our, we'll just make this a cell type markdown. And then we run that. Of course, it gives us a nice looking slicing there. And slicing means we're just going to take sections of the array. So let's create an array np a range. Let's just do 20. And if you remember, if we do A, we have a 0 to 19. And then we can do A, and remember that we can always print these. This can always be put in a print, but because I'm in Jupyter, if you're doing a demo in Jupyter, it's just so great that you have all these controls on here. So we can slice 4 on, and this should look familiar because this is the same as a Python and a lot of other different scripting languages. If we do 4, it goes 0, 1, 2, 3, it's the first 4 in the thing, and it skips some and starts with this one. The first 4 are skipped, and then from there on. You can also do the opposite and go till the 4th one. If we run that, we get 0, 1, 2, 3. Quite the opposite on there. We can do a single item, so we can pick object number 5 on the list, run that, and 5 happens to be 5 because that's the order they're in. And then this one's interesting because I can do s equals slice, and let's create a slice here, and let's do 2 comma 9 comma, yeah, let's leave a 2 on there. So we'll create an s slice on here. And then if we take our array and we do array of s, we're taking our slice in there, and let's go ahead and run that. And let's take a look and see what it generated here. First off, we started with 2, so we have 2 at the beginning. We're going to end at 9, which happens to be 8, so it stops before the 9. Remember when we're doing arrays in Python. And then we step 2, so 2, 4, 6, 8. We could do this as 3. Let me run that, and you can see how that changes, 2, 5, 8. And we could do this as, let's leave this at 3, and if we change this to 10, oops, let's make it 12. There we go. And we run that, we have 2, 5, 8, 11. So that's pretty straightforward. It's a very nice feature to have on here where you can slice it and take different parts of the series right out of the middle. So now that we've access to different pieces of our array, let's get into iteration. And this is interesting because my sister, who runs a college data science division, the first question she asks is, how do you go through data? And she's asking, do you know how to iterate through data? Do you know how to do a basic for loop? Do you know how to go through each piece of the data? And in Numpy, they have some cool controls for that. So put this in as a markdown. There we go, and run it. And it's called the nd-iter. I'm not sure what the nd stands for, but nd-iter for iterator. So before we do that, though, let's create an array or something we can actually iterate through. We'll call it a equals np a range. Let's do something a little funny here, or funky. And we'll do 0, 45, 5. I'm not sure why the guys in the back picked this particular one, but it's kind of a fun one. And if I run that, we do this, you can see we get 0, 5, 10, 15, 20, 25, 30, 35, 40. That's what this array looks like. And that's just from our slice. This is just a slice. That's all that is we created a slice of 0 to 45, step 5. And so what we can do with this, we can also do A equals reshape. Let's go ahead and take and reshape this. And since there's 9 variables in there, we'll do a reshape at 3 by 3. So if we run that, whoops, missed something there. That is the A. That really helps. So if we do the A reshape, and we'll go ahead and print that out, we get 0, 5, 10, 15, 20, 25, 30, 35, 40. And then we simply do 4x in our Numpy nd iter of A colon, and we'll just go ahead and print x. And let's see what happens here when we run through this and we print each one of those. It goes all the way through the whole array, so it's the same thing we just saw before. We got 0, 5, 10, 15, 20, 25, 30, 35, 40. So it prints out each object in the array, so you can go through and view each one of these. And certainly if you remember, you could also flatten the array and just do for A and that also and get the same result. There's a lot of ways to do this, but this is the proper way with the nd iterator because it'll minimize the amount of resources needed to go through each of the different objects in the Numpy array. And hopefully you asked this question when I just did that. And the question is, how can I change this instead of doing each object? So first of all, let's go ahead and take my cell type and we're going to mark that down and run it. And so we're going to work on iteration order C style and F style. Remember C because it came from the C programming and F because it came from the old Fortran programming. So let's give us a reminder. We'll do a print A and we'll do 4x in np iterate A. But we also want to do this in a specific order. And you know what? I'm a really lazy typer, so let's go back up here. This is the nd iterator. I knew I was missing the nd part of A. And let's do order equals C. We'll print X on there. And let's do that again. And this time order equals F. There we go. Order equals F. And let's go ahead and run this and see what happens here. And the first thing you're going to notice, our original array, 0, 5, 10, 15, 20, 25, 30, 35, 40. When we do order C, that's the default, 0, 5, 10, 15, 20, and so on. And then when you come down here, you'll see F, order F, is 0, 15, 30. So it takes the first digit of each of the subarrays, or the second dimension, and then it goes into the second one, 5, 20, 35, 10, 25, 40. So slightly different order for iterating through it if you need to do that. So we've covered reshaping, we've covered math, we've covered iteration, we've covered a number of things. The next section we want to go ahead and go over is going to be joining arrays. So we need to bring them together. Let me go ahead and take the cell and make it a markdown. Cell type markdown. There we go. And run that. So let's work on joining arrays so we can bring them together and what different options we have. And let's do, we'll do an NP array 1, 2, 3, 4. We'll go ahead and print. Let's do, oops, first. Well, these arrays aren't that big, so let's just go ahead and keep it all on one line, A. So if we run this, first array 1, 2, 3, 4. Whoops, I forgot that it automatically wraps it when you do it this way. So we'll go ahead and keep it separate and print A. There we go. And let's go ahead and do a B. And we'll do 5, 6, 7, 8. And notice I'm keeping the same shape on these two arrays. Depending on what you're doing, those shapes have to match. And let's go ahead and print second array. Do a print B. We'll go ahead and run that. Oops. Missed something up there. Let me fix that real quick. When I was reformatting it to go on separate lines, I messed that up. There we go, run. Alright, so we have first array 1, 2, 3, 4, second array 5, 6, 7, 8. And we'll put a carried return on there. And the keyword we use is concatenate. And if you're familiar with Linux, it usually means you're adding it to the end on there. And we're going to do what they call along axis 0. So we have concatenate AB along axis 0. Let's go ahead and run that and see what that looks like. And so we have 1, 2, 3, 4, 5, 6, 7, 8. So now we have an array that is 4 by 2. Has a nice shape of 4 by 2 on here. And if we're going to do it along the axis 0, you should guess what the next one is. We're going to do it along the 1 axis. And let's see how those differ from each other. Let's just go ahead and run that. And again, all we're doing is adding in the axis equals 1. So we have our concatenate, we have AB, and then axis 1. Remember a couple things. One, these are the same shape. So we have a 2 by 2, same dimensions going in there. You're going to get an error if you're concatenating and they're not. If you have something that instead of 1, 2 is 1, 2, 3, 4, 5, 6 with a 5, 6, 7, 8. They'll give you an error on there. In fact, let's take a look and see what happens when we do that. Let me just take this. 1, 2, 3, 3, 4, 5. And let's run that. And if we come down here, oh, we got there. It says all the input array dimensions except for the concatenation axes M must match exactly. So it'll let you know if you mess up. That's always a good thing. Let's go ahead and take this back here, and let's go ahead and run that. And so we have our 0 axes, which is 1, 2, 3, 4, 5, 6, 7, 8. And we bring them together. And you'll see a very different setup here when we do it along the axis 1. We end up with, instead of 4 by 2, we end up with a 2 by 4. 1, 2, 5, 6, 3, 4, 7, 8. And that's just changing which axes we're going to go ahead and concatenate on. What I find is when you're talking about the concatenate or the joining arrays, you really got to play with these for a while to make sure you understand what you mean by the axes. It looks very intuitive when you're looking at it. Axis 0, 1, 2, 3, 4, 5, 6, 7, 8. Axis 1 is then splitting it a different way, 1, 2, 5, 6, 3, 4, 7, 8. When you're actually using real data, you start to really get a feel for what this means and what this does. So if we're going to do that, let's go ahead and look at splitting the array. And do that under Markdown and run it. There we go. So you have a nice little title there. And we'll go ahead and create an array of 9. Let's do NP split. We'll do A, and we're going to split it by 3. Let's just see what that looks like. So if we split it, we get an array 0, 1, 2, 3, 4, 5. We get 3 separate arrays on here. Now remember, we're looking at, let me just print A up here. So we're looking at 0, 1, 2, 3, 4, 5, 6, 7, 8, and then we can split it into 3 separate arrays. And let's take this, we're going to do this right down here, just move the A split down here. Instead of the 3, let's do 4, 5, and put that in brackets. And so when we do it this way, we have 0, 1, 2, 3, 4, 5, 6, 7, 8. And that's kind of interesting. I wasn't sure what to expect on that, but we get, when you split an A by 4, 5, you get a totally different setup on here as far as the way it split the array. And to understand how this works, I'm going to change the 5 to a 7. And this will visually make this a little bit more clear. So we had 4 and 5, it went 0, 1, 2, 3, 4, 5, 6, 7, 8. And you see the markers 4 and 5. When we do 4 and 7, I get 0, 1, 2, 3, 4, 5, 6, 7, 8. And so what you're looking at here is the first markers, this is going to go to 4. So there's our first split at the 4, the marker at 4, and then the second split is going to be at position 7. And this is the same thing here. 4, position 5. That's why we're splitting it in those 2 sections. We could also do it 7. Let's just see what that looks like. Run. And you can see I now have 0, 1, 2, 3, 4, 5, 6, 7, 8. So we can split it in all kinds of different ways and create a different set of multiple arrays on here and split it all kinds of different ways. And before we get into the graphs and other miscellaneous stuff, let's go ahead and look at resizing the array. We'll go ahead and take this cell and set the cell as a markdown and run it. Give us a nice title there. And we'll do an array, an NP array of 1, 2, 3, and 4, 5, 6 here. And let's go ahead and just print. Let's go print a dot shape. And we'll go ahead and run that. Whoops, hit a wrong button there. Hit the comma instead of the dot. So we have a shape of 2, 3 here. And this is important to note because when we start resizing it, it's going to mess with different aspects of the shape. And so we'll go ahead and do a print. Scoop in for a blank line. There we go. Now let's do b equals np.resize. We're going to resize A, and let's resize it with 3 by 2. And then we'll just go ahead and print B and print B period shape, not a comma. We'll run that. Oops, forgot the quotation marks around the end. We'll go ahead and run that, and let's just see what that looks like. So we have 1, 2, 3, 4, 5, 6, our original array, with a shape of 2, 3. And then we want to go ahead and resize it by 3, 2. And we end up with 1, 2, 3, 4, 5, 6, and we end up with a shape of 3, 2. That shouldn't be too much of a surprise. You know, we got 6 elements in there. We can resize it by 2, 3 was the original one, and then we're actually just reshaping it is how that kind of comes out as when you resize it like that. But what happens if we do something a little different? And let's go ahead and just take this whole thing and copy it down here so we can see what that looks like. And instead of doing 3, 2, remember last time I did the, to reshape it, I messed with the numbers and it gave me an error. Well, when you resize it, you don't have to match the numbers. They don't have to be the same dimensions. So we can, instead of going from a 2, 3 to a 3, 2, we can resize it to a 3, 3. So let's take a look and see how it handles that. And when we come down here to 3, 3, we end up with 1, 2, 3, 4, 5, 6, and it repeats 1, 2, 3. So it actually takes the data and just adds a whole other block in there based on the original data and repeating it. All right, now at this point, we've been looking at tons of numbers and moving stuff around. What we want to go ahead and do is get a little visual here, because that certainly you can picture all the different numbers on there, but let's look at histogram. Let's put this into a histogram. Let me go ahead and run that. And to do that, we're going to use the matplot library. So from matplot library, we're going to import pyplot as PLT. And that's usually the notation you see for pyplot. So if you ever see PLT in a code, it's probably pyplot in the matplot library. And then the guys in the back did a nice job, and gals too, guys and gals back there. Our team over at Simplilearn put together a nice array for me, 20, 87, 4, 40, 53, with a bunch of numbers. That way we had something to play with. And what we want to do is we want to do plot the histogram. Now remember, a histogram says how many times different numbers come in. And then we're going to put them in bins. And we have bins 0 to 20 to 40 to 60 to 80 to 100. You might, in here with the matplot library, they call them bins. You might hear the term buckets, or they put them in buckets. That's a really common term. And then we want to give it a title. So the way it works is you do your plt.hist for histogram, your plt title, and your plt show. And we're doing just a single array in here in the Numpy array of A. And let's go ahead and run this piece of code. Take it a moment to come out there. It says figure size, so it's generating the graph. And you can see we have, and let's just take a look at this. Let me go down a size. There we go. Okay, so now we can see we're taking a look at here. So between 0 and 20, we have 3 values. So we have a 20 here, we have a 4, and a 11, and a 15. 0, 1, 2, 3. It's actually 4 values, but they start at 0. So remember, we always count from 0 up. And from 20 to 40, we got 20. So it's 1, 42, 3, 4, 5, 6. And so you can see in the histogram, it shows that the most common numbers coming up is going to be between the 40 and 60 range. Least common between the 80 and 100. This looks like an age demographics, is what this looks like to me. And you can see where they would have put it in the buckets of different age groups, which would be a nice way of looking at this. Histograms are so important and so powerful when you're doing demos and explaining your data. So being able to quickly put a histogram up that shows what's common and how it's trending is really important. And using that with a Numpy is really easy. And you know what, let's take the same data, and I want to show you why we do bins, or why we have buckets of data. I'm used to calling it buckets. Why we have bins. Let's do it instead of by 20, let's do it by tens and see what happens. And what happens when you do it by tens is you miss out on you can see a nice curve here on the first one, and on the second one it looks like a ladder going up and a plummet, a ladder going up and a plummet, and a ladder going down. So the first would be more indicative of an age group, and the second one would be what you would get if you divided incorrectly. You wouldn't see the natural trend of, I don't know what this would be, maybe how much food they eat. Hopefully not, because I'm in 50, so I'm right in the middle there, which means I eat a ton of food compared to everybody else. But it's some kind of demographic. Maybe it's mental, maybe it's knowledge, because we hit a certain point and then we start losing, our marbles start leaking out or something. So you start off knowing something, and then as you get older you grow more. But you can see here we lose that. You lose that continuity in the thing if you split the histogram into too many bins or too many buckets. And if you actually plotted this by the individual numbers, it would just be a bunch of dots on the graph and wouldn't mean a whole lot. And we've looked at graphs. There turns out are a ton of useful functions in Numpy. I'm sure there's even new ones that aren't going to be in here. But let's just cover some important ones you really need to know about if you're using the Numpy framework. One of them is line space function. This is generating data. So you have a line space, we have 1, 3, 10, and when we do that, we end up with 10 numbers. So if you count them, there's 10 numbers. They're between 1 and 3, and they're evenly spaced. We get 1, 1.222. But these are all, there's a total of 10 here, and it's right between the 1 and 3 range. That can be, there's a lot of uses for that, but they're probably more obscure than a lot of the other common Numpy arrays set up. Then a real common one is to do summation. So we'll do summation where you do, in this case we create a Numpy array of two different arrays, 1, 2, 3, or two different dimensions, 1, 2, 3, 3, 4, 5. And we're going to sum them up under axes 0, which is your columns. And if you remember correctly, columns is the 1 plus 3, 2 plus 4, 3 plus 5, so we have 3 columns. And if we change this, we'll just flip this to 1. We get 2 numbers. So we get 1, 2, 3 all added together, which equals 6, and 3 plus 4 plus 5, which equals 12. We'll set this back to 0. There we go, since we're looking at axis 0. And these probably could have been, some of these could be with our math section. Square root and standard deviation, 2 very important tools we use throughout the machine learning process and data science. And simply we take the NP array, we have again the 1, 2, 3, 4, 5, 6, 3, 4, 5. I don't know why I need to keep recreating it, I probably could have just kept it. But we can take the square root of A. So it goes through and it takes the square root of all the different terms in A. And we can also take the standard deviation, how much they deviate in value on there. And there's a rabble function. We can run that. And in array is x, we're going to do x equals, hey, we changed it from A to x. X equals rabble. And this sets it up as columns. So we have 1, 2, 3, 4, 5. This is all columns on here. Very similar to the flatten function. So they kind of look almost identical. But we also have the option of doing a rabble by column. And then another one is log. So you can do mathematical log on your array. In this case, we have 1, 2, 3. And we'll find the log base 10 for each of those 3 numbers. And there's a couple of them. You can't just do any number here after log, but there is also log base 2. Log base 10 is pretty commonly used on here. We'll go and run that. There we go. Before we go, let's have a little fun. Let's do a little practice session here on some more challenging questions. So you start to think how this stuff fits together. Right now we just looked at all the basics and all the basic tools you have. So let's do some Numpy practice examples. And let's start by figuring out how do you plot, say, a sine wave in Numpy. What would that look like? And so in this project we wouldn't have to do this because I've already run these. But we'd want to go ahead and import our Numpy as NP, and import our matplot library pyplot as PLT. So we get our tools going here. And then we'll break it into two sections because we need our XY coordinates in here. So first off, let's create our X coordinates. And our X coordinates we're going to set to an A range. And we want this A range, since we're doing sine and cosine, it's going to be between 0 and 0.1. And then we use our NP, and we actually can look up Numpy stores pi. So you have the option of just pulling pi in there directly from Numpy. It has a few other variables that it stores in there that you can pull from there. But we have Numpy pi, and we generate a nice range here. And let's go ahead and run this. And just out of curiosity, let's see what X looks like. I always like to do that. So we have 0.1, 0.2, 0.3, 0.4. So we're going 0 to, in this case, 9.4, 3 times Numpy pi. Remember, pi is like 3 point something, something, something. So that makes sense. It should be about 9. And we're doing intervals of 0.1. So we create a nice range of data. And then we need to create our y variable. And so y is going to simply equal NP, or numpy.sine of x. And then once we have our x and y, and if we print, let's go ahead and just print y. See how that, we'll do this. Let's do this so it looks print x, print y. So we basically have two arrays of data. So we have like our x-axis and our y-axis going on there. And this is simply a plt.plot, because we're going to plot the points. And we'll do x comma y. And then we want to actually see the graph, so we'll do plot.show. And we'll go ahead and run that. And you see we get a nice sine wave. And here's our numbers 0 through 9. And here's our sine value, which oscillates between -1 and 1 like we'd expect it to. Then for the next challenge, let's create a 6x6 two-dimensional array and let 1 and 0 be placed alternatively across the diagonals. Oh, that's a little confusing. So let's think about that. We're going to create a 6x6 two-dimensional, so the shape is 6x6 two-dimensional array, and let 1 and 0 be placed alternatively across the diagonals. Now, if you remember from lesson 1, we can fill a whole Numpy array with zeros or ones or whatever. So we're going to do NP, create a Numpy zeros, and we're going to do a 6x6, and we'll go ahead and make sure it knows it's an integer, even though it's usually the default. And just real quick, let's take a look and see what that looks like. So if I run this, you can see I get 6x6 grid, so 6x6, 0, 0, 0, 0, 0. Now, if I understand this correctly, when they say 1s and 0 placed alternatively across the diagonals, they want the center diagonal, maybe that's going to stay 0 all the way down. And then the next diagonal will be 1s all the way across diagonally. And then the next one 0s, the next one 1s, the next one 0s, and so on. Hopefully you can see my mouse lit up there and highlighting it. So let's take a little piece of code here. And we'll do z1::2, ::2 equals 1. And wow, that's a mouthful right there. So let's go ahead and run this and see what that's doing. And so what we're doing is we're saying, hey, let's look at, in this case, row 1. There's 1. And then we're going to go every other row 2. So we're going to skip a row. So skip here, skip here, skip here. So we're going down this way. And we're going every other row going this way. It's hard to highlight columns. So you can see right here where we're not touching each row, like this row right here is not being touched. Okay, so we're going to start with row 1, and then we're going to skip a row and another one, and so we're going every 2 rows. And then in every 2 rows, we're looking at every 2, starting with the beginning. That's what this thing blank means. So we're going to start with the beginning, and we're going to look at all of them, but we're going to skip every 2. So starting with row 1, we look at all the rows, but we do it by 2 steps. So we go 1, skip 1, 1, skip 1, 1, skip 1, 1. If you left this out, it'd do every 1. This would just be 1s. In fact, let's see what this looks like. If I go like this and run it, you can see that I just get 1s. So this notation allows us to go down each row, row by row, and we're going to do every other row set up on there. And so if we're going to start with row 1, we also, Control Z, try that. There we go. We'll start with row 0. Again, we're going to go each row, step 2. So we'll start with row 0, and we'll go every other row. And this time we'll start with 1, column 1. And again, we go every other one going down. That's what that step 2 is. That's skipping every other one. We're going to set that equal to 1. So let's see what that looks like. And you can see here we get our answer. We get 0, 1, 0, 0. But it has the 1s going in diagonals on every other diagonal and 0 on every other one. A little bit of a brain teaser, that one, trying to get that one to work out. So you can see how you can arrange your rows, and here's your step and your different access on there. And then the next one is find the total number and locations of missing values in the array. The first challenge is to create some missing numbers. So let's create our array Z. We're going to do numpy.random.rand 10, 10. And before we do the second part, let me just take this second part out. And let's just see what that looks like. So let's run that. And there we go. So we have a 10 by 10 random array. It randomly is picking out numbers. And next, we want to go ahead and take our random integer size equals 5. And then we're going to do a random 10 size equals 5. So in the Z, we're going to select a number of random spaces here and set them equal to null value. And let's go ahead and run that so you can see what that looks like. And if we look at the array, we've created 1, 2, 3, 4. There should be a fifth one in here. My eyes may be failing me. So we've created a series of, because 0 to 5, 0, 1, 2, 3, 4. So we got 5, there are different null values on here. And this is kind of a neat notation to notice that we can generate random integers, size equals 5. So this generates 5 by 5 miniature grid inside of this to tell it where to put the nands at. So that's kind of a cool little thing you can do. And then we want to look up and see how many null values are in there. And this is simply just NP is nan of Z. Simple. So if it is nan, then we want to sum it up. So we're going to sum up all of the different null values on there. And let's do one more feature in here, which is really cool. Let's go ahead and print the indexes. So NP argware NP is nan of Z. So we're going to create our own another NP array. And let's run this, and we'll see here that it comes up with the 4 indexes. So we did count 4 of them up there. It tells you where they are, 1, 9, 2, 0, 4, 6, 5, 4. And then let's go ahead and run this again. Run, there we go. This time I got 5. That's what we get for random numbers. Another fun one that I always like to do, it's very similar because we have np is nanz.sum. So we're summing the number of nands. And we can get the indexes and you can reshape the indexes. But you can also just do, we'll do an INDS where np is nan of Z. And let's just print that. Print INDS. Let's see what that looks like. And it's very similar. We have 0, 1, 3, 0, 6, 3, 8, 6, 9, 3. But I've split it into 2 different arrays. So we have our X and our Y kind of coordinates going there. And what I can now do is I can now do Z INDS equals. And at this point, you can also, instead of getting the sum, you can get the means or all the numbers and that kind of thing, or the average as it is. So that'd be one thing you could do, and you can pick out the average. That's very common in data science to get the average and just use that for a value. But we'll go ahead and just set it to 0, and then let's go ahead and print our Z and run that. And you can see when we come down here, we have wherever there was a null value, it is now 0. And you can set this to whatever you want. This is another way to replace data or help clean data up, depending on what it is you're doing. So, wow, we covered a lot of stuff. So quick rehash going over everything. We went into there, we looked at array manipulation, changing the shape, how to switch that around. We even had the flatten down there, which remember we have another command lower that's similar. We could change the order by F. Remember F stands for Fortran, very strange connotation, but there's C and F. C is the standard, and F switches it to a different order. To be honest, I usually have to look it up because I almost never use F. But when you need it, you're like, oh my gosh, what was the other order? Just do a quick Google. So we talked about reshape, making sure that the dimensions are the same. You don't want to have like something that has 12 objects in it and reshape it to 11 and 5 because it doesn't work. It doesn't divide into 12. We can transpose, so we can switch them. So we can go from a 4x3 to a 3x4. Oops, I did that the other way around. 3x4 to 4x3. We covered reshaping the array. We did the roll the axes. You can do some weird things with swapping and rolling axes and transposing the numbers. We dug a little bit into the arithmetic. So we talked about adding, we talked about subtracting, multiplying, dividing. And at this point it's so important we just look up the Numpy mathematics. And you can see here they have just about everything. Your trigonometry, your hyperbolic functions, rounding, sums, products, differences. There is so many, all your different miscellaneous mathematical connotations. So, Google it, go to the main Numpy page and look at the different setups you can do on there. So we covered that, and we did slicing, how to break it apart. We did iterating over the array. We covered joining arrays and how to concatenate. Remember, concatenate just means add on to it. So in this case, how are you adding B onto A is how you'd read that. From Linux, you should catch the concatenate because that's used regularly there. Splitting the array, we talked about how to split the array in different ways. So you can split it in array of arrays, all kinds of different ways to split the array up. How to resize it. And remember, resize does not have to have the same shape, but if you resize it, it will take the data and begin at the beginning and add new rows on if the size is bigger. If it's smaller, it truncates it. It just cuts the end off. We looked at how to do a histogram and how to plot that. We mentioned buckets or bins, as they call them in PyPlot. And then we covered a lot of other useful functions in Numpy. We talked about the line space setup for doing numbers in a series. How to sum the axes up. Again, that's part of the mathematical formulas there that we looked at. There's a sum, there's also means and median. All of those you can compute in Numpy. And you can also do the square root and standard deviation. The ravel function, very similar to the flatten. To be honest, I almost always just use the flatten, but the ravel has its own kind of functionality that it does. And then we went into some Numpy practice examples. We challenged you to create a sine wave in Numpy and how to do that. We're kind of looking for that A range. Remember how we do the A range, and you can have your beginning value, your end value, which they did as 3 times pi, Numpy pi, and we're going to do intervals of 0.1, and then y just equals the Numpy sine of x. There's our math from the math page we were just looking at. Remember that? It's right at the top. And finally, we went down here. We had this kind of a little brain teaser, how to do diagonal zeros and ones, playing with the different connotations of the Numpy array. And then we did a random size, and we played a little bit with with the null values, playing with null values. If you're doing any data science, null values are like a headache. What do you do with them? Big sets of data, you get rid of them. Small sets of data, you have to factor something in there, like figure out the average or the median there, and then replace it with that. Pandas really is a core Python module you need for doing data science and data processing. There's so many other modules that come off of it. There actually sits kind of on Numpy, so if you've already had our Numpy array, hopefully you've already gone through the Numpy tutorial 1 and 2. So today we're going to cover what is Pandas. We'll discuss series. We'll discuss basic operations on series. And then we'll get into a data frame itself, basic operations on the data frame, file-related operations on a data frame, visualization, and then some practice examples. Roll up our sleeves and get some coding underneath there. And let's start with just some real general, what is Pandas? Pandas is a tool for data processing which helps in data analysis. It provides functions and methods to efficiently manipulate large data sets. Now, this is a step down from, say, using Spark or Hadoop in big data. So we're not talking about big data here, but we are talking about pandas, and there is some connections. There's like an interface going on with that, so there is availability, but you really should know your pandas, because if you're working in big data, you'll know there's data frames. Well, pandas is a data frame primarily. It has a couple different pieces we'll look at here. And if you've never worked with data frames before, a data frame is basically like an Excel spreadsheet. You have rows and columns. You can access your data either by the row or the column, and you have an index and that kind of setup. And we'll dig more into that as we get deeper into pandas. But think of it as like a giant Excel spreadsheet that's optimized to run on larger data on your computer. And then I said that it's a data frame. So the data structures in pandas are series, one-dimensional arrays, and then we have data frame, two-dimensional array. And it really centers around the data frame. The series just happens to be part of that data frame. And here's a closer look at a pandas series. Series is a one-dimensional array with labels. It can contain any data type, including integers, strings, floats, Python objects, and more. So it's very diverse. If you remember from Numpy we studied, they had to be all uniform. Not in pandas. In pandas we can do a lot more. And pandas actually kind of sits on Numpy, so you really need to know both of those if you haven't done the Numpy tutorials. And you can see here we have our index 1, 2, 3, 4, 5, and then our data A, B, C, D, and E. Very straightforward. It's just two columns, and we have a nice index label and a column label for the data. And then a data frame is a two-dimensional data structure with labels. We can use labels to locate data. And you can see here we had, if we go back one, we had our index 1, 2, 3, 4, 5. So in each one of these series, they would share the same index over there, the row index. So you have your row index df.index, and then you have a column index df.columns. And this would look, like I said, this would be really familiar if you've done any work with spreadsheets, Excel. So it kind of resembles that. This does make it a lot easier to manipulate data and add columns, delete columns, move them around. Same thing with the rows. So you have a lot of control over all of this. Now, we're of course going to do this in our Jupyter Notebook. You can use any of your Python editors, but I highly suggest if you haven't installed Jupyter and haven't worked with it, it is probably one of the best ways for easily displaying a project you're working on. I skip between a lot of different user interfaces or IDEs for editing my Python, and it's just simply jupyter.org, jupyter.org, and then I always let mine sit on Anaconda, anaconda.com. And just real quick, we'll open that up for you. Oops, offline mode. Don't show me that again. But you can see here that I have different tools that I can actually install in my Anaconda, including the Jupyter Notebook, which comes by default. And then I have access to the environments. And again, that's anaconda.com, named after the very large, one of the world's largest snakes, and then Jupyter Notebook. In this case, jupyter.org. And when we're in our I'm going to go in here to our Jupyter Notebook, and we're going to go ahead and just do new and a Python 3. And this will open up a Python 3 untitled folder. So diving right in, let's go ahead and give this a title, Pandas Tutorial. And we'll go up to Cell, and we'll change the cell type to Markdown so it doesn't execute it as actual code. One of those wonderful tools when you have Jupyter Notebook so you can do demos with this. And let's go ahead and import Pandas. And usually people just call it PD. That has become such a standard in the industry. So we'll go ahead and run that. Now we have our Pandas has been imported into our Jupyter Notebook. And then, we can go ahead and let me do the Control Plus. Since it's Internet Explorer, I can enlarge it very easily so you have a nice pretty view. Whoops, too big. There we go. And whenever you're working with a new module, it's good to check your version of the module. In Pandas, you just use the, in this case, pd.__version__. That's actually pretty common in most of our Python modules. There's different ways to look up the version, but that's one of the more common ones. And we'll go ahead and run that. We get 0.23.4, and if we go to the Pandas site, we see 0.23.4 is the latest release. And of course, a reminder that if you're going to your environment, you need to install it. So you'll need to do pip install pandas if you're using the pip installer. We'll go and close out of that. And the first thing we want to do is we're going to work with series. A lot of the stuff you do in series you can then do on the whole data set. We need to do what? Create one. We need to manipulate it. Take pieces of it, so query it. Delete, so you can delete different parts of it. So we want to do all those things with the series. And we'll start with the series, and then almost all the code, in fact all the code does transfer right into the actual data table. So we go from a series of a single list of one column, and then we'll take that and we'll transfer that over to the whole table. And we'll start by creating, there we go, creating a series from list. And let's just call this ARR equals, and we'll do 0, 1, 2, 3, 4. If you remember from our last one, we could easily do R equals range of 5, which would be 0 to 4. But we'll do R equals 0 to 4, and we'll call this S1, and we'll go PD, and series is capitalized. This one always throws me, is which letters do you capitalize on these modules? They're getting more and more uniform, but you got to watch that with Python. And we're just going to go ahead and do ARR. So we're just going to take this Python list and we're going to turn it into a series. And then because we're in Jupyter, we don't have to put the print statement. We can just put S1 and it'll print out this series for us. And let's go ahead and run that and take a look. And you'll see we have 2 rows of numbers. So the first one is the index. Now it automatically creates the index starting with 0 unless you tell it to do differently. So we get 0, index row 0 is 0, 1, 1, 2, 2, 3, 3, 4, 4. And because it's a series, it doesn't need a title for the column. There's only one column, so why title it? And this also lets you know that it's a data type of integer 64. So we print this out. This is our series, our basic series we've just created. And let's do a second series, PD, and we'll use the same data list. And let's go ahead and do order. We'll give it an order equals, let's do it this way. Let's go index equals order. And it helps if we actually give it an order. So we'll do order equals, and let's do 1, 2, 3, 4, 5. So instead of starting with 0, we're going to give it an order starting with 1. We're going to run that, and we'll go ahead and print it out down here, S2. And we'll see that we now have an index of 1, 2, 3, 4, 5, and that represents 0, 1, 2, 3, 4 in the series. And we're still data type integer 64. And very common as you're messing with Numpy arrays is we can import our Numpy as NP. Remember that from our Numpy tutorials. We can go ahead and create a Numpy out of random with the random numbers of 5. And let's just see what that n looks like so we can see what our Numpy looks like. So we have some nice random float values here, 2.33, so on. And that's from our last tutorial, the Numpy tutorial 1 and 2. And instead of calling it order, let's call it index. And we're going to set our index equal to A, B, C, D, and E. I want to show you that the index doesn't have to be an integer, so it can be something very different here. And then let's go ahead and create we'll just use S2 again. And here's our NP for Numpy, series, capital S, and N is our NP for Numpy. PD for Pandas, there we go, switching my anachronisms. So we have PD.series of N, and we want to do our index equals our index we just created. And then let's go ahead and see what that looks like. S2 is to print it, and let's run that. And we can see here we have a nice series going on. A, B, C, D, and E for our indexes. So instead of it being 0, 1, 2, 3, or 4, we can make this index whatever we want. And you can see the numbers here going down that we randomly generated from the Numpy array. So we used Numpy to create our Pandas series right here. And so continuing on with creating our series, this one I use so often, we create a series from a dictionary. So we have our dictionary. In this case, we went ahead and did A of 1, B is 2, C of 3, D 4, E of 5. So each one of those is a key and then a value. And then we're going to use, let's use S3 equals PD for Pandas, series, and then we want to go ahead and just do D in here. Print out S3 here, and let's go ahead and run this. And you can see we got A is 1, B is 2, C is 3, D is 4, E is 5. And it's still of integer 64 because the actual data is 1, 2, 3, 4, 5, and it's all integer 64, type 64. And the last thing we want to do in the creating section of our series is to go ahead and modify the index, because we're going to start modifying all this data. So let's start with modifying the index of the series. And if you remember, let's do a print this time, S1. I'll go ahead and run this. And the reason I did print is because it only prints out the last variable. So if I put S1 up here and we're going to do another variable back down lower, it won't print the first one, just the last one. And we're going to go ahead and take S1 the index, and we're just going to set it equal to a new index. And obviously, the number of objects in our index has to equal the number of objects in our data. And then because it's the last variable, we can go ahead and just do an S1. And let's run that, and you can see how we went from 0 to 0, 0, 1, 2, 3, 4 as our index. We've now altered it to A, B, C, D, and E. So this would be much more readable, or might be representational of a larger database you're working with. So cool tools. We've covered creating a database based on a basic array, Python array. We've showed you how to reset the index. Then we showed you how to use a Numpy array. So you can put a Numpy array in there. It's all the same, pd.series, a Numpy array, and then we can set the index on there. And the same thing with the dictionary. So it's very versatile how it pulls in data. And you can pull in data from different sources and different setups and create a new series very easily in the Pandas. And then we looked on changing your index. So now we have a new index on here. And then we want to go ahead and do some selection. Let's do some basic slicing. Most common thing you'll probably do on here. And we'll just do S1. This notation should start to look really familiar. Again, this is going to put an output. So it doesn't change S1. This just selects it. So we might do A equals S1 and then print A. And you'll see that it just looks at the first three, 0, 1, 2. And we can do the same thing by not having the A in there. I'll go ahead and take that out. But it's just a reminder that it's not actually changing S1. It's just viewing S1. So simple slicing on here. And we can likewise do an append. Oops, before we do append, let's just do a quick kind of fun one. We'll do to -1. And you'll see it covers everything but the E. Of course, you can do -2 on this side. So another way to select it is to go how far from the end. And likewise, we can do a 2 here, CDE to the end. So it starts at the second one. And another way we can do this is we can do a -2 over here. And that looks at just the last 2 in the slice. So you can see how easy it is to slice the data. And of course, there's no reason to do this, but you could select all of them if you wanted to view all of them on there. Oops, 32. There's not 32, so it's just going to show the first 3. There we go. And then we can also append. So I can take and, let's create another series and append one to it. And if you remember, we had S3. There's our S3. And we have our S1. We'll go ahead and do S1. And let's go ahead and do, let's call it S4 equals S1 append S3. So we're just going to combine those two into S4. And if we go ahead and print S4 on here, you'll now see that we have A, B, C, D, E, A, B, C, D, E, 0, 1, 2, 3, 1, 2, 3, 4, 5, because we started the data at 1. So very easy to append one series to the next. And if we're going to append one series to the next, we need to go ahead and drop or delete one. And drop is the key word for that. And let's just do E, or index E. And so if I run this, you'll see that it'll print it out, and A, B, C, D, there's no E. And remember, all these changes, if I type in S4 again, you'll see that S4 still has E in it. So this change does not affect the series unless you tell it to. So I'd have to do like S4 equals S4.drop E. And there's another way to do that, which we'll show you later on. Let me just cut this one out. There we go. All right, so we've covered all kinds of cool tools here. We have appending, we have slicing, we did all the creating stuff earlier. So you can see here on the setup how easy it is to manipulate the series. So next, what we want to get into is we want to get into operations that happen on the series. Let me go ahead and change this cell to Markdown. There we go, and run that. So series operations, what can we do with the series? And let's start by creating a couple arrays. We'll call it array 1, and we'll do 0 through 7, and array 2, 6 through 6, 7, 8, 9, 5. I don't know why we threw the 5 on the end. Let's go ahead and run those so those load up into Jupyter. And we'll do this a little backwards. We're going to do S5 equals a Pandas series of array 2. So I'm doing this in reverse. And then when we do S5, you'll see that we have 0 to 4. It automatically assigned the index. 6, 7, 8, 9, 5 for our series. And let's go ahead and do the same. And we'll call this S6. And we'll set this equal to PD series for our first array. And if we do an S6 down here to print it out, we'll see something similar. I got 0 through 6, 0, 1, 2, 3, 4, 5, 7 for the data. So those are two series we just created, series 6, 5, and 6. And one of the first things we can do is we can add one series to the next. So I can do s5.add s6. And let's see what that generates. And just a quick thing, if you've never used Pandas, what do you think is going to happen with the fact that this only has 5 different values in it, and this one has 7 values? So let's see what that does. And we end up with 6, 8, 10, 12, 9, and it goes, oh, I can't add this, there's nothing there. So it gives us a null return. Very different than the Numpy that would have given you an error. This instead tells you there's no value here because we couldn't generate one. So we can easily add s5.add s6, and likewise we can do s5.sub for subtract s6, and we'll run that. And on the add, the subtract, and you guessed it, we're going to do multiply and divide next. Again, you can see there's null values where it can't subtract the two because there's no values there to subtract. We can also do s5 multiply, MUL. They're all 3 letters on these. That's one of the ways to remember how they figured out the code for this. So remember, these are all 3 letters, mul. We'll go ahead and run this, and you can see how they're multiplied together. And then we can also do the s5 div, 3 letters again, s6, and run that. And you'll see here, this goes to infinity because we have 0 in the wrong position. So it actually gives you a whole different answer here. That's important to notice. And then in the null values, because there's no data and it can't actually produce an answer off of missing data. And since we're in data science, let's do S6 median. So let's look up the median data, which is simply median. Sorry for those who are following the 3 letters, because median is not 3 letters. And you can see in S6 is 3.0. And let's do a print here. And we'll do median or average. S6. And let's print max, comma S6. And just like median, there's max value. And if we're going to have a max value, we should also have a minimum value. So let's pop in minimum. We'll go ahead and run this. And you're starting to see something that would be generated like, say, in R, where you're starting to get your different statistics. We have a median value of 3, max value of 7, and a minimum value of 0. And what it does when it hits these null values, if there is null values in there, because we could still do that, we could actually, you know what, let's go up here and do, let's pick this one where we multiplied. Let's go S7 equals, I'll go ahead and print the S7 just so I keep it nice and uniform, so I still have my S7 down there, and run it. And then I want to take the S7, because S7 now has null values and an infinity value, and let's see what happens. This is going to be interesting because I want to see what it does with infinity. And we end up with a median of 6, maximum of 27, and minimum of 0, which is correct. It drops those values. So when it gets to there and it doesn't know what to do with them, it just drops those values and then it computes it on the remaining data on there. So that's important to know when you're making these computations, you're looking at min and max and median, you're not going to know that there's null values unless you double check your data for the null values. That's a very important thing to note on there. So just a real quick review on there. We've created our PD series, and we've gone ahead and done addition, subtraction, multiplication, division. All of those are 3 letters, so sub, min, div, add. And then we looked at median, maximum, and minimum. So we're going to go ahead and jump into the next big topic, which is to create a data frame. So now we're going to go from series, and we're going to create a number of series and bundle them together to make a data frame. There we go, cell type, markdown. And we go ahead and run that. So we have a nice title on there. It's always good to have a good title. All right, so our first data frame, we'll jump in with some stuff that looks a little complicated, but we'll break it down. First, I'm going to create some dates. And you know what? Let's just go ahead and do this. I want you to see what that looks like, what I'm creating here. I've created a series of dates, PD date range, and we're going to use these for the index. Okay, so when you look at this, you'll see that it's just, basically it comes out kind of like a basic Python list or a Numpy array, however you want to look at it, with our different dates going down. And we've generated 6 of them. And it's going to have whatever time it is right now on the thing for the date for the time. That's that time stamp right there. And then you'll see we have 11/19, 2008, 11/20, 11/19, and looking into the future there. So that's all this is generating a series of dates that we're going to use as our index. And this is a Pandas command, so we have a date range, which is nice. That's one of the tools hidden in there in the Pandas that you can use. And next we're going to use Numpy to go ahead and generate some random numbers. In this case, we'll do the np.random.random in 6, 4. You can look at this as rows and columns as we move it into the Pandas. And of course, you could reshape this if you had those backwards on your data. But we want the 6 to match the rows, and we have 6 periods, so our indexes should match along with the rows on there. And then, you know, before we do the next one, let's go ahead and just print out our Numpy array so you can see what that looks like. Here we have it, 1, 2, 3, 4 by 1, 2, 3, 4, 5, 6. 4 by 6. So it's a nice little setup on there. And since working with data frames can be very visual, let's give our columns, we have 4 columns, and we're going to give them names, A, B, C, and D. So now we have columns on there also. And then let's put this all together in a data frame, and we can actually, you know what, let's do this. Since I did it with everything else, let's go ahead and do columns, and you can see there's our columns on there. And we'll go ahead and do df1 equals pandas dot data frame. And note that the D and the F are capitalized. Series, it was just the S, and I always highlight this because you don't know how many times these things get retyped when you forget what's capitalized on there. It's a minor thing. You'll pick it up right away if you do a lot of it. And the first thing we want to do is we want to go ahead and take our Numpy array, because that's what we're going to create our data frame off of, is the Numpy array. And then we want our index equal to our dates. So there's our index in there. And then we also have columns equals columns. And then finally, let's see what that looks like. Now remember, we had all that different data that just looked like a jumble of data. We have our column names and everything else. Our Numpy array, kind of just a jumble array over there, 4 by 6. You can sort of read it. But look how nice this looks. I mean, this is, you come into a board meeting, you're working with your shareholders. This is pretty readable. This is, you know, this is our date. This is our A, B, C, D, whatever it is. Maybe each one of these dates has your leads, closures, lost leads, total dollar made, you know, whatever it is, if it's in a business. Maybe it's measurements on some scientific equipment, weather searching material, you know, where this is like high of the temperature, low of the day, humidity of the day, whatever it is. So you can see that we can really create a nice clear chart, and it looks just like a spreadsheet. You know, we have our rows, and we have our columns, and we have our data in there. Now this one I use all the time. If we're going to create, we can create it like you saw here with our Numpy array. Very easy to do that and reshape it. You can also create it with a dictionary array. So here we have some data, and let me just go down a notch so you can see all the data on there. We have an animal, in this case cat, cat, snake, dog, dog, cat, snake, cat, dog. We have the age, so we have an array of ages. We have the number of visits and the priority. Was it a high priority? Yes, no. And then we're going to take that, we're going to create some labels. We have A, B, C, D, E, F, G, H, I. And what I want you to notice on this is we have a title, animal, and then we have basically a Python list. And these lists, they don't necessarily have to be equal because we can have non-data, you know, np.nan, numpy array, null value. But we want to go ahead and create labels that are equal to the number in the list. So A, the first cat, B, the second cat, C, the snake, D, the dog, and so on. So we'll go ahead and create our labels, which we're going to use as an index. And we'll call this df, let's do it this way. We'll call this df2 equals PD for pandas data frame, and then we have our data just like we did before, and then we have our index equals labels. And if we're going to go from there, let's go ahead and print it out so we can see what that looks like. df2. So let's go ahead and run that. And again, you have a nice, very clean chart to look at. We've gone from this mess of data here to what looks like a very organized spreadsheet, very visual and easy to read. Animal, age, visits, priority, and then A through J, cats, and all your different animals, so on and so on. And then when you do programming, a lot of times it's important to know what the data types are. So we can simply do df2 dtypes. And if we run that, we can see that our animal is an object, because it's just a string, but it comes in as an object. Age is a float 64, integer 64, and then priority again is just an object. And exploring this one's very popular. Let's go df2 head, and if we print that out, the df2 head returns the first 5. And we can change this. You don't have to do 5. You might want to just look at the top 2. Maybe you want to look at, let's see, let's do 6. So maybe we want to look at just the top 6 in the database, in your data frame. And you can actually, this creates another data frame. So I could have a df3 equal to df2, and this now takes the df2 and just the first 6 values. So if we do df3, run, get the same answer. And if we do the head of the data, we can also do the tail. It's the same thing. df tail, you can look at the last, we'll just do the tail, which by default does 5, the last 5. And of course you can just look at the last 3 of those real quick just to see what's at the end of the data. And this is the tail. I love doing the tail of 1 because I'll have like the index or something like that, and it will just show me the last, whatever the last entry was. Looking at stock values, and I might want to look at just the last 5 days of the stock values. I can do that with the data frame tail. And some other key things to look up are the index. So we can do df2.index. And I want you to notice that this isn't a call function. So if I put the brackets on the end, it'll give me an error because index is not callable. It's just an object in there. So we do df2.index. There's also columns. So we can go ahead and let's print this. Remember, the first one's not going to show unless I print it, and then df2 columns. So now we can see that we have our indexes and we have our columns listed here, df2.columns, animal, age, visits, priority. It tells you what kind of object it is, or what kind of data type it is, and they're both object. And then finally df2.values. And again, there's no brackets on the end of df2.values because this is an actual object, it's not a callable function. So we'll go ahead and run that, and it just displays a nice array. A very easy way to convert this back to a Numpy array, basically. So before I go into the next section, let's just take a quick look at what we covered so far with the data frame. We came up here, we created our data frame. We did it from a Numpy array first, setting the columns and the index. The index setting it up is the same as when we set up the series, so that should look very familiar. So is the whole format, the Numpy array, the index dates, and the columns. And remember, in our Numpy array, we're looking at row, comma, column. So 6 rows, 4 columns is how that reads in the data frame. And we went ahead and also did that from a dictionary. In this case, animal was the column name with all the data underneath that column, and then age with that data, visits that data, priority that data. And then of course we added our labels in there for our index. So there's no difference in there, but it automatically pulled the column names. Important to know when you're dealing with a data frame and importing a data frame this way. And then we did looking up D-type. We looked at head and tail, looking at your data really quick. We also did index and columns and values. And note these don't have the brackets on the end. So the next thing we want to do is go ahead, since we're dealing with data science, is we want to go ahead and describe the data. So we have df2.describe to do that, and we're going to manipulate it in just a minute, but let's just see what this generates. And you can see right here we have age and visits. So looking at our data from up above, let me just go all the way up here. Animal, age, visits, priority. And it does a nice job generating your age versus visits, which has all the data. You have your count, your means, your standard deviation, your minimum value, 25% are in this group, 50%, 75%, and your maximum value. So this will look familiar as a data science setup with your describe for a quick look at your data frame data. So let's start manipulating this data frame and moving stuff around, and we'll start with transposing. And it is simply capital T for transpose. And when we run that, it flips the columns and the indexes. So now the indexes are all column names and the columns are all indexes, animal, age, visits, priority. So if we had come in here with our data shaped wrong, up above where we had a 4x6, we can quickly just swap it if we had it backwards. Not a big deal. And we can also sort our data, something that you can't do, which is more difficult to do with a lot of other packages. In the data frame, it's really easy to do. Take our data frame df2 and we're going to sort underscore values by equals age. And so when we run this, you'll see the default is ascending. So we have 0.52, 2.53, and everything else is organized. So if you look at your indexes, they've been moved around because each index, it moves the whole row, not just the one piece of data is not being sorted. So a very quick way to sort by age our different data in the data frame. And in addition to sorting it, we can also slice the data frame. So I could do df2, and this should look familiar from earlier. We'll just do 1 to 3. So we're going to pull out, oops, it does help if I use a df instead of just d. And we're going to pull up just between 1 and 3. So we have not 0, which is A, but we have B, which is 2, or B, which is 1, and C, which is 2. So 1, 2, and then it does not include 3, which is the standard in Python. And we can even do something like this. We can combine them, which is always fun. Because remember, this returns a data frame. So if I take df2 dot sort values, and we'll do by equals age. This is just kind of fun. And then I'm going to slice it. There we go. Double check my typing and run it. And now you should see FA, because FA are now 1 and 2 on there. So you can very quickly create a whole string on here which narrows it, that you can sort it, then slice it, and do all kinds of fun things with your data frame. We'll just go back to the original one. Run. There we go. And if we can slice it by row, we can also query the data frame. So we can do df2. And this is a little different because I'm going to create an array within an array. And in this case, we're going to look at, let's do age, comma, visits. So look at the different format in here. We have 1 to 3. So we've done this by slicing by an integer value. And then on here, I've done df2 age, comma, visits in an array. And when I run this, you can see that we get just these 2 columns on here. We get age and visits. So it's a quick way to select just 2 columns or select number of columns you're working with. And if you saw up there, we did the slicing. Almost identical to slice is iLocation, which uses the integer location 1, 3. There's a push in Pandas to move to this particular setup instead of doing just a regular slice. And that's because this can be confusing when we slice 1 to 3 and then we select age and visits. So there is a push to go ahead and move to an iLocation, which does the same thing. You can see here BC, it's the same as up above. There's also a copy command, so we can do df3 equals df2 copy. We're just going to create a straight copy of it. And of course, if we do df3, it'll be the same as a df2 on there. So df3 equals df2.copy. And then let's do df3.isNull. So we're looking for null values. And this will return a nice map, and you'll see that everything is false, except when you go up here under the cat or H, they had a null there. And so if we go, they have a couple up here also underneath of, let's see, the dog. Okay, there's a bunch of nulls in here. There's D up here. So let's look at D down here, and you'll see false, true. There it is. There's our null value. So we can create a quick chart of null values. You can use this to do other things. We can leverage that null value to maybe take an average or something and fill those null spaces with data. And we can also modify the location. So here's our df3 location. And notice this is location, not iLocation. iLocation has I for integer. Location uses the, in this case, the variables on the left. And what we can do on here, and we'll go ahead and just set this equal to 1.5, and then let's pick a spot. Let's go back up here where we had, let's do F age. Let's see, what was we looking at? Oh, here we go. Let's do F and age. And up here, F is set to age of 2.0. And we find out that that's incorrect data, so we go ahead and switch to df3 equal, and then we go ahead and print out our df3. And if we go to F and age, it is now 1.5. So we're just changing the value in the df3. And this is changing the actual data frame. Remember, a lot of our stuff we do a slice, and like it returns another data frame. This changes the actual data frame and that value in the data frame. So we've covered location and iLocation is null. Making a copy, here's our iLocation, which is equivalent of a slice, and also selecting columns. So now we want to just take a little detour here, and let's look at df3 means. And this is kind of nice because you can do this. You can either do this by, you can select a single column here, by the way. You can just add the column selection right here like we did before. So we could have age. Look up the mean, that just creates a series. If I run that, there's our age. But if I take that out, instead of selecting it, we can do the whole setup, and it has age and visits. So why doesn't it have priority or animal? Well, those are not integers, so it's really hard. They're non-numerical values. So what is the average? I guess you could do a histogram, which probably we'll look at that later on. But the only two things we can really look at is age and visits, and we have the average or the mean on the age is 3.375, and the mean on visits is 1.9. And let's do df3 visits. We'll go ahead and still the visits again. And you remember all those different functions we looked at for a series? Well, we can do those here. We can do the sum. So if we run that, we'll see that these sum up to 19. We could also look up minimum. If you remember that from before, the minimum is 1, max. So all that functionality is here. I'll just go back to summing it up and adding it all together. So real quick, we've shown you how to take the series operations and put them into the data frame. And then we can actually, this is an interesting one, we can just do df3 sum, run, and you'll see the different summations on there. It just combines them. I like the way it just combines the strings on there for priority and animal. We've looked at is null. We've also looked at copying, along with the different slices which we talked about earlier. So let's talk about strings. Let's dive into the string setup on there. And let's go ahead and create a string series. String equals PD series. And we just put it right in there. We have A, C, D, AA, BA, CA, popped in a null value, cow and owl. I don't know why they picked cow and owl in the background. Someone must like those animals. And of course we can just do string. If we run that, you'll see, leave the R out, we'll get an error. But if we put it in there, you'll see that we have a simple series. 0A, 1C, 2D, and it automatically indexes it 0 to 8. And then we can go string dot lower. So when we're talking about our data frame, in this case, or our data series string, in this case, we use the string function str, and we're going to make it lower. And if we go ahead and put the brackets on there, and you'll see that we've gone from capital A, capital C, so on to ABC, and baka, CBA, cow, owl, they were all lowercase already. And of course, if you want to go lower, you can also do upper. We'll go ahead and run that. And you can see we now have ACD, AAA, baka. Everything's capitalized except for the null value, which is still null. Alright, so we looked at a few basic string. You can see that string functions upper and lower. We're going to jump into a very important topic. I'm even going to give it its own header on here because it's such an important topic. What do you do with missing values? Panda has some great tools for that, so we'll dive into those. We'll work with df4, and if you remember the df copy from above, we're just going to make a copy of df3. And let's just take a quick look at the data we're working with. Oops, df3, forgot the 3 on there. There we go. So here we have our cats, snakes, and dogs. Hopefully not all in the same container, because that would be just probably mean to all of them. So we made a copy. We're going to be working with df4. And the reason we made a copy is we want to go ahead and fill the data. And we just simply do fill NA, and then we're going to give it the value we want to put in there. We'll give it the value 4. So I can run in here, and you'll see now that df4 now has where the NA was, it's filled with the value of 4. Same thing down here. A lot of times we'll compute the mean first. So I might do a mean age equals df4, and then we want to go ahead and do age and dot mean, and then I'll do something like this, df4, I only want to select the age, and I want to fill that with the mean age. And I run in there, and you'll see that our df4 age now has the means in there. Just a quick way of showing you how you can combine these. Let me go back to our original one. There we go. And run that. And keeping with good practices, df5 equals df3.copy. And then we'll print our df5, which should be the original one. And then on the df5, we can now drop our missing data. I'm going to simply drop NA, and we're going to use how equals any. So I'm going to drop any row that has missing data in it. And you'll see we had D here with missing data and H. And then let's go ahead and see what df5 looks like when we do that. There we go. And there it is. D is gone and so is H. So we create a new data frame off of this, missing those values. Now, if you have a lot of data, dropping values is a good way to take care of it because you don't miss some data. If you have not a whole lot of data, you're working with like the iris data set or something like that, or something small, you want to start trying to find a way to fill that data in so you don't lose your computational power of the data you got. So just a quick look at processing null values or missing values. You can fill them, usually with the means. Some people use medium or the mode. There's different ways you can fill it. One way is means. And we can also just drop those rows. Those are the two main things we do with missing data. Here we go. We're going to cover next. I so love data frames for this. File operations. It saved me so much time because they have so many different tools for bringing data in and saving data. So when we're looking at the data frame file operations, it's really streamlined. I don't know how many times I'll go on to different data downloads and they'll have Panda download standard on there just because it's so widely used. So let's start with the most common file is a CSV. So we have df3 to CSV or animal. And let me just show you what the folder is going into. Right now I have some untitled and a few things in here, but nothing labeled animal. So we go ahead and run this, and this has now saved the animal to my hard drive. And you can now see the animal folder up here, and if I, let's do edit with a notepad. Oh, let's open it up with just a regular notepad. There we go. Or WordPad. If I open that up, you can see it's comma separated. Our titles, they don't have an index on the categories on the top. And the index, comma, then all the different data is separated by commas. Standard CSV file on there. And if we're going to send it to CSV, and notice the format is .to_CSV. And it's just the name of the file we're sending it to. You can also put the complete path. By default, it's going to go whatever the active directory this program's running on. That's why those other folders are in there. So we have our df3 to CSV, and then if we're going to put it in there, we want to also get it back out. And we'll call this one df_animal equals pd read_CSV. I always have to remember it's to_CSV and read_CSV. I always want to do like a capital in there and not the underscore. We're going in here again, it's the active directory. So if I now do print out my df animal, and let's just do the head. We only want to look at the first three lines. So if I go ahead and run this, we'll see the first three lines and they should match up here what we saved to our CSV. So very easy to save and import from our CSV files on here. And it turns out df3 also has a to Excel. They actually have a lot of different formats, but old school Excel was real popular for so long, still is. We can go ahead and save it as animal.xlsx. We're going to call the sheet named sheet 1, and then I can also do df, we'll call it animal2, and this one's going to come from, and the same format on here. There we go. So we still have our animal xlsx, the sheet 1, that's where it's coming from. Index columns equals none. So we're going to suppress the indexing on the columns. NA values, and it'll just assign it's 0 on up on your indexes. So if it says index columns equals none, that's what it does. And then we've added null values because there's null values in here, and we want to just make sure that they're marked as NA. And we'll go ahead and just print out the animal2, there we go. And let's run that. Let's just do the whole thing. So we'll go ahead and run that. And it probably doesn't help that I completely forgot the read. So animal2 equals pd.read Excel. There we go, Excel. So now we go ahead and run it. And what we expect is happening here. We have the same data frame on here. And if I flick back to my folder, you can now see that we have the animal. One of these is in Excel, and one of these is a CSV on here. And so there's our two file types on there. And they have other formats. These are just the two most common ones used, and I don't know how many times I've had stuff from Excel I need to pull out. If you've ever played with Excel, it's a nightmare in the back end because of the way they do the indexing. So this just makes it quick and easy to pull in an Excel spreadsheet. So we looked at two different ways to bring data in and save it to files. We've looked at all kinds of different ways of manipulating our data set and slicing it and creating it for our data frame. Let's get in there for your visualization. Always the big thing at the end, because one, it lets you check to see what you did, make sure it looks right. And then also, if you're going to show somebody else, it makes it very clear what's going on if they see something visual. So this is where a really important part of data science is. So let's go ahead and bring in our tools. We're going to do import Numpy as NP. We want to make sure we have our ampersand matplot library in line. This just lets Jupyter know that we're going to print it on this page. If you're using a different IDE, you don't really necessarily need that, but this does help it displays correctly in Jupyter Notebook. And if you remember for earlier, we could create a, we're going to call it TS. We're going to create a pandas, which are cute, cuddly creatures, versus pandem, short for pandemonium? No. So we have TS equals PD series, and we're just going to create a random setup of 50. We'll do an index. We'll set it equal to the pandas date range today. Periods equals 50, so the 50 should match. And I want you to notice something here. I did not import the matplot library. Why? Because it's already in there. Pandas already has its built-in connection and interface with matplot library, so you don't have to import it. And we'll go ahead and do TS equals TS dot cumulative sum. We're going to do the cumulative sum. So a little reformatting there, and we'll go ahead and plot it. And let's take a look at what that looks like. So we have a nice graph here. We have the dates on the bottom. We've set this up so we have a nice range between, in this case, -4 to, looks like about 2 maybe, or 1, -4 and 1. So what we've done here, we plotted a basic series, just a single row of data, and we've set indexes on there. But we can also do the whole data frame on there, and let's see what that looks like. So first, let's go ahead and create the data frame. We have here random numbers, so we're going to do 50 by 4. And then we'll go ahead and create columns A, B, X, and Y, just because we can. Index is a ts.index on there, so we're going to use the same index as before, just to keep it nice and uniform. We've already generated the dates to go with it. And then we can do, just like we did with the series, we can also do with the data frame, df equals df cumulative sum. So we're going to sum the whole data frame. And then we'll do simply df plot. And let's push that in, and let's go ahead and run this. And look how easy and quick that was to generate a nice graph with all the different data on there. So we have our shared index, we have the shared columns, and then we have the different data from each one that we can easily look at and compare. So very quick way of displaying data. You can imagine if you were working in, I think I mentioned stock earlier because I've been doing some analysis of stock lately. So you'd have your date down here, and then you would have stock A, stock B, stock XY, whatever it is. And you can put them all on one chart and see how what they look like next to each other. And this isn't too far off from what some of those graphs look like, and this is just randomly generated. So stock has a lot of randomness in it, which is one of the reasons I actually play with it for doing some of my models on, for testing them out. Now, there are a lot of features in Pandas. So we're going to show you one more thing on here. There's some of the things, like I didn't go too deep. We looked at the top two for importing data from a CSV and from an Excel spreadsheet. Showed you how to quickly plot the data. There's more settings in there you can do. We're going to do one more thing down here, and this is kind of a fun one. Change this to a markdown and run that. So how would you remove repeated data using Pandas? And this is where you have a data set that comes in, and maybe it's feeding from one location, and instead of noting that it's repeated the date, like, let's go back to stocks. That's a good visual. We have the stocks from the 23rd. And it adds another row, and it's the same row. It's importing the 23rd again and again. So now you have that data repeated 3 times, and you need to go back and figure out how to get rid of it. How do you track that down? So let's start by creating a quick database, or data frame. Not a database. I keep saying database. It's a data frame. And we'll just make this data frame using our dictionary going in. This data frame only has one data series in it, which is fine. So if we do df to print it out, you'll see A, 1, 2, 2, 2, 2, 4, 4, 4, 5, 6, 7, and so on. And so how would you remove that? Well, there is a neat feature in data frames called shift, along with another feature that lets us select just certain information. And we'll go with the location function. Put that in brackets. Remember that from above, location. And then in the location, let me just spread this out a little bit so it's real easy to read. In fact, I'm going to go upscale on that since we're doing a little bit more complicated here. What you can see on this, on the location, is I have dfa.shift. So this is going to shift up 1 by default. You can actually change this to 2 or 3. You can even do a -1 and it shifts the other way. But it's going to shift up by 1 by default. And it's going to say if that does not equal df of a, then we want that. And if you look down here, we had 1, 2, 2, 2, 2, 2. When we run this logic on here and we do the shift, it now gets rid of all the duplicates. So we went from 1, 2, 2, 2, 2, 4, 4, 5, whatever it was. Here it is, 1, 2, 2, 2, 4, 4, 4, 5, 5, 5, 6, 6, 6, to 1, 2, 4, 5, 6, 7, 8. And you'll see on the index, it just deletes them out of there so the index stays the same. Obviously, you don't want the dates to change if you're working with an index dated setup. So it just deletes those duplicates out of there. This is just a quick way to introduce you to, 1, the fact that you can add logic gates into here. And 2, the iLocation allows you to use shift. So there's the shift function, and then the iLocation selects that based on true or false. Wow, so we've actually covered a lot today in Pandas. We've really covered into the basics of selecting your different series out of your column, out of your data frame, how to index rows, how to slice, how to plot. Hopefully you'll take this beyond that and start combining these different things, and you can create long strings and really explore your data, generate some nice graphs. If you're in Jupyter Notebook, it's a great demo to show others. And I didn't know this about Jupyter Notebook. You can do this in Jupyter Notebook, and then you can download. And I never really looked too closely at all the downloads. But you can download it as an HTML and post it to your blog. So it's got a neat feature in there. But any of this is really powerful tool. All of this is really powerful tools for doing your.
If you're an aspiring data analyst looking for online training and certifications from prestigious universities and in collaboration with leading experts, then search no more. Simplilearn's postgraduate program in data analytics from Purdue University in collaboration with IBM should be your right choice. For more details, use the link mentioned in the description box below.
So currently I am on my MySQL workbench. Let me connect to the local instance. So I'll give my password. I'll click on OK. Alright. So this is my MySQL workbench query editor. So first we are going to learn subqueries. Let me give a comment and write subqueries. Alright. So first of all, let's understand what a subquery is. So a subquery is a query within another SQL query that is embedded within the where clause, from clause or having clause. So we'll explore a few scenarios where we can use subqueries. So for that, I'll be using my database, that is SQL_intro. So I'll write my command use SQL_intro. Now this database has a lot of tables. I'll be using the employees table that is present inside SQL_intro. Let me just expand this, and you can see here we have an employees table. So let me first show you the contents within this table. I'll write select star from employees. Let me execute it. Okay, you can see here we have the employee ID, employee name, age, gender, there's date of join, department, city and salary, and we have information for 20 employees. If I scroll down, you can see there are 20 employees present in our table. So let's say you want to find the employees whose salary is greater than the average salary. In such a scenario, you can use a subquery. So let me show you how to write a subquery. I'll write the select statement. In the select statement, I'll pass my column names that I want to display. So the column names I want are the employee name. Then I want the department of the employee and the salary of the employee. From my table name, that is employees. Next, I'll use a where condition where my salary should be greater than the average salary of all the employees. So I'll write salary greater than. After this, I'm going to write my subquery. So I'll give select average of salary from my table name, that is employees, and I'll close the bracket and give a semicolon. So what it does is, first it is going to find the average salary of all the employees that are present in our table. Once we get the average salary number, we'll use this where condition where salary is greater than the average salary number. So the inside subquery, let me run it first. If I run this, this gives you the average salary of all the employees, which is $75,350. Now I want to display all the employees who have salary greater than $75,350. So let's run our subquery. There you go. So there are 8 employees in our table who have a salary greater than the average salary of all the employees. Alright. Next, let's see another example. Suppose this time you want to find the employees whose salary is greater than John's salary. So we have one employee whose name is John. Let me run the table once again. Okay, if I scroll down, you see we have an employee as John. You see this? Our employee ID 116 is John and his salary is $67,000. I want to display all the employees whose salary is greater than John's salary. So basically all the employees who are earning more than $65,000, I want to print them. So let's see how to do it. I'll write select. I want the employee name, comma, the gender of the employee. I also want the department and salary. From my table name, that is employees, I'll write where salary is greater than. I'll start my opening bracket. Inside the bracket, I'm going to give my inner query, that is select salary from employees where the employee name is John. So within single quotations, I'll give John as my employee. I'll end with a semicolon. So let me first run my inner query. So this will give us the salary that John has, which is $67,000. Now I want the employees who are earning more than $67,000. So let's run our subquery. Okay, so you can see 12 rows returned, which means there are 12 employees in our table who are earning more than $67,000. You see here, all these employees have a salary greater than $67,000. Okay. Now, you can also use subqueries with two different tables. So suppose you want to display some information that are present in two different tables, you can use subqueries to do that. So for this example, we'll use a database that is called classic models. You can see the first database. So let me use this database called classic models. I'll write use classic models. Now this database was actually downloaded from the internet. There's a very nice website. I'll just show you the website name. So this is the website, that is mysqltutorial.org. You can see here they have very nice articles, blogs from where you can learn MySQL in detail. So we have downloaded the database, that is classic models, from this website. You see here they have a MySQL sample database. If you click on this, it will take you to the link where you can download the database. So they have this download link which says download MySQL sample database, and the name of the database is classic models. Alright, so we are going to use this classic models database throughout our demo session. If I expand the tables section, you can see there are a lot of tables that are present inside this classic models database. We have cricket, customers, there's employees, office, there's orders, order lines, and many more. So for our subquery, we'll be using two tables, that is order details and products table. First, let me show you the content that is present inside the products table first. If I run this, you see here it says 110 rows returned, which means there are 110 different products that are present in our table, which has the product code, the product name, product line. We have the product vendor, description, quantity in stock, buy price, MSRP. The other table we are going to use is order details, which has the details of all the orders. Let me show you the records order details tables has. Okay, so there are 1000 records present in this table. You have the order number, the product code, quantity ordered, price of each item. You have the order line number as well. Okay, now we want to know the product code, the product name, and the MSRP of the products whose price of each product is less than $100. For this scenario, we are going to use two different tables and we are going to write a subquery. Okay, so if you see here in the order details table, we have a column called price each. I want to display the product code, the product name, and the MSRP of the products which have a price of each product less than $100. So the way I'm going to do is, I'll write select product code, comma, product name. Now one thing to remember, that this product name is actually present inside our products table, and product code is present in both the tables, that is products and order details. Here you can see this is the product code column, comma, MSRP, which is present inside the products table again, from my table, that is products, where I'll write product code. I'm going to use the in operator. Next, I'll write my inner query, that is select product code from my table order details, where my price of each product is less than $100. Let me run this. Okay, so you can see there are total 83 products in our table which have a price less than $100. You can see the price here. Okay, now we learn another advanced concept in SQL which is known as stored procedures. I'll just give a comment saying stored procedure. Okay, so first let's understand what is a stored procedure. A stored procedure is an SQL code that you can save so that the code can be reused over and over again. So if you want to write a query over and over again, save it as a stored procedure and then call it to execute it. So in this example, I want to create a stored procedure that will return the list of players who have scored more than 6 goals in a tournament. So I have a database called SQL_IQ. These are a few databases that I have already created. So this database has a table called players. If I expand the tables option, you see we have a table called players, and you can see the columns player ID, the name of the player, the country to which the player belongs to, and the number of goals each player has scored in a particular tournament. So I'll write a stored procedure that will return the list of top players who have scored more than 6 goals in a tournament. So first of all, let me begin by using my SQL_IQ database. We'll run it. So now we are inside the SQL_IQ database. Let me select star from players to show the values that we have in the players table. You can see there are 6 players in our table. We have the player ID, the names of the players, the country to which these players belong to, and the goals they have scored. So I'll write a stored procedure. So the stored procedure syntax is something like this. It should start with a delimiter. Okay. In the delimiter, I'll write &&. Next, I'll write create procedure followed by the procedure name. Let's say I want to name my procedure as top_players. Next statement is begin. After begin, I'll write my select statement. I want to select the name of the player, the country, and the goals each player has scored from my table, that is players, where I'll write goals is greater than 6. I'll give a semicolon. Then I'll end my procedure with a delimiter that was double ampersand. Next, I'll write delimiter and give a semicolon. Now the semicolon suggests this is a default delimiter. And there should be a space. Okay. Now let's run our stored procedure. There you go. So you have successfully created our stored procedure. Now the way to run a stored procedure is you need to use the call method and give the procedure name, that is top underscore players in our case, with brackets and a semicolon. Let's execute it. Okay, there is some problem here. So we made a mistake while creating a procedure. The name of the column is goals and not goal. Let me create that procedure again. Okay, it says the procedure top underscore player already exists. Let's just edit the procedure name. Instead of top player, we'll write it as top players, and similarly we'll edit here as well. Now let's create it again. Okay, now to call my procedure, I'll write call space followed by the procedure name, which is top underscore players. If I run this, you can see we have 2 players in our table who have scored more than 6 goals. So we consider them as the top players in a particular tournament. Alright. Now there are other methods that you can use while creating a stored procedure. One of the methods is by using an in parameter. So when you define an in parameter inside a stored procedure, the calling program has to pass an argument to the stored procedure. So I'll give a comment stored procedure using in parameter. Alright. So for this example, I'll create a procedure that will fetch or display the top records of employees based on their salaries. So we have a table in our SQL underscore IQ database which is called employee details. I'm going to use this table. You can see we have the name of the employee, the age, sex, then we have the date of join, city and salary. Using this table, I'll create a procedure that will fetch or display the top records of employees based on their salaries, and we'll use the in parameter. So let me show you how to do it. I'll write delimiter. This time I'm going to use /. I'll write create procedure followed by the procedure name. Let's say SP for stored procedure, sort by salary is the name of my procedure, and inside this procedure I'll give my parameter in. I'll create a variable var and assign a data type integer. Then I'll write begin followed by my select statement, where I'll select the name, age, salary from my table name, that is EMP details or employee details. I'm going to order this by salary descending, and I want to display limited number of records, so I'm using this limit keyword and my variable var which I created here. I'll end my select statement. I'll end my stored procedure with /, and I'll go back to my default delimiter, that is semicolon. Alright, so let me run this. There should be a space here. Alright, so let's run this. Okay, you can see we have successfully created our second stored procedure, which is sp underscore sort by salary. Now you can also check whether the stored procedure was created or not. Here you have an option to see the stored procedures. Let me just refresh this, and you can see we have 3 stored procedures that we have created so far. One is sp underscore sort by salary, the other two were top underscore player and top underscore players. Okay, now let's call our stored procedure. I'll write call space followed by the stored procedure name, which is sp underscore sort by salary, and inside this I'll give my parameter, which was actually var, and this var we have used in limit. Let's say I want to display only the top 3 records of the employees who have the top 3 highest salaries. Okay, so let me run it. There you go. So Amy, Sarah and Jimmy were the top 3 employees who have the highest salary. So you saw how you could use the in parameter in a stored procedure. We created a variable, and that variable we used in our select statement, and we called our stored procedure and passed in that variable. Okay. Now, instead of a select statement inside a stored procedure, you can also use other statements. Let's say update. So I'll create a stored procedure to update the salary of a particular employee. So in this procedure, instead of select statement, we'll use the update command. In this example, we'll use the in operator twice. So let me show you how to do it. I'll write my delimiter first, which is going to be /, then I'll write create procedure. My name of the procedure is going to be update salary, and inside the update salary name I'll write in, and then temp underscore name, which will be a temporary name variable, and the type I'll assign is varchar 20. I'll again use my in parameter. I'll write in. Next, my other variable would be new underscore salary, and the data type would be float. I'll write begin and write my update command or update statement. I'll write update table name, that is employee details, set salary equal to new underscore salary, where name is equal to my temporary variable, that is temp underscore name. So this is my update command, and I'll end the delimiter. Alright, so let's run this. Okay, we have successfully created our stored procedure. If I refresh this, you can see I have my stored procedure update underscore salary. Okay, now let's say, first of all, I'll display my records that are present inside employee underscore details table. Okay, so we have 6 rows of information. Let's say you want to update the salary of employee Jimmy, or let's say Mary, from 70,000 to let's say 72,000, or let's say 80,000. So I'll call my stored procedure, that is update underscore salary, and this time I'm going to pass in 2 parameters. The first parameter will be the employee name, and next with a comma I'll give my new salary that I want to. So my employee name, let's say, is Mary, and the salary I want to be updated is, let's say, $80,000. I'll give a semicolon and I'll run it. You can see it says 1 row affected. Now let's check our table once again. There you go. If you see this record, for Mary we have successfully updated the salary to $80,000. Now moving ahead, we learn to create a stored procedure using the out parameter. So I'll give a comment, stored procedure using out parameter. Okay, so suppose we want to get the count of total female employees. We will create total employees as an output parameter and the data type would be an integer. The count of the female employees is assigned to the output variable, which is total underscore EMPs, using the into keyword. Let me show you how to write a stored procedure using the out parameter. So first I'll declare my delimiter 2/. I'll write create procedure followed by the procedure name. It is going to be sp underscore count employees, and inside this I am going to give my out parameter and the variable name, that is total underscore EMPs, which is total employees, and the data type will be integer. Next I am going to write begin followed by my select statement, that is select. I want the count of total employees, and the output I am going to put into my new variable, that is total underscore EMPs. From my table, that is EMP underscore details, where sex is equal to F, which means female. I'll give a semicolon. Next I'll end it with the delimiter, and I'm going to change the delimiter to a default delimiter, that is colon. So let me tell you what I am doing here. I'm creating a new stored procedure, that is sp underscore count employees. Using this stored procedure, I am going to count the total number of female employees that are present in our table EMP underscore details. So I've used my out parameter and I'm creating a new variable called total underscore EMPs. The data type is integer. Here in the select statement, I'm counting the names of the employees, and the result I am storing it in total underscore EMPs. I have used my where condition where the gender or the sex is female. So let's run this. Okay, so we have created our stored procedure. Let's refresh this. Okay, you can see we have our new stored procedure sp underscore count employees. Now to call it, I'll write call the name of the procedure, that is count underscore sp underscore count employees. Within brackets I'll pass in the parameter as @f underscore emp. I'll give a semicolon. Then I'll write select @f underscore emp as female employees. Okay, so as is an alias name. Let's run this one by one. First I'll call my procedure and then we'll display the total number of female employees. You can see in our table we have 3 female employees. Alright, now with this understanding, let's move on to our next topic in this tutorial on advanced SQL. Now we are going to learn about triggers in SQL. So I'll give a comment here, triggers in SQL. So first let's understand what is a trigger. So a trigger is a special type of stored procedure that runs automatically when an event occurs in the database server. Now there are mainly 3 types of triggers in SQL. We have the data manipulation trigger, we have the data definition trigger, and login triggers. In this example, we will learn how to use a before insert trigger. So we will create a simple students table that will have the student's roll number, the age, the name, and the student's marks. So before inserting the records to our table, we'll check if the marks are less than 0. So in case the marks are less than 0, our trigger will automatically set the marks to a random value, let's say 50. So let's go ahead and create our table, that is students. Alright. So I'll write create table student. Now this table will have the student roll number. The data type is integer. It will have the age of the students. Again, the data type is integer. We have the names of the students. So the third column would be name. The data type would be variable or varying character. Size I'm giving it as 30. Finally, we have the marks as floating type. So let's create this table, which is student. So we have created our table. Now I'll write my trigger command. So trigger command will start with delimiter, like how our usual stored procedures have. Next, this time I'll write create trigger. Then you need to give the name of the trigger, that is marks underscore, let's say verify. I'm going to use a before insert trigger, so I'll write before insert on my table name, that is student. Next I'll write for each row if new dot marks is less than 0, then we'll set new dot marks equal to 50. So this is my condition. First we'll check before inserting if any student has marks less than 0, we'll assign a value 50 to that student, because usually the marks are not less than 0 in any exam. I'll write end if semicolon and I'll close the delimiter. So this is my trigger command. I'll run it. It says trigger already exists. So in this case we need to update the trigger name. Let's say I'll write marks underscore verify underscore student for ST. Let's run it again. Okay, there is an error here because in our table the column name is mark and not marks. So here we need to change it as mark instead of marks. Alright, let's run it. Okay, so we have created our trigger. Now let me insert a few records to the student table. So I'll write insert into student. I'll write values. I'll give the values as 501, which is the student roll number. The age is, let's say, 10. The name is, let's say, Ruth. And the marks is, let's say, 75.0. Give a comma. We'll insert our second student record. Student roll number is 502. Age is 12. The name is, let's say, Mike. And this time I'm purposely giving a value of minus 20.5. Give another comma. We'll insert the third record for student roll number 503. Age is 13. The name is Dave. And let's say the marks obtained by Dave is 90. Now we'll insert our final record for student number 504. The age is 10. Name I'll enter as Jacobs. and this time again I'm purposely giving the marks in negative 12 point, let's say 5. I close the bracket and give a semicolon, and I'll run my insert statement. Okay, so we have inserted 4 rows of information to our student table. Now let me run the select query. I'll write select star from student. If I run this, you see the difference. There you go. So originally we had inserted for 502 the marks was minus 20.5, and for 504 for Jacobs the marks was minus 12.5. Our trigger automatically converted the negative marks to 50, because when we created our trigger we had set our marks to 50 in case the marks were less than 0. So this is how a trigger works. Now you can also drop a trigger or delete a trigger. You can just write drop trigger followed by the trigger name. In this case our trigger name is marks underscore verify underscore st. I'll just paste this here, and if you run this it will automatically delete your trigger. I'll give this as a comment. Okay, now moving on. Now we are going to learn about another crucial concept in SQL which is very widely used. This is known as views. So views are actually virtual tables that do not store any data of their own but display data stored in other tables. Views are created by joining one or more tables. I'll give a comment as views in SQL. Okay. Now to learn views, I am going to use my table which is present inside Classic Models database. Now this database, as I mentioned, we had downloaded it from the internet. So first of all, let me write use Classic Models. So I'll switch my database first. Alright, now we are inside Classic Models. So here let me show you one of the tables which is called customers. So I'll write select star from customers. Okay, I missed S here. Let's run it again. So this is my customer table which is present inside Classic Models database. It has the contact last name, the contact first name, the customer name, customer number, we have the address, state, country, and other information. Now I'll write a basic view command using this customer table. The way to write is I'll write create view followed by the view name which is cust underscore details. Then you write as select. I'm going to select a few column names from my original customer table which is this one. So I need the customer name. Let's say I need the phone number and the city. So you have this information here. You have the phone number and the city. Alright, I'll write from my table that is customers. If I run this, my view that is cust details will be created. Let's run it. There's some error here because the name of the table is customers and not customer. I'll give an S and I'll run it again. Alright, so you can see we have created our view, and to display the contents that are present inside our view, I can write select star from followed by the view name that is cust underscore details. Let's run it. There you go. So we have the customer name, the phone number and the city of the different customers that we have in our table. Alright. Now let's learn how you can create views using joins. So we'll join two different tables and create a view. So for that I am going to use my products table and the products lines table. I'm talking about the products table and the product lines table present inside Classic Models database. So before I start, let me display the records that are present inside the products table. Let's run it. So these are the different products you can see here. Now let's see what we have in product lines table. So we have the product line, the text description, and there is some HTML description and image. So I'll create a view by joining these two tables and will fetch specific records that are present in both the tables. So let me first start by writing create view followed by the view name, that is product underscore description, as I'll write select product name, comma, then I'll write quantity in stock. I also want the MSRP. Now these three columns are present inside the products table, and next from the product lines table I want the text description of the products. So I'll write from products table, I'll give an alias as P followed by inner join my other table, that is product lines, as let's say PL on the common column, that is product line. So P dot product line is equal to, I'll give a space, PL dot product line. Okay, so here we have used an inner join to fetch specific columns from both the tables, and our view name is product underscore description. Let us run it. Alright, so we have our view ready. Now let me view or display what is present inside our product underscore description view. I'll write select star from product underscore description. Let's run it. There you go. So we have the product name, the quantity in stock, MSRP, and textual descriptions of the different products in the table. Okay, now there are a few other operations that you can perform. Let's say you want to rename a view. Instead of product underscore description, you want to give some other name. So I'll just give a comment, rename description. So to rename a description, you can use the rename statement. I'll write rename table product underscore description, which is my old name. I want to change this name to, let's say, I'll give vehicle description, since all our products are related to some of the other vehicle. So I'll write vehicle description. Okay, let us run it. Alright, so here you can see I have renamed my view. So here if I just refresh it and I'll expand this, you can see we have the cost details view and we have the vehicle underscore description view. Okay, now either you can view all the views from this panel or you can use a command. Let's say I'll write display views is the comment. Now to show all the views, you can use show full tables, where table underscore type is equal to, within single quote I'll write view. So this is the command that will display all the views that are present inside a database. There is some error here. Let's debug the error. This should be okay. So instead of table types, it should be table type equal to view. Let's run it. You can see the two different views that we have. One is customer details, another is vehicle underscore description. Okay, now you can also go ahead and delete a view. For that you can use the drop command. So I'll write drop view followed by the view name. Let's say I want to delete customer underscore details or cust underscore details view. I'll write drop view cust underscore details. Let's run it. You can see here we don't have the cust underscore details view anymore. Alright. Now moving to our final section in this demo. Here we will learn about Windows functions. Now, Windows functions were incorporated in MySQL in the 8.0 version. So Windows function in MySQL are useful applications in solving analytical problems. So using the employees table present inside my SQL underscore intro database, so we'll find the total combined salary of the employees for each department. So first let me switch my database to SQL underscore intro database. I'll run it. Okay. I'll display my table, that is employee. So here we have 20 employees in our table. Using this table, we are going to find the combined salary of the employees for each department. So we'll partition our table by department and print the total salary. And this we are going to do using some Windows functions in MySQL. So I'll write select. I want the employee name, the age of the employee, and the department of the employee, comma. Next I'll write the sum of salary over. I want to partition it by department. So I'll write partition by department, which is DEPT, and I'll give an alias as total salary, so that it will create a new column with the name total salary from my table, that is employees. The output will be a little different this time. Let's execute it and see the result. There you go. So here we have created another column in our result, that is total salary, and for each of the employees and the respective departments we have the highest salary. So in finance, the highest salary of one of the employees was $155,000. Similarly, if I come down, we have the highest salary from HR. If I scroll further, we have the highest salary from IT, marketing, product, sales, and the tech team. Alright. Now we'll explore a function which is called row number. Now the row number function gives a sequential integer to every row within its partition. So let me show you how to use the row number function. I'll write select row underscore number function over my column would be salary. So I'll write order by salary. I'll give the alias as row num. I'll give a comma, and I want to display the employee name and the salary of the employee from my table, that is employees, and I'll order by salary. So let's see how our row number function will create sequential integers. Okay, you can see here we have a row num column and we have successfully given row numbers to each of the records. You can see it starts from 1 and goes up till 20. Okay. Now this row number function can be used to find duplicate values in a table. To show that, first I'll create a table. I'll write create table. Let's say I'll give a random name, that is demo. And let's say we have in this table the student ID, which is of type integer, and we have the student name, which is of type varchar. The size is 20. I'll create the small table with a few records. Let's create this table first. Now we are going to insert a few records to our demo table. So I'll write insert into demo values I'll give 101, the name is Shane, give a comma, I'll insert the second student name, 102, the name is Bradley, I'll give a comma. This time for 103 we have two records. Let's say the name of the student is Herath. I'll give a comma, I'll copy this and we'll paste it again. So we have duplicated 103. Next we have 104. The name of the student, let's say, is Nathan. Then again, let's say for the fifth student, which is Kevin, we have two records. I'll copy this and I'll paste it here. Let me give a semicolon and we'll insert these records to our table demo. Alright. Now let me just run this table for you. I'll write select star from demo. If you see this, we have a few information that are duplicated in our table, that is for student ID 103 and student ID 105. Now I am going to use my row number function to find the duplicate records present in my table. I'll write select student underscore ID comma student underscore name. I'll give another comma and write row underscore number over, within brackets I'll write partition by st underscore id comma st underscore name. Okay, then I'll write order by st underscore id, close the bracket. I'll give an alias as row num from my table, that is demo. Let's just run it. You can see here, okay, let me just delete n from here and do it again. Alright, now if you see here, there is just one student in the name Shane, we have one student in the name Bradley, but here if you see for Herath, the second record it says 2, which means there are two records for Herath, and if I scroll down there is one record for Nathan and there are two records for Kevin, which means Kevin is also repeated. Okay, now we are going to see another Windows function that is called rank function in MySQL. So the rank function assigns a rank to a particular column. Now there are gaps in the sequence of ranked values when two or more rows have the same rank. So first of all, let me create a table, and the name of the table would be a random name. We'll give it as, let's say, demo1, and it will have only one column, let's say variable a of type integer. We'll create this table first. Okay, now let's go ahead and insert a few records to our table, which is demo1. So I'll write value 101, 102, let's say 103 is repeated. I'm doing this purposely so that in the output you can clearly distinguish what the rank function does. Next we have 104, 105, we have 106, and let's say 106 is also repeated. Finally we have 107. Okay, let me insert these values to my table, that is demo1. Okay, this is done. Now if I write select var underscore a and use my rank function, I'll write rank over, then I'll order by my variable, that is var underscore a as an alias name, let's say test rank, from my table that is demo1. Let me execute this and show you how the rank function works. Now if I run this, there you go. So here if you mark, so for variable A101 the test rank is 1, for 102 the test rank is 2, but for this value which is 103 the test rank is repeated because there was a repetition for 103. So we have skipped the rank 4 here. For 104 the rank is 5 now, for 105 the rank is 6 now. For 106 again, since the record was repeated twice, we have skipped the 8th rank and our rank function has assigned the same value which is 7 for 106, and for the last value 107 the rank is 9. Alright. Now moving ahead, we'll see our final Windows function which is called first value. So first value is another important function in MySQL. So this function returns the value of the specified expression with respect to the first row in the window frame. Alright. So what I'm going to do is, I'm going to select the employee name, the age and salary, and I'll write first underscore value, which is my function, and pass in my employee name, and then I'll write over order by my column that is salary descending. I'll give an alias as highest underscore salary from my table that is employees. So let me run this and see how the first underscore value function works. Alright, so in our table Joseph was the employee who had the highest salary, which was $115,000. So the first value function populated the same employee name throughout the table. You can see it here. Now you can also use the first underscore value function over the partition. So let's say you want to display the employee name who has the highest salary in each department. So for that you can use the partition. I'll write select emp underscore name, comma, I want the department and the salary, comma, I'll use my function that is first underscore value followed by the name of the employee inside my first value parameter. I'll write over, here I'm going to use partition. I'm going to partition it by department, since I want to know the employee name who has the highest salary in each department. And I'm going to order by salary descending, and I'll give my alias again as highest salary from my table that is employees. So let's run this and see the difference in the output. Okay, so as you can see here, we have the employee who had the highest salary from each department. So for finance, Jack had the highest salary. From HR it was Marcus. Similarly in IT it was William. If I scroll down, for marketing it was John. For product it was Alice who had the highest salary. Similarly in sales we had Joseph, and in tech we had Angela. So this is how you can use the first underscore value function using partition. Alright, so that brings us to the end of this demo session on our tutorial. So let me just scroll through and show you what we did from the beginning. First we learnt about subqueries in SQL. So we initially wrote a simple subquery, and then we used our classic models database which was downloaded from the internet. I'd also shown you the link from where you can download this database. Here we used two different tables and we performed a subquery operation. we learned how to create stored procedures. So we learned how you can use the in operator or the in parameter as well as the out parameter in stored procedure. After stored procedure, we learned another crucial concept in SQL which is called triggers. Now triggers are also a special kind of stored procedures. So we saw how to write a before insert trigger. You can see it here. Next, we learned how to delete a trigger. We also saw how to work with views in SQL. So views are basically virtual tables that you can create from existing tables. We also saw how you can use views using two different tables and an inner join. And we learned how to display views, how to rename view names, how to delete a view, and finally we explored a few Windows functions.
So let's discuss what's in it for us today. Now, we will first talk about why Power BI, why it's a popular tool and what problem it solves, what is Power BI, and what are the primary features of Power BI, which you can use in your day-to-day data analytics, visualizations, creating fancy reports, creating meaningful, intelligent reports for your organization, for your personal use, for crunching numbers, for generating reports real time, etc. Now, the most popular tool for Power BI is the Power BI desktop. I'll show you certain aspects of Power BI desktop, and then I'll show you the steps how to install Power BI desktop on your machine. And then definitely Power BI desktop is a free tool provided by Microsoft, but then you can also subscribe for an enterprise version, which is primarily used by enterprises for publishing their data. So we'll see the difference, and then overview of dashboards which can be created. What kind of dashboards can be created in Power BI. So this is the agenda for us today. Now, why Power BI? So generally, visualization tools, reporting tools are required in order to create and prepare and analyze meaningful data. It could be a data for an organization. It could be a social media platform data. It could be a data from IoT devices, but something which needs to be analyzed and some intelligent inferences and data mining has to be done on top of it. Now imagine today we are in a world where terabytes of data and information is getting generated on an instantaneous basis, on minute by minute basis. So it becomes very essential to churn out something meaningful, something intelligent out of it. In the market, there are a lot of other tools which are available like Clix, Alteryx, Tableau, and Power BI. So Power BI is a Microsoft product, which is one of the most popular products, and it comes as a free to download product, Microsoft Power BI desktop, which is available, and I'll show you a couple of ways how you can install it on your machine. But why Power BI is popular is because it provides a lot of out-of-the-box features, drag and drop features, which we will talk about in our subsequent sessions and classes. But today's session is primarily focused on giving you guys an introduction on what is the purpose of Power BI and what all problems it solves in the real world. So Power BI allows you to view, analyze and visualize huge quantities of data, and the data could be in any format: Excel, CSV, text, or it could be a direct connection to a database like SQL, MySQL, Azure, Oracle, anyone, IBM DB2. So it supports n number of data types or data sets, and it's very powerful in terms of data connectivity. So it uses powerful compression algorithms to import and cache the data within the .pbix file. So it's as convenient as a simple software. If suppose you import a data and then you prepare a report, and then you can easily share the reports with your peers or someone who's co-developing with you, either through Power BI cloud services, or even you can share the PBIX file in an email or through any other means, and you can share the data set with the concern, and they can then work on the report independently. So there are different ways. There is no kind of a limitation for working on Power BI. There are multiple ways, and it is very fast. It is the most fast tool to work with Excel, because definitely Excel is also a Microsoft technology, so it works very fast on Excel based data and gives you numbers and reporting at a very high speed. So now once you have imported the data, Power BI allows you to model the data, allows you to work intelligently on the data. It allows you to model the data in a way that if you are importing data from multiple Excel sheets, importing data from multiple tables, you can easily create a relationship between those tables or data sets in Power BI, and then create visually appealing reports, meaningful reports, as I've been emphasizing, and make sense out of that data. No data in silos is of any use. Data in silo means a single worksheet or a single data set will not churn out any meaningful information until and unless you basically join it, club it, merge it, union it, append it with some other data sets, because a single data set will never be able to hold that much amount of information which is generally required for a important report. So it has easy drag and drop functionality with features that allow you to copy all formatting across similar visualizations. So just like in Microsoft Excel we use Format Painter to copy the format of one cell to another, similar features, very similar to Excel products or Microsoft products, they have provided that if you have applied a particular theme on a report, you can easily replicate that on any other report. The font, the header size, the background color, you don't need to do it again and again. So there's a lot of reusable features which are also available. Okay, now as I said, Excel is a Microsoft product, Power BI is a Microsoft product, so they have intercompatibility. You can publish data from Excel to Power BI. Now with the latest developments and enhancements, as of today, Excel has also plugged in a new feature called Power Pivot, which I'll show you later down the line. But that also allows you to do a quick analysis. You can't create, of course, complex reports or fancy reports like Power BI, but Power Pivot allows you to create, quick measures, quick functions, quick calculations on your data quickly only in Excel. So it's an Excel plugin. But whereas, Power BI is also compatible with Excel. So when you create a report in Power BI, it gives you inbuilt feature to export your Power BI report into Excel format directly. You don't need to do any programming for it. Also, you can easily publish, when you publish your Power BI reports, it allows you to give some inbuilt intelligence of analyzing your reports in Excel, and it gives you all those features of exporting your Power BI reports into Excel, which is not available in any other tool, or otherwise those tools have to create plugins, create add-ins, and probably they might charge for it. But Power BI comes with a lot of out-of-the-box features which are very, very helpful for analyzing data in Excel, and vice versa. Azure Cloud. Now Azure itself again is a Microsoft Cloud tech stack. So using Power BI with Azure allows you to analyze and share large volumes of data. So Azure, basically Azure database or Azure cloud servers are meant to hold huge amount of data, and Power BI allows you to have seamless connection. You can easily connect to Azure Data Lake. You can reduce the time it takes to get insights and increase collaboration between business analysts, data engineers, and data scientists. So Azure Data Lake becomes the central focal point where all your analysts, engineers can keep working on the centralized piece of data and churn out their reports. Data scientists' primarily job is to keep the data in a structured way, optimized way, optimize the input-output operations, disk operations, and memory utilization, so that the reports also get churned out in a faster manner. So every every person has their own role in order to give a quick refreshable report, a quick rendered report. Any report which is taking huge amount of time to get rendered will not eventually be used by the business users, because then it does not solve the purpose. The report should be fast. Report should have appropriate filters, slices and dices. You should be able to create the reports or dynamically, or you should be able to visualize the data dynamically. So all those visualization features are available in Power BI, and it works seamlessly. Either it is small data or huge data. It allows that you to work on those kind of data in a seamless fashion. Right. So this is just a very quick example of how a typical dashboard looks like. Dashboard is nothing but, you have clubbed a couple of multiple reports on a single page, and if you change a filter, a single filter on the page, all the reports will honor that filter and the numbers will change accordingly. So if you see in this example, there is a filter or a drop down of product ID, product name, employee name, or supervisor, or a date range. So whatever date range or filter you will apply, all the reports on this dashboard will get changed based on the filter you have selected. So Power BI allows you to get insights from data and turn insights into action to take data-driven business decision. And that is the ultimate goal of any visualization tool. That is the purpose for which visualization tools are bought and purchased by the organizations, and data is fed into them. Now, Power BI fetches data from factory sensors, social media sources to get access to real-time analytics, so that you are always ready to make timely business decisions. So basically, there is a feature of live connection or cutoff data connection. So either you can work on data which is residing on a machine and you can just work on the cutoff data. Like for example, there's a data which is available for sales 2017, 2018, and you're just working on a historical data. It's a cutoff data. Or it could be possible that you want to be connected live to a real-time IoT based, sensor based data, or social media data like Twitter, Facebook feeds, or you're connected to live Google worksheets. That is also possible. You just need to publish your Google sheet for a public domain, embed the URL into Power BI, and then whoever updates that Google sheet, automatically the Power BI report will also start honoring and consuming the new data which is added in the Google sheet. So all those kind of real-time streaming analytics is also possible, and that is one big feature and very important feature of Power BI, which is widely used and has a very huge market acceptance and market utilization. Now, what is Power BI? Power BI is a business analytics service provided by Microsoft that lets you visualize your data and share insights, right? So earlier, Microsoft used to have a technology called SSAS. Now they have replaced actually SSAS and SSRS with Power BI. So basically you can use Power BI on the data which is there in your Excel or any other data source, and the Power BI service or Power BI desktop basically creates a connection to those data sets and import it, cache it, and give you a handle to it in order to work with it. So you can create these fancy, meaningful visualizations. Like for example, there is a geographical map. If you are importing data for a country or a continent or a region, Power BI will automatically detect that it's a geographical information and give you a map with latitude, longitude information, and you just need to plot your numbers on the map. Either you can use bubbles or either you can use triangles or whatever data structure you want to use, but all the mapping will be available geographically. Then you can create pie charts, which is shown in this visualization. You can create tree maps. You can create cards where you can highlight the most important numbers like sales, total sales of your company across all the regions, or the growth chart or the month on month sales of your organization, or total number of products or units sold. So whatever is important and to be highlighted for the management to take any meaningful decision or any insights you want to share. Power BI visualization tool, the Power BI visualization chart allows you to drag and drop and create wonderful reports. Okay. So what are the features of Power BI? So Power BI desktop is something, a standalone tool which you need to install on your machine. It allows you to build reports by accessing data easily. You do not need advanced report designing or query skills to build a report. Though yes, it is beneficial that if you know some SQL programming, analytical programming, or you are aware of advanced features of any analytical tool, that might help you, but that's not a showstopper. You can easily build reports in quick turnaround time without needing any technical background. You just need to have some analytical mindset, and you can create savvy visualization and analytical reports. Stream analytics, as I mentioned, you can create a live connection with any kind of data. It could be IoT, it could be media, social media, it could be Google Docs, it could be any other kind of live connection. It could be a live database connection itself. So any insertions or updations or deletions happening will automatically reflect in your report. Yes, multiple data sources, and that has to be the primary criteria for any tool to be popular. If any visualization tool is limited to certain data sets, then it will not be highly acceptable in the market. And custom visualizations, right? So as I showed you certain examples in the past, in the previous presentation, that feature is very important because someone might want to look at the KPIs from a different perspective. Some management might want to look at the KPIs from a different perspective. So you need to have that capability to create different visualization from the same data set. Now let's take a look at how to install Power BI desktop on your machine. So basically what you need to do is you need to go to this URL, powerbi.microsoft.com ENUS desktop. Okay, and you need to just enter this. Now you can download it for free. So just click over here and it will open Microsoft Store. So basically now what Microsoft have done in the latest operating systems is that when you are trying to download, you can actually directly go to the Microsoft Store and search for Power BI. So let's wait for a couple of seconds. Right here. So Power BI desktop in Microsoft Store. For me, it's already installed, so it's asking me to open it. I'll open it in a while, but for anyone who is not installed, he will see the button of install over here, and it will automatically install in your machine, and then you can easily go and open Power BI desktop. Now if I click open over here, now this is the UI of the Power BI desktop. I'm not going to go right now in creating reports right away. We will talk about that in a subsequent session with sample data sets, and we will cover the features of Power BI desktop one by one. But this is what it is. This is the whole tool of Power BI, which is having the visualization pane. All the different visualizations are can be created from this pane. Then this is the pane which allows you to select the data fields. Then there is a report view data view and relationship view, the data model view, where multiple relationships you can create. You can view the data in the grid of the tables which you will create, and the reports. So you can create multiple reports on multiple pages. You can keep adding pages. Either you can create multiple reports on a single page and it will become a dashboard, or you can create separate independent reports on the single page. And these are the menu options which we will talk about. How you can change color scheming, you can do data modeling, you can create new reports, and you can also transform data, which is the biggest feature. Extract, transform, and load the data, apply different logic, changing data types, massaging the information, creating new joins, appending the data, adding new columns, etc., etc. That is what you can do in transform data. So this itself is a whole different world. It's a dedicated topic. So we will talk about that in our subsequent sessions. So what's in it for us today? We will be learning how to connect to data, different data types, data files like Excel, PDF. Then what are the different data importing modes? And then I will also show you practically different sets, how to import them in Power BI and use it for your visualization purpose. Now, what are the steps to connect to data? So now we will go directly into Power BI and try to import one by one few most commonly and popularly used data sets which are most commonly used in a day-to-day activity. Rest, of course, there are Power BI supports n number of data sources, but we will do something practical on the most popular ones. So let's open our Power BI. Now this is my Power BI, and first I want to show you that how can I import data directly from a web page and import the data. Now it is asking for a URL in order to import data. So what I have done is I have created a Google Excel sheet with simple data with rows and columns, and what I have done is I have shared this sheet as published to web. Okay, so you just need to say publish to the web, the link as web page, and say done. It's automatically published, and say link. So copy the link which you have published on the web, copy this link, and then go back to your Tableau, paste that link over here and click OK. Now Power BI will try to establish a connection with this Google Doc sheet because it's published on the web. You need to wait for a while it is reading. Okay, now it has read one of the HTML tables, so I'll select this one. Now you can see it is showing me a preview of the table which is there on my Google sheet, right? It has 11 rows, so it has all showed all the 11 rows. So now I can go and transform this data because I can see my headers are there starting from the second row. So there is an opportunity for me to transform the data. So I'll go and transform it so that it looks clean. Okay, so first is I need to remove the first row, which is the null row. Remove the top rows. Okay, and then I need to use the first row now as a header. So you just click this option, use first row as headers. That's it. So now if you see my row ID, order date, ship date, all my data is now ready. So I can say close and apply. Click apply changes. Now this is an example of web data import. You can go and preview your data. Right? Now the biggest advantage of this data connection is that it's a live data. So for example, I insert another row. Let me change the order ID. I've changed some basic stuff, and it's auto saved. Control S. Now I'll go to my Tableau and I'll refresh. Now you can see as I refreshed my Power Query Editor, I clicked refresh all and I got my new row which is there in the live data. I got that fetched from my, okay, I got that row, the row ID number 12. So I have to say close and apply. Now you can see the new row, the row number 12 is now available in my new dataset, in the dataset, because it's a live connection. It's a live connection with the web-based Google Sheet. Okay, so this is one important way in which you can import data. Now let's try to import data from a text file. Now I have already prepared a text file called subcategories.txt. Now let me just open it in a notepad. Now it's a very plain simple file, tab separated file in which you have product subcategory ID, subcategory name and product category key. So basically to which product category this particular subproduct belongs to, right? So what I'm going to do is I'm going to go back to my get data option and I'm going to select text/CSV option and I'm going to select option mod product subcategories.txt. Okay, so now Power BI has identified that it's a tab delimited file, it has recognized the headers, etc., right? And I can now directly load this file. Okay, so now once the data is imported in Power BI, it is like irrelevant to me. It's a composite data import I am doing, right? So in my presentation, when I am talking about importing data, there are different importing modes, right? Data import can happen through different ways. Okay, one is direct query mode, in which I create a live connection to the database, which I'll also show you using MySQL and MS SQL Server. And also you can do a composite mode in which you can have data imported from Excel, plus you can have direct query modes. So you can have multiple modes to connect and create a composite data model, and that's what we are doing right now in our practical. So what we are doing over here is, one, we have imported data from the web. Second, we have imported data from a text table. Now after doing text, now our next task is to import from CSV. Let's try another one. So now I have imported product subcategory. Now I'll import a CSV file. So again I'll choose the option text/CSV, and now in this CSV file, let me open this CSV file and show you what is it. So this is a list of all my products, product key, product subcategory key, products stock keeping unit, etc. A simple CSV file, and I'm going to import that. Okay, so now it has identified the delimiter is comma rather than a tab, and it has already recognized the headers correctly, so I'll load it. Okay, so now my products are there, product subcategories are there. For product categories, now what I have done is I have created a Excel mode now. So now Excel I'm using to import my product category. So now I have to click on the option of import data from Excel, and I'll say product categories. Select the sheet, load, and now so my products, product categories, product subcategories, though with different data storage types, but still now the data is imported into Power BI. It is a composite data model. Now another very important data type which you can import is the PDF also, right? So what I have done is I have created a PDF called customers. My customers data is lying in a PDF. So what I've done is I've created a PDF which has data for some columns are there, like customer key, prefix, first name, last name, birth date, marital status, gender, email address, annual income, total children, etc., etc. So this is the data set which I have created in PDF. So what I'm going to do is I'm going to select PDF now and import customers.pdf, and see it has recognized my table on page 1 which I'm going to load. Okay, you can rename this as PDF table. So this basically, these are the different type of data types we have imported: PDF, Excel, text, CSV, and web page. Now let's take a look at another interesting data set which we want to import, is the MySQL Server data set. So what I have done is I've already installed MySQL Server on my local instance, and there's already a schema of SQLite tutorial over there, and I have certain tables already prepared over there like department, employee, etc. So my goal is now to import this data or create a live connection with this data set. Now in order to import my SQL database connection in Power BI, you need to first download a connector, MySQL Power BI connector. So you need to go to this link and then click on download and install the MySQL connector. Based on the operating system you have, you click on download and install it. After you have done this, go back to Power BI and then give the IP address of the database. In my case, it's there in this local machine, and the schema which I want to import is SQLite tutorial. So I'll give the name, click connect. Okay, now it's connected. So now it is asking me which particular tables you want to create a connection with. I'm choosing department and employee, and I'm just loading them. Okay, so now this is the exact data which is there in the employee and department in MySQL. Okay, so this is one example of how to create connectivity between Power BI and MySQL. Now I want to do the same thing using SQL Server, Microsoft SQL Server. So I have also installed Microsoft SQL Server on my machine, and I have used the SQL Express. So this is the name of my server, so which I'll copy the server name and go to get data, select SQL Server, and for now database is optional. I can say direct query, click OK. Okay, now it is showing me what all tables I can import. So in my SQL Server tutorial, in my SQL Server, I have these three tables: customers, employee attrition, Olympic events. So I can use probably the customers one, which is now you can see this is the data, the customer's data, which is lying in my SQL server. Okay, so I can preview it and load it. So now you can preview the data in Power BI. That is, this is the data. So I can rename as customers from MS SQL, and this is from MySQL, and okay. So now this is not the only data sets you can import. Now if you take a look at the options which Power BI gave, of what different type and variations of data it can it has compatibility to import from. Okay, so we can just take a look at the categorization on the left hand side first. There are file based like Excel, text, XML, JSON is also possible. You can evenly directly import an entire folder, and within the folder whatever data types of files are there, it will detect it. PDF, Parquet, or even SharePoint folder, which is itself a Microsoft technology. Then different kind of databases, SQL Server and MySQL we just saw, but it's not only limited to this. You can connect to Microsoft Access, SSAS, Oracle database, IBM DB2, Postgres, Sybase, Teradata, and then SAP databases, Amazon, Redshift, Impala, Vertica, Snowflake, and n number of databases which are there in the market today, Amazon, etc. Then it also allows you to connect with its own Power platforms, Power BI platforms, data marts, Power BI data flows, Dataverse, etc. Azure, there are different kind of storage mechanisms in Azure, and Azure itself is a Microsoft technology, so it has a compatibility with a lot of Azure based data storages like Azure SQL database, blob storage, Azure Databricks, right, Azure HD Insight, Spark. So if you have those kind of services running on your Azure cloud services, you can even import them over here. Now online services, like you have ERPs running or some data which is shared on the internet. If you want to import it, that is also possible through certain products. Dynamics 365, Microsoft Exchange Online, Salesforce, Google Analytics, Adobe Analytics, GitHub, LinkedIn Sales. If you want to do some analysis of some social networking, feeds, that also you can import. Then other miscellaneous are also there, web-based, Hive, R script, Python script, if there's something to import, get data from. Google Sheets, like we saw one example in our video right now. So there are multiple options available. Now, once you have imported the data which is relevant to you, in our subsequent sessions, we will see how to create relationships, but just giving you a glimpse that whatever data you are importing, Power BI auto detects certain relationships and it will create for you, but then you can go and manually also change. So this is the composite data model which is getting created in the backend while you are importing the data. You can easily go and manage these relationships, either keep them as is, you can delete and create new ones manually. So there is no limitation in that. So this is what we have witnessed. We have imported data from different files types, data types, and then we have tried to, once it is imported into Power BI, then there is no limitation of how you use it. You can create visualizations across different data sets and then create your standard reports. So this is the example of importing data from web, importing data from a database, from a PDF, and then once you have data, you can shape and combine data. You can basically do whatever transformation you want to do. You want to make joins, merge the data. So for example, if we go back to our Power BI, and if I go back to my transform data section, now as I have now different data sets available with me, I can do any kind of operation, transformation on the data, right? So like I showed you, I upgraded the header row because one of the imported data was not showing the header correctly, or this column, like this exact one column is extra, I can remove the column, right? All those transformations, whatever I do in the backend gets captured in the applied steps section, right? This is the customer data. You can create, you can merge it, you can append it, with other data sets, right? Let's, for example, I want to create a merge data set of my categories and subcategories. So I can say merge, select those two data sets and say merge queries as new, and I can select product categories and product subcategories, select product category key on both the sides, and then they do a left auto join. So whatever product categories are there, I'll get the subcategories associated with it, and I'll create a new table which will have, now I have the table which has the category and the subcategory and subcategory in one table itself. So I can rename it now to as category subcategory table. It's a merge. Basically, it's a join between category and subcategory, and now I have a common table, right? And I can close and apply. So imagine I have created a new table which is created from one data set which is Excel based, and another data set which is text based. See this category subcategory table. So now I can use it the way I want in my visualization reports. So that's what the presentation says, right? That once you have the imported data, you can shape, you can combine, you can adjust, you can do whatever transformation you want to do and create your visualization. Okay, so what topics we are going to cover today? We are going to talk about different types of data modeling, and the most important part and aspect of data modeling is the cardinality. The cardinality which you basically decide after reviewing the nature of data, and after you've imported it, what kind of cardinality you have to basically highlight, right? And there are different type of cardinalities which you might have heard earlier also if you're from PL SQL background, like 1:1, 1:many, etc. We will talk about that. Now, what are the different types of data modeling? Now, dimensional data modeling is one of the most popular and most widely used modeling. In dimensional data modeling, you have master data, like for example customer data, date, store data, product data. So these are like less frequently changing data sets. So there is an organization, right, and you have set of customers, their email ID, phone numbers, etc. that will change less frequently as compared to the sales transactions, because transactions are happening every day, every minute. So sales is a more fast changing data set in dimensional modeling, which is in the terminology of data is also called as a fact. And customer, store, product, which are like more of static data and less changeable data, is sometimes called a dimension. So this is a typical dimensional data model which is typically used sometimes, right? And then there is another model which is relational model. This is a typical model which we have been using in database design, like primary key, foreign key relationships. So for example, you have a customer who has purchased a product. So probably he might have the customer might have the details of the product which he has purchased, and you will make a join between customer and product table, and even you can make a join between product or product type or customer or product type. So customer table will also have a key to the product type. So this is less conducive for reporting, but it is more of a transactional relational model. But of course this is also feasible. But from the Power BI perspective, when we talk about reporting and visualization, this is the most extensively used dimensional data model, and this is what we are going to see in our example now. So what I'm going to do is I'm going to show you certain data sets. First we will prepare and create certain of our data sets, and then we will import in our sample Power BI file, and then slowly we will create the relationships. Now, one important thing which you need to understand, that in Power BI, if you go to Power BI, there is an option that Power BI auto detect new relationships after data is loaded and import relations from the data source on first load. So for example, if you are importing the data from a database where you have already defined the primary keys and the foreign key relationships, so that is the first option which Power BI will auto detect. And secondly, if suppose you are importing two different kind of data sets, one is Excel, one is CSV, and if Power BI detects a common column, key columns, it will auto detect a relationship which you can go and later change, modify, manage in your relationship menu, manage relationship menu in Power BI, which I'm going to show you. Okay, so if I open a Power BI, and this is where the option lies, go to File, go to Options and Setting, Options, Data Load, and these are the two options which are by default checked. You can uncheck it and manually prepare relationships. There is no limitation to that, but if you keep it checked, then Power BI will do its job to detect the relationships. Okay. Now coming to the next important factor, cardinality. Now before I start playing around with my data and start showing you certain relationships, it's very important to understand these four types of cardinalities. One is many to one, right? So basically many to one means that many orders contain data of one customer. So per order one customer is there. So from customer to order or product or delivery address, it's a one-to-many relationship, and from the other side, from order to customer perspective, it's a many-to-one relationship. Okay. Second, other cardinality is 1:1. 1:1 relationship is only applicable when you are saying it's an extension of the current table. So for example, in one table you have employee details, and you are extending the details of the employee in another table like employee address, employee ID. So that is like 1:1. There is no multiple records of a single employee. In the address table, only one employee ID exists, right? Now 1:many, as I said, is the reverse side of many:1. So in customer table, only one customer record exists per customer, and one customer can place many orders for multiple products and can also have multiple delivery addresses. So that way this is a typical 1:many relationship. We will be seeing this example also in our sample data set. And last is the many-to-many relationship. Now many-to-many is a very typical example, so which I'm going to show you practically. And in our case we will see that, like for example, you have placed an order for a particular product, but there are multiple fulfillments which has happened. So suppose you made order for 10 products, but at the back end when the company is fulfilling, it is first fulfilling the first 2 products, then the rest 3. So basically the fulfillment is happening in batches. So one order ID might have multiple fulfillments for the same order ID. So there will be a many-to-many relationship, which I'll show you practically. So now with this background, let's start importing our data. Now the first important thing which we need to import is the master data. So first I'll import all my master dimensions which I'm going to use in my example. So first is the customers table, customers data. So this is the customer details, like customer key, prefix, first name, last name, birth date, marital status and gender. Some redundant columns are also present, but we'll remove it. So my customer data is loaded. Now today's session is all about this section of modeling. So we will keep our focus over here. Okay. Now some columns, probably some blank columns are there. I can select them and say delete from model. Yes. Okay. So now this is my customers data with the relevant columns and the key per customer, customer key. Now there's no relationship in this model right now, right? Because only single table is there and the associate data is only imported. Now let me also import my another important master table is the products. Select the product data, product key, product subcategory, product SKU, product name, model name, product description, color, size. So just see all the relevant information only specific to the product is available. So I'll import it. Okay. Now see, there's no relationship between product and customers directly, because until and unless a customer makes an order, places an order for a particular product, there is no join, right? So now between these two tables, the most important, now another table which will now make sense is the sales order table, sales table. Now I am assuming that Power BI have auto detected the relationship. Now you can see that because I've already ticked that checkbox. Now let's see what Power BI, what relations Power BI has auto detected. Let's first check the relation between customer and sales. I'll double click this join. Now what it has done is it has created a join of many to one between sales and customer. So what does that mean is that one customer has can place many orders, right? And that it has detected by the quality of the data and the data sampling which Power BI has done. You can also reverse this relationship. Here I can select customers and I can select sales. Now it has become one to many. So that you can also do manually. So that is what I said. Whatever Power BI is detected, it is up to the discretion of Power BI internal configuration and algorithm, but you can go and change it. So this is, now you can make, this is by default active. So we want to keep it active. One customer, many sales orders. Cross filter direction means that only from customers to sales is the filter applicable, not reverse. I'll come to this with my another example, but first let's change the relationship. So 1:many means from one customer and many sales orders. Similarly, let's see what has happened at the product side of the relationship. Similarly, Power BI, many sales orders for one product. You can, for simplicity's sake, you can say products, sales, product key is the join. Now just focus one more thing. Please also see the column on which the join is the grade column, grade out column. Product key is also here and product key is also there, and it is what we wanted. So 1:many relationship from product to sales table and active. Now looks fine. This is something which is looking logical, and probably now we can proceed further to create a report. Now let me explain the cross filtering with an example. Now, for example, I want to check in a report that what is the count of products which which a particular customer has ordered. Okay, so what I'll do is I'll select the product count of product name. Now if you see, and for each customer, in front of each customer name, the count is coming as 293, 293. It is getting repetitive because there is a one-way filter between customers and sales and products, right? So this join is single-sided. It means that from customer to product, you can't find a relationship because it's a single side cross filter, right? What does this, if I change it to both, it means that it is equal to a join between product and sales, and every product detail now is appended to the sales table. So if I want to make you visualize this, you need to go here. I'll first open my sales table. We can also open it here. Let's click this OK. Now if I click OK, you can see the single arrow is changed to double arrow. It means it's a both side filter. So when you say a both side filter, it means that implicitly within Power BI, you can imagine that all the product columns now will get appended because of both ways filter you have applied. And if you go to your report now, see the change of the numbers now, 40, 20. So the total count of products across all my customers come out to be 293. Now the report looks correct. If I change the relationship from back to single between product and sales, then you can't make a join between customers and product. Basically, you can't derive the product count from the product table. See this. If you have to live with it, then you would have to go to the sales table, get the product key and get the value of count of product key, but that is not correct. Okay. So if you want a report in which you want the count of product name, and even if you want a count of distinct product name, so this will not come correctly. You would have to go and change the direction of the filter, which is from single to both. So this is a typical example there where you want to use a two-directional filter. Now let's proceed further and import other data set in order to show you another example. Now I want to show you an example of 1:1. So I have another table which is called customer details. So the key in this table is again customer key, but only email address, annual income, total children, education level, etc. Other details of the customer is there. So I'm loading the customer details. Now you see it has auto detected a 1:1 relationship. Now what is the meaning of 1:1? Means one customer key only has one entry in customer details. There is no multiple entry. So if you click this button, it's a 1:1 and the cross filter can be both or single, doesn't matter, because one customer will have only one value. You can make this as active. Okay. And if you go to the customer report table, you can now easily associate a email address with the first name. You will get 1:1 record. So now you can see that with 1:1 relationship, with the first name, I have associated the email ID, and for each email ID, there is a associated first name with that. So this is an example of 1:1 relationship. So in this example, what we have explained is that for each customer, there is an associated customer detail, right? So you have the first name, email address, education level, homeowner, occupation, and total children count. So in this report, what we have done is, if you click over here, So the first name and the email address. Okay, so there's a 1:1 relationship, and if you drag the customer key, report takes time to render, and even if you can, so this is the reporting output. You have the customer key, first name, associated email address, and the count of product names which the customer has ordered. Now this is an example of 1:1. Now I want to show you an example of many to many. Now for that, I'll import my fulfillment data set. Okay, now in my fulfillment data set, there is a column for order number. So basically what I'll do is I'll drag order number from here to here. Okay, so now what has Power BI detected? I'll do one thing. I'll select sales over here, fulfillment over here, and order number to order number. Okay, so it's a many to many relationship. So it means that per order I have created multiple batches to fulfill that particular order. Now many to many relationship is definitely a candidate for both ways cross filter detection direction, but you can check that. But definitely Power BI shows a warning that this relationship has cardinality to many, and this should only be used if it is expected that neither column contains unique values. Okay, so we know that fact. That's why we are accepting this relationship as many to many, because we know there are multiple order numbers over here in the sales table which are mapped to the multiple order numbers in the fulfillment table. We'll click OK. Now you want to keep the direction as both ways or one direction. That is up to you, the way you want to map the report. So I can double click over here, and you can even click. So now you can select from which way single filter you want, from fulfillment to sales or sales to fulfillment. I'll prefer sales to fulfillment and click OK. Okay, now we have all our different kind of relationships over here, which we have tried to shortlist. One to many, many to one, one to one, which is this example, and many to many. Now if I show you further relationships which you can keep on adding, like for example I have the example of territories. Now in which particular territory the sales was done, so I can map it over here. Okay, so now it's a typical 1:many relationship, because territory is my master table where I have a static list of continent, country, region, and it is mapped to the territories which are in which my orders have been placed. So it's a typical 1:many. So that way, you can keep on adding data. Then you have details of returns. Now this is another transactional table which is about the orders which have been returned rather than being returned by the customers. So you have a product key, so automatically Power BI has detected a relationship between the product key and the product table, right? And even if you can join the territory key, in which territory the return has happened, right? So mostly the most common relationship which you will observe is the 1:many, because as I told earlier, the most common relational model is the dimensional model. The static data, the slow changing dimensions, the SCDs are the master tables, and the most frequent changing are the fact tables. So if I talk about a typical dimensional model, the fulfillment table, sales table, and the territories table, the fulfillment table, sales table, and my returns table are the fact tables of my data model. Now, so far, what we have done as per our last session is that we did data modeling on the different data sets which we had imported in Power BI, like products, sales data, returns, fulfillment, customer details, and customer master data, calendar details, etc. So in the last session, we prepared a data model and established the relationships between these different data sets, like 1:1, 1:many, many to 1, 1:1, etc. And we saw the examples. Now, once our relational model is prepared, our data model is prepared, now our next activity is to create certain additional columns which we want to derive basis the data which we have imported. So for example, I'll start with my product data set. Now in my product data set, I want to introduce a column which basically categorizes that if any product which has a color red, black or gray, I am going to tag it as a colored product. Rest I'm going to say not a colored product, right? So all these are like example of byte type product SKUs. So for that, now in order to introduce a new column, you just need to do what? You need to select the table in the data grid, go to the table tools and say new column. Okay, so column will get appended to the rightmost part and you will start seeing a formula section typical to like you get in your Excel. Now I'm going to say that the name of my column is going to be byte type color. Okay, and I'm just creating a if condition. If product color is equal to black, okay, or if it is equal to red, or if it is equal to gray, then say yes, it's a colored product, else say no. Okay, so now you can see basis the product color red and black, they are saying byte type color yes, blue is no, multi is no, etc, etc. So this is a classic example of an if and else condition based conditional column. Okay, so you can create such columns. Now second column, custom column, which I want to create is I'm going to call as discount. Now basis the pricing of my products, I want to associate certain discounts which I am ready to give to my customers basis the product category, like what is the pricing of the category. Again I'm going to make use of if else, but in a nested way. So if I am saying if my product price is less than 100, then I will give 0% of 0% of discount. So 0 into product price, just to keep it consistent. Now I'm saying else, if less than 100 then 0, else I'll check again that if the price is less than 500, then I'm ready to give 1% discount on the
product price, else I'll move further. So like this, I have created a formula. So what I'm saying is, if product price is less than 100, give 0%. If it is less than 500, then give 1%. Less than 2000, then 1.5%. Less than 3000, then 2%. And otherwise, else less than 3000, if it 2%, else 3%, right? Now, after this column is created, now you can check, right? So this, see, the product price for this particular product, it is less than 100, so that's why there is no discount. It is between 100 to 200, then this has been given a 1% discount. So like this, all the discount column is now calculated. Now this column is available just like a regular column in my product table. Now after this, I'll go to my sales table. Now in sales table, I want to identify, create a column called as cost. There is no product cost column over here, so that will be derived. So let's create a column called as cost, and it is derived by order quantity into, now the cost of the product is in the product table, and I know I've already created a relationship between product and sales table. So I just need to select the product cost column. Now only keyword which I have to use in Power BI is the related keyword. So this will pick up the relation, and now for this particular sale order, the cost has already been derived. So this order number, this is the cost for which the product is the costing of the product for this particular order. Okay. Now I'm going to create another conditional column over here called as order status. I'm saying if any order whose order quantity is greater than 2, then for my organization it's an urgent order, else it is a normal order. Oh, sorry, I lost it. So this is my order status column, and I have my order quantity, urgent or normal. So any order which has order quantity 1 is normal. Any order which is having order quantity as greater than 2 is urgent. You can see this. So there's this whole Power BI tabs and sheets allow you to also review the data, what you're doing. So it's very convenient. Now I have my sales data. Now what I want to bring within the sales is my discount column. So here also I want to bring the discount which I have created. So I'll say discount. Discount will be order quantity into related product discount, right? So the discount calculated column which I had created under products, I'll bring over here. Now I am creating the order level discount. So if you see, for this particular order, there's a 25 for 25 rupee discount at the cost is 100,000 rupees. Okay. And what is the order price now? So I have taken the order cost, the discount. Now I have to create a column called as price, order price. So that will be again order quantity into related price, which is per product, price, enter. Okay, so now I have the cost, the discount and the price, right, available with me. Now I want to calculate the total revenue, total profit and loss, right? Per order, how much? So first I'll calculate per order how much revenue I am generating. So now I have to generate a column called as revenue. Revenue is price minus discount so 1700 minus 25, 1700 minus 25, 2071 minus 42. And if I want to calculate the profit per order, then it is revenue minus cost. Okay, so now you can see, typical custom columns, calculated columns which we have created are all playing around with the numeric values, numeric data primarily, and trying to give inferences into per order cost, discount, per order price, revenue and profit. So typical calculation columns which I have prepared in front of you. Now let's take a look at other different variations of custom columns. I'll create certain columns for text-based custom columns, calculated columns using text-based data. So I'm now moving towards my customer table, in which I have customer key, prefix, first name, last name, birth date, marital status and gender. Now I want to create a new column in which I want to derive the age of each customer as of today, right? So I'll use another function, a date function called as date diff. Now date diff, so I want the difference between the birth date of the customer and as of today in years. Okay, so this customer as of today is 68-year-old, one is 74, 68, 57, etc. So this is one derivation of a calculated column of age. Let's take another example. Now this is a text based column where I want to derive the full name of the customer. Now here I'll say first lowercase, in lowercase I'll concatenate the prefix, then ampersand, space, ampersand, first name, ampersand, space, ampersand, last name, and closing brackets, etc. Full name. Okay, so this is an example of full name in lower cases. Now another calculated column, conditional column at the customer level. I want to identify a flag which says who is my target customer basis the demographics shared over here. Target customer. So I'll say if the marital status is equal to M and total children, and total children annual income. So okay, so let me change the logic a bit. So marital status is M and age is less than 50. These customers are my target customers. Okay, so I would say yes, else no. See this. His marital status is married, Logan Diaz, and age is less than 50, else everyone. So if I try to filter, so these are my target customers. 69 out of 1178. So this is just a conditional column, but a logical condition, an example which I'm trying to highlight over here. Okay, now let's look at certain calendar date oriented columns, calculated columns. Very typical, like now I have a simple date column. Now I'll keep adding certain columns which which will help you understand how we can do some calculations on the dates. So like for example, I want a date which is 12 days after the current date, the date in the column. So just simple 12 days after, select the date and add 12. Now if you see the date format, you can go and change the format at the top, and if whatever you feel like this. Now see, 12 days after 1st Jan 2015 is 13 Jan 2005. You can go and change the format and other details. Let me also show you, if I go to my cost and other columns, I can go and change the format. This is like a currency, cost is currency. So I can go and change the currency type, and you can even show the dollar value or whatever currency type it is. So for numbers, you can do currency, or text or dates, you can select the format. So this is available at the column tools level. Now in customers, like we had our column of full name. So now what all things are available? Format as text, okay, data type text. So very minimal options are there. With date you have options of the date format. Now next, I want a column which defines the expiry date. Okay, so 8 months prior to the expiry date which is coming up in 8 months. So I'll create a column called as 8 months expiry, and then there is a edate function. I'll use that. I'll use my date in the data set, comma, I'll say 8. So now this date column will append 8 months to my actual date, and again I can go and change the format. Correct. Now another important column, like I want to know the date name. So I'll use a function called as format, and I'll select my calendar date column, and I'll say give me the DDDD format of it. So it will give me the day name, the day name of on that particular date. Next, years in between. So I want the years in between the today's date and the date of my calendar. So equal to date diff, the calendar date, comma today, comma year, end. 7 years, 2015 to 2022. Then last date of the month. So if I want what is the last date of this particular calendar month, I will use a function EO month, which is there available in the Power BI. So I'll say last date of the month equal to EO month. Then just select the calendar CSV date, comma 0 in months, and enter. Change the format. Then similarly, start of the month. So I'll use a function called start of month. So for all January dates, end of the month is 31st Jan and start of the month will remain 1st of Jan. Change the format. Next, I want to know what is the week number of that particular date. So now there is an inbuilt function called week number, week num, and just pass the date and you will get the week number. First week of the year, second week of the year, etc. Now another very good example is whether the week day is a weekday or a weekend, right? So what is it? It's a week type. Okay. So I'll put a if condition, and there is a function called weekday, and I'll pass the calendar. If it is less than 6, it means it's a weekday, else it's a weekend. So all Saturday and Sunday day names will come as weekends, or else everything else will come as weekday. So these are very different variations of different column types, calculated columns, which is a very important utility, and any Power BI project you will definitely be ending up creating n number of calculated columns to derive your numbers, to prepare your reports. But it's important to understand what all things we can do. Yes, there are n number of functions available in Power BI. But what I have tried to showcase over here is some important functions. But basis your utility, basis your problem statement, you can look up for a relevant function in the Power BI dictionary. Now, with this introduction to calculated column, this is the base for us to now get into our next session. We will be talking about creating DAX measures and DAX functions. We will be using Power BI DAX functions, which is much more powerful than simple calculated columns, where you can do more complex calculations. You can calculate totals and then use them in the reports.
If you're an aspiring data analyst looking for online training and certifications from prestigious universities and in collaboration with leading experts, then search no more. Simplilearn's postgraduate program in data analytics from Purdue University in collaboration with IBM should be your right choice. For more details, use the link mentioned in the description box below.
In this session, we will start with certain exercises which we will perform in Tableau in order to understand some basic concepts. Now, in order to learn Tableau, the basic first step is to import a sample data. So in our case, what we have done is we have imported a sample superstore, which is in Excel format, a sample superstore.excel, which has 3 worksheets in it: orders, people, and returns. So by importing this data into Tableau, first of all, we will create relationships between these sheets in order to identify who all have placed orders and how many people have returned the orders. We will do some analysis on the orders placed by certain set of people and order returned by certain set of people. Now, as we have imported the sheet, we will make certain joins. So the first step is to drag the orders table, the order sheet, on the relationship canvas here. Okay, and you can see the data, sample data, the first 100 rows over here. Okay, then now we need to create an inner join with people's table between order and people. Okay, so if you see, it has automatically detected the field names on which the inner join has to be created. So on the order side, you have region, and on the right hand side, which is the people data, you have also a region. Okay, so both these columns are common, and that's how we have made a join between orders and people data. So if I close this box and go and check the people's data, open, so see the region and the person, these two columns from the people table have now been joined with the orders table, right? So it means that these are the orders in a particular region which has been placed by in this region. Let me show you the sample superstore Excel file. Now this is the structure of the file. You have a sample list of transactions, basically the orders which are placed by customers across multiple regions, south, west of USA, south region, west region. Then you have a list of order IDs which have been returned. So basically the order ID in the returns sheet matches with those orders in the orders table. And then you have the people sheet in which you have region and a person associated with that region, the salesperson associated with that region. Okay, so basically when we are joining orders with people, we are joining that which orders belongs to which region and who's the salesperson associated with it. So what we have done over here is we have made an inner join, means all the orders should belong to particular region and that region is in the people's sheet. And then in the second step, now we will make a left join between returns and orders, not inner join. We'll make a left join between returns and orders, and we will make a join using the order ID. Okay, so just edit this, click on left and select order ID as the join column. Now what does left join means? Left join means is that consider all the orders from the orders table and only consider the orders from the returns table which have data, means which are returned. Otherwise show null for the order IDs which are not returned. So if you see, these are the two columns from the returns table, and these are null because this is relevant to the order IDs which are not returned, okay, which has been accepted by the customer. But these are the orders for which you see data in the returned and order ID column. It means that these have been returned. Now with these joins in place, please save your book, and now we have our relations created in the Tableau. Now we are ready to create certain reports and extract certain KPIs using this relationship model. Now we'll move to sheet 1. Okay, and first we will place state and person on the rows sheet. Okay, then I'll go to my numbers and put the profit or the, so per state, per person, how much profit I am making as a company. Okay, this is my goal to check. Now sort by highest to lowest. So California is giving me the maximum profit of 76,381, then New York, then Washington. So this is the sorted order in which I have listed my profit in descending order. Now I can also check what are the number of orders placed and check the distinct count. So out of 120, out of the total orders of 127, okay, so this is the number of
total number of orders which have been returned for California is 127. It's 16, 29. So the sorted order is as per the revenue, as per the profit. And this is the details of the orders which have been returned per state. So if you see for Connecticut, for Kansas, there are 0 returns. So you can also extract data. Table to refresh is orders and identify new rows using order date. So as and when new data is being added, you can refresh it. Now say extract, and now you can save this information, profit by state, and click save. So this is the extraction of this particular report which is possible in Tableau. So this is the first exercise which we have completed for reviewing and analyzing the profit per state, highest to lowest, and within that per state, what are the number of orders which have been returned by all the customers, the distinct count of order IDs which have been returned. Now let's start our second exercise on creating calculated fields in Tableau. Now in this exercise, we will be doing certain activities, like we will be creating a set to show the states which have more than 100 customers. Then we will be creating a calculated field to show an average sales per customer. Okay. Then we will create a calculated field to show the sales goals, and then show emerging and developing stage. So these are the 4 KPIs which we have to derive. Now, the first thing, we have our sample superstore data already imported and the relationships created, inner join with people and left join with returns. Now we have our sheet 2 in which we will create the states, a list of states which has more than 100 customers. So what we have to do is we have to right click on the customer name and click create set. Okay. Now we have to give the name as states with 100 plus customers, and then go to the condition tab, select by field, and then apply condition as count of customer name greater than equal to 100 and click OK. Now we have this set created, states with 100 plus customers. Now to determine average sales by customer, we have to now create a calculated field. So go to the analysis and click on create calculate field. Okay. Now name it as average sales per customer, and now we will say average we will use a okay, so we are saying that per customer we are using a level of definition function include, which means that per customer what is my average
sales, right? We've already used a function, aggregated function called average. So we are saying per customer, give me the total and then give me the average per customer. So we're going to click OK. Now create another calculated field. You can also create from here and name it as sales goal. Now in this we are going to type the formula if minimum states with 100 plus customers equal to true, then sum of sales into 1.3, else average sales per customer into 100. So we are saying that if the customer belongs to the set of states with 100 plus customers, then the sales target should be 1.3 times the actual sales as of today, else it should be 100% of the average sales per customer. Now let's create another calculated field which we call as emerging or developing state. If distinct count of customer name is greater than equal to 100, then the state is tagged as developing state, else it is called as emerging state. Okay, so we have now 3 calculated fields: average sales per customer, emerging or developing state, and sales goals. Now we will use this in our reporting. So we will drag sales goal under the columns and then I'll drop my state. So now this is the state wise sales goal, depending whether the state has 100 plus customers or not. Then add your customer name. Make the measure as count distinct and make it as discrete. Okay, so if you see this, we have the count of customers per state and the sales goal for that particular state. And now I'll put my sum of sales, the total sales which I want per, which is there per state. Now go to show me and select this particular chart, bullet graph. Now to bring sales goals to column, right click on the sales axis and select swap reference line fields. Now from your left hand panel, drag and drop emerging or developing state on the color panel. Okay, so emerging state is the orange one and the developing state is the blue one. And save the sheet as developing and the emerging states. So if you see this, it's an emerging state because its count is less than, the customer count is less than 100. Its sales goal is 57384, but the actual sales is 19511. Okay. So now this is a developing state. Its count is greater than equal to 100 and its sales goal and its sales is exactly the same. It matches. So that's why you are seeing the bar and the blue bar is ending exactly where the vertical bar is. So what we are trying to depict is that whether the state is going beyond its target sales goal or it's behind it. And you can see that using this particular vertical bar, like for example Michigan, its sales goal is 71,952, but its actual sales is 76,270 average sales. So that's why it is above its target and it's a developing state because it has more than 100 customers. So you can even sort by the count of the customers higher to lower. So all your developing state will group from at the top and the emerging states will group at the bottom. Or you can sort by the sales goal. So the orange bar is the sales goal or the blue bar. So depending what sales goal is being derived for each state. The Netflix database which we have, and we will prepare certain reports in order to identify what kind of reports we can generate from such a data set. So currently on my screen what you can see is the Tableau, the Netflix data sheets, the data sources, where you have the Netflix shows, movies, their associated duration, what kind of shows or movies are there, their release year, the associated rating, description, and a key which is the show ID. Now this is the unique identifier for each show in this Netflix title sheet, and with this show ID all other sheets are related, like who are the directors of the show, in which country the show was released, what is the cast of each show, all that information is in this sheet, and to which particular category, basically the listed in category is being listed in this particular sheets. So what we are going to do is, first we are going to import this sheet into Tableau. Okay, and then create relationship between them using the Tableau relationship canvas. So first the primary transaction table, the sheet in which all the information related to movies is there or shows is there, is in Netflix titles, and then we will drag sheet like Netflix cast, titles cast. Now Tableau has automatically identified the relationship between the show ID of titles and show ID of titles cast, and it has made a join. So if you double click this, you can see this relationship, cardinality, and the related fields. Similarly, I'll drag titles category, countries, and directors. Now by virtue of this, all the sheets have now been joined with Netflix titles, and with this relationship ready, we can start preparing our reports. Now let's create a basic report where we can just glance the data, like whatever we were seeing in the Excel, how it looks in Tableau. So you have all the types of movies, then for example I drag the release year. Now first I do not want to
consider it as a dimension. So I'll just release year, per category, per type, there is a release year, and then I'll drop the listed in. So now these are the categories. So per year, the details of the categories, right? And then you can drag the title and the associated rating. So this is just a view of your data. We can name it as shows listing report. Now let's try to create some report for some measures, some numbers, etc. So now let's check in which country how many movies or titles were released. What is the count? So first let's drag the country. So as soon as we drag the country field, it has identified that it has the geographical names and identified the latitude and longitude details. So Tableau internally does that automatically, and it has identified the spots across the globe of the relevant country. Now let's drag the listed in on the color section. Now what it is doing is it is showing in which country what different kind of category wise movies are or shows are being released. Like in Sri Lanka, documentaries have been released. In India, action and adventure. United States, action and adventure, like this. Now let's put a count of the titles, right? So if you see 247 action and adventure movies or shows have been released in United States. Okay, so this is one inference by this particular report you can identify. So let's save this report as listed in by country. Okay, now let's create another report. We will call it as the per year statistical report. In this, first I'll put the release years in the column. Now count of Netflix titles. So this is the count of Netflix titles per year, so 2017, 2016, 14, and then count of Netflix titles in the countries. This is the second bar chart. Okay, now what I'll do is I'll combine it into one. So one report we are moving in the bar, creating the bar, and one in the line. And now I just have to, so we will click on the count of Netflix titles by country, right click, mark it dual axis. So now as soon as you click this, both the charts have been combined, and right click over here and say synchronize axis. Okay, okay, so now if you can see right, in 2017 you had 2303 Netflix releases across all categories and 1159 titles, right, 1063 titles in 2017. So this is a
descending representation of the count of titles released per year across category and across titles. So let's call this as per year stats. Now let's create another report. Number of shows per title. Okay. So, or sorry, per rating. So we will drag the rating column and we will count of titles and unique count of titles and unique count of show IDs. Okay. One is bar and one is line. Okay. So this is a report which shows rating wise titles and the show IDs. So in the tooltip, you can see the distinct count of titles and show ID per rating. Okay, so let's call it shows per rating. Now let's create another sheet, call it as shows by cast. So in this, what we're going to do is first drag the cast column on the rows section. You have name of all the cast, and then we drag the show ID on the column section and put a count D and sort it. Okay. You can remove the null cast, and this is your sorted order. And on the labels section, you can say show mark labels, and you will see the count that Anupam Kher has done the maximum, then Shah Rukh Khan, Om Puri, Nasruddin Shah. So this is the details on the sorted order, that who has done how many shows. Okay. Then next is shows by director, similar to shows by cast. Drag director into rows, or differently if you want to prepare, into columns, and then count of show ID, okay, sort it, and you can actually filter out the null director value. And this is your count. Put the label. So you can see Jan's sweater has the maximum shows. Okay. Then create another report, shows by category. Now similarly drag the listed in the rows and show ID count, remove the null category and sort. Labels, show mark labels. So international movies are the highest category, dramas the next, comedy, international TV shows. This way you have your category. Now let's create a dashboard in which we want to combine all these reports and take a common view. So first let's drag listed in by country, then shows by director. Also please let's set the size as automatic. Then let's drag shows by category and shows by cast. Now these 4 reports are on a single dashboard. We will link them to each other. So go to worksheet, actions, add action, filter, select dashboard 1, only select shows by category here, and in target dashboard 1 except shows by category keep everything else, and in the source sheet just select, click OK. Now whatever category you will select over here, that related category data will automatically be shown in other reports, like see international movies across the globe, across the countries, directors of only international movies, who has done the maximum, Johnny To, and shows by cast, right, that who has done the maximum international movies or dramas or comedies. See, Paresh Rawal has the maximum number of comedies, and then if you see the comedy movies, these are the count of comedy movies released across the countries and who is the director. Another very interesting report which you can prepare is that, for example, you want to check in which country maximum duration of your movies have been released. So first let's create convert to measure, remove this. Okay. So if you see, maximum duration of the movies or the entire Netflix content is maximum United States, then in India these many minutes, next is United Kingdom, and you can also change the colors. Whatever you feel is as per your standards or as per the convention, you can change the color combination. So there are multiple ways you can generate reports, and hope you have understood how you can leverage such a data to create your reports.
Hello and welcome to Data Analytics Interview Questions. My name is Richard Kirshner with the Simplilearn team. That's www.simplilearn.com. Get certified, get ahead. Today we're going to jump into some common questions you might see on Numpy arrays and Pandas data frames in the Python, along with some Excel, Tableau, and SQL. Let's start with our first question. What is the difference between data mining and data profiling? It's real important to note that data mining is a process of finding relevant information which has not been found before. It is a way in which raw data is turned into valuable information. You can think of this as anything from the sales stats and from their SQL server all the way to web scraping and Census Bureau information. Where the heck do you mine it from? Where do you get all this data and information? Then we look at data profiling is usually done to assess a data set for its uniqueness, consistency, and logic. It cannot identify incorrect or inaccurate data values. So if somebody has a statistical analysis on one side and they're doing you might the wrong data to then program your data setup. So you got to be aware that when you're talking about data mining, you need to look at the integrity of what you're bringing in, where it's coming from. Data profiling is looking at it and saying, hey, how is this going to work? What's the logic? What's the consistency? Is it related to what I'm working with? Define the term data wrangling and data analytics. Data wrangling is a process of cleaning, structuring, and enriching the raw data into a desired usable format for better decision making. And you can see a nice chart here with our discover it. We structure the data how we want it. We clean it up, get rid of all those null values. We enrich it, so we might take and reformat some of the settings. Instead of having 5 different terms for height of somebody, in American, English, or whatever, we clean some of that up, and we might do a calculation and bring some of them together. And validate. I was just talking about that in the last one. You need to validate your data. Make sure you have a solid data source. And then, of course, it goes into the analysis. Very important to notice here in data wrangling, 80% of data analytics is usually in this whole part of wrangling the data, getting it to fit correctly. And don't confuse that with data cooking, which is actually when you're going into neural networks, cooking the data so it's all between 0 and 1 values. What are common problems that data analysts encounter during analysis? Handling duplicate and missing values, collecting the meaningful right data the right time, making data secure and dealing with compliance issues, handling data purging and storage problems. Again, we're talking about data wrangling here. 80% of most jobs are in wrangling that data and getting it in the right format and making sure it's good data to use. Number 4, what are the various steps involved in any analytics project? Understand the problem. We might spend 80% doing wrangling, but you better be ready to understand the problem, because if you can't, you're going to spend all your time in the wrong direction. This is probably the most important part of the process. Everything after it falls in, and then you can come back to it. 2, data collection, data cleaning. Number 3, 4, data exploration analysis, and 5, interpret the results. Number 5 is a close second for being the most important. If you can't interpret what you bring to the table to your clients, you're in trouble. So when this question comes up, you probably want to focus on those 2, noting that the rest of it does, 80% of the work is in 2, 3, and 4, while 1 and 5 are the most important parts. Which technical tools have you used for analysis and presentation purposes? Being a data analyst, you are expected to have knowledge of the below tools for analysis and presentation purposes. There's a wide variety out there. SQL Server, MySQL, you have your Excel, your SPSS, which is the IBM platform, Tableau, Python. You have all these different tools in here. Now, certainly a lot of jobs are going to be narrowed in on just a few of these tools. Like, you're not going to have a Microsoft SQL Server and MySQL Server, but you better understand how to do basic SQL polls, and also understanding Excel and how the different formats for column and how to get those set up. Number 6, what are the best practices for data cleaning? This is really important to remember to go through this in detail. These always come up because 80% of most data analysis is in cleaning the data up. Make a data cleaning plan by understanding where the common errors take place and keep communications open. Identify and remove duplicates before working with the data. This will lead to an effective data analysis process. Focus on the accuracy of the data, maintain the value types of data, provide mandatory constraints, and set cross-field validation. Standardize the data at the point of entry so that it is less chaotic, and you will be able to ensure that all the information is standardized, leading to fewer errors on entry. Number 7, how can you handle missing values in a data set? Listwise deletion. In listwise deletion method, entire record is excluded from analysis if any single value is missing. Sometimes we're talking about records. Remember, this could be a single line in a database. So if you have your SQL comes back and you have 15 different columns, every one of those that has a missing value, you might just drop it just to make it easy because you already have enough data to do the processing. Average imputation. Use the average value of the responses from the other participants to fill in the missing value. This is really useful, and they'll ask you why these are useful, I guarantee it. If you have a whole group of data that's collected and it doesn't have that information in it, at that point you might average it in there. Regression substitution. You can use multiple regression analysis to estimate a missing value. That kind of goes with the average imputation input. Regression model means you're just going to actually generate a prediction as to what you think that value should be for those people based on the ones you do have. Multiple imputation. So when we talk about multiple inputs, it creates plausible values based on the correlations for the missing data, and then averages the simulated data sets by incorporating random errors in your predictions. What do you understand by the term normal distribution? And the second you hear the word normal distribution, should be thinking a bell curve like we see here. Normal distribution is a type of continuous probability distribution that is symmetric about the mean, and in the graph, normal distribution will appear as a bell curve. The mean, median, and mode are equal. That's a quick way to know if you have normal distribution, is you can compute mean, median, and mode. All of them are located at the center of the distribution. 68% of the data lies within one standard deviation of the mean. 95% of the data falls within 2 standard deviations of the mean. 99.7% of the data lies within 3 standard deviations of the mean. What is time series analysis? Time series analysis is a statistical method that deals with ordered sequence of values of a variable of equally spaced time intervals. Time series data on a COVID-19 cases. And you can see we're looking at by days, so our space is of days, and each day goes by. If we take and graph it, you can see a time series graph always looks really nice if you have like 2 different, in this case we have the United States going over there. I'd have to look at the other setup in there, but they picked a couple different countries. And it's time sensitive. With the next result is based on what the last one was. COVID's an excellent example of this. Anytime you do any word analytics where you're figuring out what someone's saying, what they said before makes a huge difference as to what they're going to say next. Another form of time series analysis. 10. How is joining different from blending in Tableau? So now we're going to jump into the Tableau package. Data joining. Data joining can only be done when the data comes from the same source. Combining 2 tables from the same database or 2 or more worksheets from the same Excel file. All the combined tables or sheets contains common set of dimensions and measures. Data blending. Data blending is used when the data is from 2 or more different sources. Combining the Oracle table with the SQL server, or 2 sheets from Excel, or combining Excel sheet and Oracle table. In data blending, each data source contains its own set of dimensions and measures. How is overfitting different from underfitting? Always a good one. Overfitting. Probably the biggest danger in data analytics today is overfitting. Model trains from the data too well using the training set. The performance drops significantly over the test set. Happens when the model learns the noise and random fluctuations in the training data set in detail. And again, the performance drops way below what the test set has. The model neither trains the data well nor can generalize to new data. Performs poorly both on train and the test set. Happens when there is less data to build and an accurate model, and also when we try to build a linear model with a nonlinear data. In Microsoft Excel, a numeric value can be treated as a text value if it proceeds with an apostrophe. Definitely not an exclamation. If you're used to programming in Python, you'll look for that hash code, and not an amber sign. And we can see here, if you enter the value 10 into a field, but you put the apostrophe in front of it, it will read that as a text, not as a number. What is the difference between count, count A, count blank, and count if in Excel? We can see here when we run in just count, D1 through D23, we get 19. And you'll notice that there is 19 numbers coming down here. And so it doesn't count the cost of each, which is the top bracket. It doesn't count the blank spaces either with the straight count. When you do a count A, you'll get the answer is 20. So now when you do count A, it counts all of them, even the title cost of each. When you do count blank, we'll get 3. Why? There's 3 blank fields. And finally, the count if. If we do count if of E1 to E23 is greater than 10, there's 11 values in there. Basic counting of whatever's in your column, pretty solid on the table there. Explain how VLOOKUP works in Excel. VLOOKUP is used when you need to find things in a table or arrange by row. The syntax has 4 different parts to it. We have our lookup value, that's a value you want to look up. We have our table array, the range where the lookup value is located, column index number, the column number and range that contains the return value, and the range lookup. Specify true if you want an approximate match or false if you want an exact match of the return value. So here we see VLOOKUP F3 A2 to C8 2, 0 for prints. Now they don't show the F3. F3 is the actual cell that prints is in. That's what we're looking at is F3. So there's your prints. He pulls in from F3. A2 to C8 is the data we're looking into. And then number 2 is a column in that data. So in this case, we're looking for age. And we count name as 1, age as 2. Keep in mind this is Excel versus a lot of your Python and programming languages where you start at 0. In Excel, we always look at the cells as 1, 2, 3. So 2 represents the age. 0 is false for having an exact matchup versus 1. We don't actually need to worry about that too much in this. 0 or 1 would work with this example. And you can see with the Angela lookup, again, her name would be in the F column number 4. That's what the F4 stands for, is where they pulled Angela from. And then you have A1 to C8, and then we're looking at number 3. So number 3 is height, name being 1, age 2, and then height 3. And you'll see here it pulls in her height 5.8. So we're going to jump over to SQL. How do you subset or filter data in SQL? To subset or filter data in SQL, we use where and having clause. And you can see we have a nice table on the left where we have the title, the director, the year, the duration. We want to filter the table for movies that were directed by Brad Bird. Why? Just because we want to know what Brad Bird did. So we're going to do select star. You should know that the star refers to all. In this case, what are we going to return? We're going to return all title, director, year, and duration. That's what we mean by all. From movies, movies being our table, where director equals Brad Bird. And you can see he comes back and he did The Incredible and Ratatouille. To subset or filter data SQL, we can also use the where and having clause. So we're going to take a closer look at the different ways we can filter here. Filter the table for directors whose movies have an average duration greater than 115 minutes. So there's a lot of really cool things into this SQL query, and these SQL queries can get pretty crazy. Select director, sum duration as total duration, average duration as average duration from movies, group by director having average duration greater than 115. So again, what are we going to return? We're going to return whatever we put in our select, which in this case is director. We're going to have total duration, and that's going to be the sum of the duration. We're going to have the average duration, average underscore duration, which is going to be the average duration on there. And then we, of course, go ahead and group by director. And we want to make sure we group them by anyone that has having an average duration greater than 115. These SQL queries are so important. I don't know how many times the SQL comes up, and there's so many different other languages, not just MySQL and not Microsoft SQL, but in addition to that, where the SQL language comes in, especially with Hadoop and other areas. So you really should know your basic SQL. Doesn't hurt to get that little cheat sheet and glance over it and double check some of the different features in SQL. What is the difference between where and having clause in SQL? Where clause works on row data. In where clause, the filter occurs before any groupings are made. Aggregate functions cannot be used. So the syntax is select your columns from table where what the condition is. Having clause works on aggregated data. Having is used to filter values from a group. Aggregate functions can be used, and the syntax is select column names from table where the condition is, grouped by, having a condition ordered by column names. What is the correct syntax for reshape function in Numpy? So we're going to jump to the Numpy array program, and what you come up with is you have, in this case it'd be numpy.reshape. A lot of times you do an import numpy as np, reshape, and then your array and the new shape. And you can see here as the actual example comes in, the reshape is A, and we're going to reshape it in 2, 5 setups, and you can see the printout in there that prints in 2 rows with 5 values in each one. What are the different ways to create a data frame in Pandas? Well, we can do it by initializing a list, so you can import your Pandas as PD, very common. Data equals Tom 30, Jerry 20, Angela 35. We'll go ahead and create the data frame, and we'll say pd.dataframe is the data, columns equals name and age. So you can designate your columns. You can also designate index in there. You should always remember that the index, in this case, maybe you want the index instead of 1, 2 to be the date they signed up, or who knows, whatever. And you can see right there, it just generates a nice Pandas data frame with Tom, Jerry, and Angela. Another way you can initialize a data frame is from dictionary. You can see here we have a dictionary where the date equals name, Tom, Jerry, Angela, Mary. Age is 20, 21, 19, 18. And if we do a df pd.dataframe on the data, you'll get the same kind of setup. You get your name, age, Tom, Jerry, Angela, and Mary. Write the Python code to create an employee's data frame from the emp.csv file and display the head and summary of it. To create a data frame in Python, you need to import the Pandas library and use the read CSV function to load the CSV file. And here you can see we have import pandas as PD, employees, or the data frame employees, equals pd.readcsv, and then you have your path to that CSV file. There's a number of settings in the read CSV where you can tell it how many rows are the top index. You can set the columns in there. You can have skip rows. There's all kinds of things. You can also go in there and double check with your read CSV, but the most basic one is just to read a basic CSV. How will you select the department and age columns from an employee's data frame? So we have import pandas as PD. You can see we have created our data. We will go ahead and create our employees PD data frame on the left. And then on the right, to select department and age from the data frame, we just do employees, and then you put the brackets around it. Now, if you're just doing one column, you could do just department. But if you're doing multiple columns, you got to have those in a second set of brackets. So it's got to be a reference with a list within the reference. What is the criteria to say whether a developed data model is good or not? A good model should be intuitive, insightful, and self-explanatory. Follow the old saying, KISS, keep it simple. The model developed should be able to easily consumed by the clients for actionable and profitable results. So if they can't read it, what good is it? A good model should easily adapt to changes according to business requirements. We live in quite a dynamic world nowadays, so that's pretty self-evident. And if the data gets updated, the model should be able to scale accordingly to the new data. So you have a nice data pipeline going where when you get new data coming in, you don't have to go and rewrite the whole code. What is the significance of exploratory data analysis? Exploratory data analysis is an important step in any data analysis process. Exploratory data analysis, EDA, helps to understand the data better. It helps you obtain confidence in your data to a point where you're ready to engage a machine learning algorithm. It allows you to refine your selection of feature variables that will be used later for model building. You can discover hidden trends and insights from the data. How do you treat outliers in a data set? An outlier is a data point that is distant from other similar points. They may be due to variability in the measurement or may indicate experimental errors. One, you can drop the outlier records. Pretty straightforward. You can cap your outliers data so it doesn't go past a certain value. You can assign it a new value. You can also try a new transformation to see if those outliers come in if you transform it slightly differently. Explain descriptive, predictive, and prescriptive analytics. Descriptive provides insights into the past to answer what has happened. Uses data aggregation and data mining techniques. Examples: an ice cream company can analyze how much ice cream was sold, which flavors were sold, and whether more or less ice cream was sold than before. Predictive understands the future to the answer, what could happen. Uses statistical models and forecasting techniques. Example: predicts the sale of ice creams during the summer, spring, and rainy days. So this is always interesting because you have your descriptive, which comes in, and your businesses are always looking to know what happened. Hey, did we have good sales last quarter? What are we expecting next quarter in the sales? And we have a huge jump when we do prescriptive. Suggest various courses of action to answer what should you do. Uses optimization and simulation algorithms to advise possible outcomes. Example: lower prices to increase sale of ice creams, produce more or less quantities of certain flavor of ice cream. And we can certainly, today's world with the COVID virus, because we had that on our earlier graph, you could see that as a descriptive. What's happened? How many people have been infected? How many people have died in an area? Predictive: where do we predict that to go? Do we see it going to get worse? Is it going to get better? What do we predict that we're going to need in hospital beds? And prescriptive: what can we change in our setup to have a better outcome? Maybe if we did more social distancing, if we tracked the virus. How do these different things directly affect the end, and can we create a better ending by changing some underlying criteria? What are the different types of sampling techniques used by data analysts? Sampling is a statistical method to select a subset of data from an entire data set, population, to estimate the characteristics of the whole population. One, we can do a simple random sampling, so we can just pick out 500 random people in the United States to sample them. We call it a population. In regular data, we also call that a population, just because that's where it came from, was mainly from doing census. Systematic sampling, cluster sampling, stratified sampling, and judgment or purposive sampling. Then we have our systematic sampling. That's where you're doing like using 1, 5, 10, 15, 20. Use a very systematic approach for pulling samples from the setup. Cluster sampling, that's where we look at it and we say, hey, some of these things just naturally group together. If you were talking about population, which is really a nice way of looking at this, cluster sampling would be maybe by zip code. We're going to do everybody's zip code and just naturally cluster it that way. Stratified sampling would be more looking for shared things a group has, like income. So if you're studying something on poverty, you might look at their naturally group people based on income to begin with, and then study those individuals in the income to find out what kind of traits they have. And then judgmental. That is where the researcher very carefully selects each member of their own group. So it's very much based on their personal knowledge. Jumping on to 26, what are the different types of hypothesis testing? Hypothesis testing is a procedure used by statisticians and scientists to accept or reject statistical hypothesis. We start with the hypothesis testing. We have null hypothesis and alternative hypothesis. On the null hypothesis, it states that there is no relation between the predictor and the outcome variables in the population. It is denoted by H0. Example: there is no association between patients, BMI, and diabetes. Alternative hypothesis, it states there is some relation between the predictor and outcome variables in the population. It is denoted by H1. Example, there could be an association between patients' BMI and diabetes. And that's the body mass index, if you didn't catch the BMI and you're not in medical. Describe univariate, bivariate, and multivariate analysis. A univariate analysis, it is the simplest form of data analysis where the data being analyzed contains only one variable. An example is studying the heights of players in the NBA. Because it's so simple, it can be described using central tendencies, dispersion, quartiles, bar charts, histograms, pie charts, frequency distribution tables. The bivariate analysis, it involves analysis of two variables to find causes, relationships, and correlations between the variables. Example, analyzing sale of ice creams based on the temperature outside. Bivariate analysis can be explained using correlation coefficients, linear regression, logistic regression, scatter plots, and box plots. And multivariate analysis, it involves analysis of three or more variables to understand the relationship of each variable with the other variables. Example, analyzing revenue based on expenditure. So if we have our TV ads, we have our newspaper ads, our social media ads, and our revenue, we can now compare all those together. The multivariate analysis can be performed using multiple regression, factor analysis, classification and regression trees, cluster analysis, principal component analysis, clustering bar chart, dual axis chart. What function would you use to get the current date and time in Excel? In Excel, you can use the today and now function to get the current date and time. And you can see down here with the two examples where it just equals today or equals now. Using the SUMIFS function in Excel, find the total quantity sold by sales representatives whose names start with A and the cost of each item they have sold is greater than 10. And you can see here on the left we have our actual table, and then we want to go ahead and SUMIFS. So we want the E2 through E20, B2 through B20 greater than 10. And this basically is just saying, hey, we're going to take everything in the E column and we're going to sum it up, but only those objects where the D column is greater than 10. That's what that means there. Is the below query correct? If not, how will you rectify it? Select customer ID, year, order date as order year from order where order year is greater than or equal to 2016. And hopefully you caught it right there. It's in the devil's in the details. We can't not use the alias name while filtering data using the where clause. So the correct format is all the same except for where it says where the year order date is greater than or equal to 16 versus using the order year, which we assign under the select setup. How are union, intersect, and except used in SQL? The union operator is used to combine the results of two or more select statements. And you can see here we have select star from region 1. We're going to make a union with select star from region 2. And it basically takes both these SQL tables and combines them to form a full new table on there. So that's your union as we bring everything together. When we look at the intersect operator, it returns the common records that are the result of the two or more select statements. So you can see here we select star from region 1, intersect, select star from region 2, and we come up with only those records that are shared, that have the same data in them. And hopefully you jumped ahead to the except. The except operator returns the uncommon records that are the result of two or more select statements. So these are the two records, or the records that are not shared between the two databases. Using the product price table, write an SQL query to find the record with the fourth highest market price. So here we have a little bit of a brain teaser. They're always fun. And the first thing we want to do is we're going to go ahead and if you look at the script on the left, we really want the fourth one down. So we're going to select the top 4 from product price. But we're going to order it by market price descending. SP order by market price ascending. So what we do is we take the top 4 of the market price ascending, and that's going to give us the 4 greatest values. And then we're going to reverse that order and do descending. And we're going to take the top one of that, which is going to give us the lowest value, which will be the 4th greatest one in the list. From the product price table, find the total and average market price for each currency where the average market price is greater than 100 and currency is in the INR or the AUD. So INR or AUD, India Rupee or Australia dollar. You can see over here the SQL query. If you had trouble putting this together, you might actually do some of it in reverse. And you can see right here where the average market price is greater than 50. Remember, we use having, not where, at the end because it's part of the group. So group by currency, because we want those 2 currencies. And we want the currency India Rupee, the INR or the AUD. And as you keep going backwards, we're actually going to be selecting the currency, the sum of the market price as total price, and the average market price as average price. So there's our select. It's going to come from the product price, which is just our table over there, and then we have where our currency is in. And like I said, you can put it together however you want, but hopefully you got to the end there. So this question will test your knowledge in Tableau, exploring the different features of Tableau, and creating a suitable graph to solve a business problem. And of course, Tableau is very visual in its use, so it's very hard to test it without actually just getting your hands on. And if you can't visualize some of this and how to do it, then you should go back and refresh yourself. Using the sample superstore dataset, create a view to analyze the sales, profits, and quantities sold across different subcategories of items present under each category. So the first step is to go ahead and load the sample superstore dataset. So make sure you know how to load the sample, the superstore dataset. That's underneath either the connect button in the upper left or the Tableau icon up there, and be able to pull in the dataset. And then once you've done that, you just drag the category and subcategory on rows and salaries onto columns. It will result in a horizontal bar chart. So in this one, we're just going to drag profit onto color and quantity onto label. Sort the sales axes in descending order of sum and sales within each subcategory. And if you're at home doing this, you'll see that chairs under furniture category had the highest sales and profit, while tables had the lowest profit. For office supplies, subcategory binders made the highest profit, even though storage had the highest sales. Under technology category, copiers made the highest profit, though it was the least amount of sales. Let's work to create a dual axis chart in Tableau to present sales and profits across different years using sample superstore dataset. Load the orders sheet from the sample superstore dataset. Drag the order data field from the dimensions onto columns and convert it into continuous month. Drag cells onto rows and profits to the right corner of the view until you see a light green rectangle. One of those things, if you haven't done this hands-on, you don't know what you're doing, you're going to run into a bind because you're going to be just kind of dropping it and wondering what happened. Synchronize the right axes by right-clicking on the profit axis. And then let's finalize it by going under the marks card, change some cells to bar and some profit to line, and adjust the size. And then we have a nice display that we can either print out or save and send off to the shareholders. Let's go ahead and do one more Tableau. Design a view in Tableau to show state-wise sales and profits using the sample superstore dataset. In here you go ahead and drag the country field onto the view section and expand it to see the states. Drag the states field onto size and profit onto color. Increase the size of the bubbles, add a border and a halo color. States like Washington, California, and New York have the highest sales and profits, while Texas, Pennsylvania, and Ohio have a good amount of sales but the least amount of profits. We'll go ahead and skip back to Python Numpy. Suppose there is an array number equals NP, or Numpy if you're using Numpy, depending on how you set it up, dot array, and we just have 1 to 9 broken up into 3 groups. Extract the value 8 using 2D indexing. So you can see on the left we have our import Numpy as NP, number equals our NP array. If we print the number, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Since the value 8 is present in the second row and first column, we use the same index position and pass it to the array. And you just have number 2, 1, and you get 8. And remember, we're in Python, so you start at 0, not 1 like you do in Excel. Always gets me if I'm working between Excel and Python, where I just kind of flip, and usually it's the Excel that messes up because I do a lot more programming. Suppose there's an array that has values 0, 1, all the way up to 9. How will you display the following values from the array? 1, 3, 5, 7, 9. So first of all, we go ahead and create the array np.arange of 10, which goes from 0 to 9, because there's 10 numbers in it, but we don't include the 10. We print it out. The first thing you want to do is, what's going on here with 1, 3, 5, 7, 9? Well, if we divide by 2, there's going to be a remainder equal to 1. And then from Python, remember that if you use the percentage sign, you get the remainder on there. So the remainder is 1. And then you have your Numpy array, and then we just want to do a logical statement of all values that have a remainder of 1, and that generates our nice 1, 3, 5, 7, 9. There are 2 arrays, A and B. Stack the arrays A and B horizontally. Boy, these horizontal vertical questions will get you every time. And in Numpy, we go ahead and we've created 2 different arrays over here, A and B. The first one is your concatenate, np.concatenate A and B on axes equal 1. That is the same as hstack. And in the back end, they're still identical. They run the same. That's all hstack is, a concatenate axes equals 1. How can you add a column to a Pandas data frame? Suppose there's an imp data frame that has information about few employees. Let's add address column to that data frame. And you can see on the left we have our basic data frame. You should know your data frames very well. Basically it looks like an Excel spreadsheet. As you come over here, it's really simple. You just do df of address equals the address once you've assigned values to the address. Using the below given data, create a pivot table to find the total cells made by each cells represented for each item. Display the cells as a percentage of the grand total. So we're back in Tableau. Select the entire table range, click on Insert tab, and choose Pivot Table. Select the table range and the worksheet where you want to place the pivot table. It will return a pivot table where you can analyze your data. Drag the cell total on the values in sales rep and item onto row labels. It will give the sum of the cells made by each representative for each item they have sold. And finally, right-click on Sum of Cell Total and expand Show Values as to select Percentage of Grand Total. Real important just to understand what a pivot table is. We're just pivoting it from rows and columns and switching this direction on there. And finally, we have our final pivot table, and you can see the values, roles, and sum of total sale. So we're going to go ahead and take a product table. This is off of an SQL, so we're going to do some SQL here. And we're going to use the product and sales order detail table. Find the products that have total units sold greater than 1.5 million. And here's our sales order detail table. So we have a product table and a sales order detail table, 2 separate tables in the database. And what we're going to do is put together the SQL query. We want to select PP name, sum, SOD, unit price as cells. And then we have our pp.product ID from production product as pp inner join, cells.sales order detail as SOD on pp product ID equals SOD.product ID, group by pp.name, pp.product ID having a sum of SOD.unit price greater than the 150 million there. That's a mouthful. And again, these SQL queries, they start looking really crazy until you just break them apart and do them step by step. And what we're looking for is the inner join and how did you do the group by. That's really what they know. How do you do this inner join? This comes up so much in SQL. How do you pull in the ID from one chart and the information from another chart and the sum totals on that chart? How do you write a stored procedure in SQL? Let's create a stored procedure to find the sum, the squares of the first n natural numbers. So here we have our formula, n times n plus 1 times 2n plus 1 over 6. And you can see from the command prompt or the setup you have, depending on what your login is, the command is create procedure square sum 1. Declare our variable at n of integer as begin, and then we're going to declare the sum of integer, set sum equals n times n plus 1 plus 2 times n plus 1 over 6. And then of course we can go ahead and print those out. Print first cast ampersand n, or our variable, as a variable character 20 natural numbers. Print the sum of the square is cast the at sum as variable character 40 end. And then we do the output, display the sum of the square for first 4 natural numbers. We have execute square sum 1, and then we're going to put in 4, and you can see here where it brings up the first 4 natural numbers. Sum of square is 30. Write a store procedure to find the total even number between two user-given numbers. A couple of things to note here. First, we go ahead and create our procedure. You have your two different variables, the n1, n2. And we go ahead and begin. We're going to declare our variable count as an integer. We're going to set count equal to 0. And then we have while n is less than n2. We're going to begin. And if n1 remainder 2 equals 0, so we're going to divide it by 2, even number, begin. We're going to set the count equal to count plus 1. We're going to print even number plus cast n as a variable character 10 for printing. Count is plus cast variable count as variable character 10 end. Else print odd number plus cast variable number 1 as variable character 10. And then we go ahead and set the increment our variable 1 up 1. So it'll go from n1 all the way to n2. And it'll print the total number of even numbers. And you can see here we went ahead and executed it. We're going to count the even numbers between 30 and 45. And you can just see it goes all the way down to 8. What is the difference between tree maps and heat maps in Tableau? Now, if you've worked in Python and other programmings, you should automatically know what a heat map is. But a tree map are used to display data in nested rectangles. You use dimensions to define the structure of the tree map and measure to define the size or color of individual rectangles. Tree maps are a relatively simple data visualization that can provide insight in a visually attractive format. And again, you can see the squares over here. This is our tree map over here with each block also has its information inside of its different blocks. A heat map helps to visualize measures against the dimensions with the help of colors and size to compare one or more dimensions and up to 2 measures. The layout is similar to a text table with variations in values encoded as colors. In heat map, you can quickly see a wide array of information. And in this one, you can see they use the colors to denote one thing and the size of the little square to denote something else. A lot of times you can even graph this into a 3-dimensional graph with other data so it pops out. But again, a heat map is the color and the size. Using the sample superstored dataset, display the top 5 and bottom 5 customers based on their profit. So you start by dragging the customer name field onto rows and profit on columns. Right-click on the customer name column to create a set. Give a name to the set and select Top tab to choose top 5 customers by sum profit. Similarly, create a set for the bottom 5 customers by sum profit. Select both the sets, right-click to create a combined set. Give a name to the set and choose all members in both sets. And then you can drag top and bottom customer sets onto the filters and profit field onto color to get the desired results. As we get down to the end of our list, we're going to try to keep you on your toes. We're going to skip back to Numpy. How to print 4 random integers between 1 and 15 using Numpy. To generate random numbers using Numpy, we use the random integer function. And you can see here we did the import Numpy as np, random arrangement equals np.random integer 1 through 15 of 4. From the below data frame, going to jump again on you, now we're into Pandas. How will you find the unique values for each column and subset the data for age less than 35 and height greater than 6? To find the unique values and the number of unique elements, use the unique and the in-unique function. You can see here we just did df height, so we're selecting just the height column, and we want to look for the unique. That returns an array, where in unique, if we do that on the height or the age, we'll return just the number of unique values. And then we can do a subset the data for ages less than 35 and height greater than 6. So if we look over here, we have a new df. Remember, this is going to be taking slices of our original data frame. It doesn't actually change the data frame. So our new df equals the data frame, or df, the data frame where age is less than 35 and the height is greater than 6. And in case you're not using Tableau, which has a lot of its own different mapping programs in there, make sure you understand how to use the basics of Matplot library. Plot a sine graph using Numpy and Matplot library in Python. And the way we did this is we went ahead and generated an x. We know our y equals np.sine of x. If you print out x, you'll see a whole value here. Our Matplot library pyplot as plt. If you are working in Jupyter Notebook, make sure you understand the Matplot library inline, that little percentage sign Matplot library inline. That prints it on the page in the Jupyter Notebook. The newer version of Jupyter Notebook or Jupyter Labs automatically does that for you, but I usually put it in there just in case I end up on an older version. If you print y, you can see here we have our different y values and our different x values. You simply put in plt.plot xy and do a plot show. And before we go, let's get one more in. We're going to do a Pandas using the below Pandas data frame. Find the company with the highest average sales, derive the summary statistics for this sales column, and transpose these statistics. That's a mouthful. And just like any of these computer problems, break it apart. So first of all, we're looking for the highest average sales. So group the company column and use the mean function to find the average sales. And you can see here by company equals df.group by company. Once we've done that, using the describe function, we can now go ahead and look at the summary of statistics on here. Use the describe function to find the summary. So by company, those are groups. We're just going to describe them. And you could actually bundle those together if you wanted and just do them all in one line. So here we go, by company.describe. You can see we have a nice breakout. Always good to remember. Whether you're using any of the packages, whether it's Tableau or Pandas in Python, or even R or some other package, being able to quick look and describe your data is very important. And then we can go ahead and just do a basic apply a transpose function over the describe method to transpose the statistics. All we've done here is flip the index with the column names, but if you're following the numbers, a lot of times it's easier to follow across one line, or maybe you want to average out the count, or there's all kinds of different reasons to do that.
If you're an aspiring data analyst looking for online training and certifications from prestigious universities and in collaboration with leading experts, then search no more. Simplilearn's postgraduate program in data analytics from Purdue University in collaboration with IBM should be your right choice. For more details, use the link mentioned in the description box below.
In today's data-driven world and cutthroat business landscape, the ability to extract meaningful insights from vast amounts of information has become paramount. This is where data analytics come into play, revolutionizing the way organizations operate, make decisions, and achieve their goals. Data analytics refer to the process of collecting, analyzing, and interpreting data to uncover meaningful insights that can be used to make informed decisions. Now, with the ever-increasing amount of data available, there has never been a greater demand for analysts who can extract insights from data. As the world becomes increasingly digital, data is being generated at an unprecedented rate, creating an enormous opportunity for businesses to leverage this data to gain a competitive advantage. By leveraging data analytics, businesses can make informed decisions, better understanding their customers, and predict future trends. Whether you're passionate about data, interested in improving your job prospects, or simply want to gain a competitive advantage in this industry, learning data analytics is a valuable investment. By understanding the fundamentals of data analytics, you can gain the skills necessary to become a successful data analyst and contribute to the growth of your organization. So stay tuned with us till the end of this video as we discuss some of the amazing data analytics bootcamps you can pursue. So fasten your seatbelts as we embark on a journey into the captivating world of data analytics, where information transforms into insights and decision becomes data-driven. But before we begin, if you're new to the channel and haven't subscribed already, consider getting subscribed to Simplilearn to stay updated with all the latest technologies. And don't forget to hit that bell icon to never miss an update from us. So without any further ado, let's get started. Firstly, let us understand what is data analytics. Now, data analytics involves the exploration and examination of extensive data sets with the aim of uncovering concealed patterns, identifying previously unseen trends, establishing correlations between data, and extracting valuable insights that will enable businesses to make predictions. Now, by leveraging data analytics, businesses can enhance their operational speed as well as efficiency. Now comes the main question: why we need data analytics? The first point is improved decision making. Now, data analytics enables informed decision making by providing data-driven insights. It allows businesses to understand patterns, relationships within data, empowering decision makers to make strategic choices that will drive growth, improve efficiency, and mitigate any sort of risk. Next, better customer understanding. Now, data analytics allows you to tailor customer service according to their needs. It provides valuable insights into customer behavior, preferences, and needs. It helps businesses to segment customers, understand buying patterns, predict future actions, and personalize marketing and customer experiences. So this allows for targeted product service delivery, improved customer satisfaction, and loyalty as well. Next, we have efficient operations. Now, data analytics fosters innovation by uncovering insights, identifying market trends, and recognizing emerging opportunities. Now, by leveraging this data, organizations can develop innovative products by efficiently increasing their operation, existing offering, and stay ahead of the competition. It enables businesses to understand market dynamics, monitor competitors, and make data-driven strategic decisions. And finally, performance optimization. Data analytics helps optimize performance by analyzing metrics and key performance indicators. So it identifies areas for any sort of improvements, uncovers inefficiencies, and facilitates data-backed changes to enhance productivity, reduce cost, and achieve operational excellence. So these are some of the main reasons why we need data analytics. Moving forward, let us understand what exactly a data analyst do. Now, a data analyst is responsible for collecting, organizing, analyzing, and interpreting data to uncover valuable insights to make informed decisions, improve operations, and drive business growth. So let us now check in detail process of what does a data analyst do on a daily basis. The first thing is data collection. Now, a data analyst gathers data from various sources, including databases, spreadsheets, APIs, or any external sources, by ensuring data quality and accuracy. Next, we have data cleaning. Now, data cleaning and pre-processing is another important factor where a data analyst has to be consistent in. Now, he has to clean and transform the data to remove any sort of errors, inconsistencies, and missing values, and prepare the data for analysis. Now, once the data is clean, data analyst will now do a proper data modeling and analysis of that data by applying statistical methods and analytical techniques to analyze data and derive insights. This may involve hypothesis testing by using machine learning techniques like regression analysis, clustering, or other data modeling techniques. And finally, visualization and interpretation. Now, finally, we have to present the analyzed data in a visually appealing and understandable format by using charts, graphs, and dashboards, and also create reports and summaries to communicate findings to stakeholders by drawing meaningful conclusions and insights from the data analysis, providing actionable recommendations and solutions based on the finding. Now, let us discuss some of the tools that you have to master for data analytics. Now, tools such as Excel, R programming language, Python, Tableau, QLic, Power BI, SQL are some of the important tools that you have to master if you want to become proficient in data analytics. Let us now talk about the salary and job prospects. Now, according to Glassdoor, the average salary of a data analyst in USA is around $75,000 per annum, and it can go as high as $1,000 per annum. And in India, the average salary of a data analyst is around 9 LPA, and for an experienced data analyst, it can be as high as 25 lakhs per annum. Are you ready to unlock the secrets hidden within vast amounts of data and gain a competitive edge in today's cutthroat business world? Well, Simplilearn's data analyst course delivered in collaboration with IIT Kanpur will provide you with extensive expertise in the booming field of data analytics. This data analytics course at IIT Kanpur is designed to provide a deep understanding of the principles, techniques, and applications of data analytics to develop a holistic skill set to effectively analyze, interpret, and extract actionable insights from data. Now, talking about this course, it follows a structured learning path that covers various aspects of data analytics, including business analytics using Excel, SQL, programming foundation using Python, data analytics with R language, Tableau training, and much more. Some of the key features of this program include masterclasses delivered by distinguished IIT Kanpur faculty, hands-on lab experience to help you master 14+ tools and frameworks, and industry-relevant projects designed to advance your career trajectory. And also, Simplilearn's Job Assist helps you get noticed by top hiring companies and can get you hired by renowned companies like Microsoft, Google, Amazon, IBM, Goldman Sachs, and many more. So what are you waiting for? Enroll now and embark on this transformative journey with IIT Kanpur's Data Analytics course and unlock the boundless potential of data. Now, many aspiring data analysts have gained benefits from this data analytics program, and some of them have shared their feedback. You can find the testimonials by following the link to the course page in the description box below.
We have reached the end of this session on the entire Data Analytics Tools full course. Should you need any assistance, PPT, project code, and other resources used in this session, please let us know in the comment section below, and our team of experts will be happy to help you as soon as possible. Until next time, thank you and keep learning. Stay tuned for more from Simplilearn.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.